गुड मॉर्निंग रानडे साहेब. हॅलो रानडे साहेब, कॅन यू हिअर मी? हॅलो हॅलो
हाँ निंबाळकर सर, गुड मॉर्निंग.
हाँ गुड मॉर्निंग सर. हाँ
सर, give me 1 minute. Just
हाँ 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 हाँ.
are you? My voice is clear?
हाँ हाँ येस इट इज क्लिअर सर.
आणि व्हिडिओ पण ठीक आहे.
हो हो.
मी फक्त एक हे शेअर करून बघतो.
हाँ हाँ
मला डायरेक्ट शेअर आधी पीपीटी उघडू का डायरेक्ट शेअर करून हे करू?
डायरेक्ट हाँ पीपीटी उघडून शेअर करा म्हणजे.
बरं एक मिनिट.
हाँ किंवा शेअरला जाऊन मग तो पीपीटी तुम्ही ओपन केला की तिथं येऊन जाईल.
बरं एक दोन.
हाँ तुमचा दिसतोय स्क्रीन आता.
एक मिनिट, मी आता पीपीटी ओपन करतो.
हाँ हाँ
स्क्रीन दिसतो आता?
हो 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 येस सर.
जस्ट गिव मी 1 मिनिट.
हाँ हाँ हाँ
वी कॅन स्टार्ट.
हाँ येस सर.
व्हिडिओ पण दिसतोय का? हॅलो.
हाँ व्हिडिओ
ओके.
म्हणजे आता स्क्रीन दिसतोय तुमचा. पीपीटी पॉवर पॉइंट प्रेझेंटेशन दिसतोय.
ठीक आहे, पीपीटी दिसतंय ना?
हो हो हो.
एक 2 मिनिटं. जस्ट
हाँ
गिव
हाँ
मी 1
हाँ
मिनिट.
हो येस सर. अजून हे जॉईन होत आहेत पार्टिसिपंट्स.
चालेल.
हाँ
तुम्ही एक 2 मिनिटांनी मी तुम्हाला हे घेतो, मग तुमच्याप्रमाणे मग चालू करा.
हो चालेल सर.
अरे विनोद, एक काम करायचं, तुमचं बसायचं. निंबाळकर सर.
हा, गुड मॉर्निंग, बोला सर.
गुड मॉर्निंग. आतापर्यंत तुमच्या याच्यामध्ये म्हणजे ऍप्लिकेशन सॉरी रिमोट सेन्सिंग ओरिएंटेडच कोर्स आहे का काय म्हणजे?
हा, रिमोट सेन्सिंग आणि GIS ओरिएंटेड.
ओके. आणि आतापर्यंत जे लेक्चर झाले त्याच्यात साधारण काय कव्हर केलं?
हा, तर त्याच्यामध्ये आता तुम्ही कोस्टल मध्ये घेणार आहे ना? कोस्टल मधलं काही झालेलं नाहीये. रिमोट सेन्सिंगचं काल एक ठकुराल म्हणून NIH नॅशनल इन्स्टिट्यूट ऑफ हायड्रोलॉजी त्यांचं एक झालं. तर त्यांनी ते इरिगेशन मॅनेजमेंट संदर्भात ऍप्लिकेशन घेतलेलं होतं.
ओके.
हा, आणि दुसरं एक H रमेश म्हणून होते ह्याचे NIT सुरतकल.
ओके.
हा, त्यांनी सॉइल इरोजन अँड स्ट्रीम फ्लो याच्यावरती घेतलं होतं.
ओके, फाईन. आणि रिगार्डिंग म्हणजे मला विचारायचं होतं की बेसिक कन्सेप्ट ज्याला म्हणतो, जसं सॅटेलाइट, आता आम्ही कोस्टल इंजिनिअरिंग साठी सॅटेलाइट इमेजरीज आपण प्रोक्युअर करतो. तर त्या करताना किंवा त्याच्या संदर्भात कोणी काही बेसिक नॉलेज काही असं दिलेलं आहे किंवा काही कव्हर?
काही डेटा सोर्सेस वगैरे हे सांगेल, पण तुम्ही हे करू शकता. आपला हा एलिमेंटरीज कोर्स आहे, तर तुम्ही त्याचं बेसिक हे घेऊ शकता.
कारण मी थोडंसं इमेज प्रोसेसिंग वरही थोडासा भर देणार आहे. ऍप्लिकेशन तर देणारच आहे, कारण आपल्याकडे वेळ आहे. त्यामुळे ऍप्लिकेशन वर तर देणारच आहे, पण ऍट द सेम टाइम इमेज प्रोसेसिंग वर पण थोडासा, म्हणजे ते कन्सेप्ट क्लिअर झाले की ऍप्लिकेशन लगेच आपल्याला दाखवते.
चालेल सर. ओके, तर मग शॅल वी स्टार्ट?
येस, तुमचं जर पार्टिसिपंट रेडी असेल तर स्टार्ट
आहेत.
करूया.
आता 41 आलेले आहेत, येतील म्हणजे ते आपण आय थिंक विल स्टार्ट.
अदरवाइज
मी
एक 2 मिनिटं.
इंट्रोड्यूस करतो आधी तुम्हाला. See, good morning everyone. Today we are starting with today's first session. Today our today's guest is Mr. Shashank Ranade, who is working in Central Water and Power Research Station, Khadakwasla, Pune, and he is working as scientist E. He did his MTech Electronics and Telecom Communication, and completed Bachelor.
सर आवाज
In 1990. Last 30 years, he is working in the areas of hydraulic instrumentation, that is sensors, data loggers, data analysis, uh, system including software development, random sea wave generation system, and remote sensing and GIS. In addition to this, he looks after the e-governance activities in the e-procurement and e-office and e-HRMS, etc. Sri Ranade has completed more than 30 projects in remote sensing and GIS applications in coastal and river engineering. Instrumentally, he is involved in the laboratory setup for remote sensing application in CW Paris. He is also nodal officer for National Hydrology Project and e-governance. Sri Ranade is also working as team leader in NHP for instrumentation, automatic weather station, rain gauges, in hydro meteorological instruments, along with data logger and telemetry under National Hydrology Project. He is involved in establishing testing laboratory for these instruments, and he has published about 22 papers in international and national symposium journals, etc. So we have a very learned speaker today, and you will definitely get benefited with his session. So I request Ranade sir to continue with his session.
Thank you, Professor Nimbalkar, for kind words. And good morning, everybody, participants. You can see by PowerPoint, right? Sir, this time?
Oh, yes, sir.
Okay, fine. Thank you. With this kind introduction, we'll start today's topic, applications of remote sensing in coastal engineering. As your course is designed for water resources, I may upon, it depends on the time, I may touch upon few applications in river engineering or water resources also. But let us see how the time will permit. Before proceeding to our topics, I will be covering first of all the introduction of remote sensing. See, if we switch over directly to the application, then it may be difficult to understand how we have arrived for these applications. So prior to that, we will have some brief about the introduction of the remote sensing. What are the remote sensing satellite? Because this information is required to have while ordering the satellite imageries, because we require to take this satellite imageries in the digital format nowadays. Earlier it used to give in a photographic format as well as digital format. From the only one agency it is supplied us in India is National Remote Sensing Agency or National Remote Sensing Center at Hyderabad, NRSC. I will briefly give the details how we can order these imageries over there and all other things. But we will see. For that we require a few things. We should know the few things about the how are the remote sensing satellite, how their orbit, they are running in the orbit, and what is the swath and other few basic things. Then what are the satellite sensors? Remote sensing satellite sensors are available. We should know, because while ordering these images, we should able to understand in detail. Then little bit knowledge about the image processing, and then what are the Indian remote sensing and foreign remote sensing satellites are available or their imageries are available. With this, then we will switch over to coastal engineering application, few river engineering application. Today I will not touch upon reservoir sedimentation, but time permits, I will cover the river engineering applications. Having said that, before switching over to the directly subject, I would like to introduce, first of all, I will thanks to Bharati Vidyapit and their AICT members and Professor Nimbalkar for inviting me to give this lecture amongst you. Similarly, I will also thanks to my director, CWPRS, Shri A.K. Agarwal sir, for permitting me to allow this lecture. So before coming to this lecture, before starting this lecture, I would like to introduce our organization. See, this is a new technology. Because of pandemic, we are giving the lecture through through webinars or through remotely. But when it would have been conducted uh, in the campus, you definitely would have visited to CWPRS organization. For civil engineering application, this is one of the best organizations. So I will just give the brief about our organization, and then we will switch over to our subject. At any point, Professor Nimbalkar sir, at any point, any doubts are there, you participant can ask. And if there is interruption in the link, sir, Professor Nimbalkar sir, please interrupt me that time, because
yes sir. Yes sir.
इथून काहीच कळत नाही, because whether I am speaking, but if there is an interruption, please call me on the mobile also, if it is directly communication not possible.
Okay sir.
So because I have alternate arrangement also there, laptop and everything communication, but I hope things will not require for alternate arrangement.
Yes sir.
Yeah. So being said that Central Water Power Research Station CWPRS, I am not included our organization slides because it will take more time. So just I will briefly tell you about my organization. It is a 106-year-old organization. It's a central government, purely central government organization working. We are working under Ministry of Jal Shakti. So Central Water and Power Research Station situated at Pune, near Khadakwasla Dam. It's a 106-year-old institute. And having said that, we have the various disciplines like river engineering, river reservoir and system modeling, reservoir apparatus and structure. Anuja, reservoir apparatus and structure, coastal and offshore engineering, foundation and structures, applied earth science, and to cater all these 6-7 disciplines, instrumentation, calibration, testing, and services. So, in fact, we are doing the physical models in our we are having, those who have visited our organization definitely know what are the physical model. It is not a table model. Physical model means, if you take the example of Mumbai port, yeah, Jawaharlal Nehru Port Trust, JNPT, so that particular Mumbai area has been replicated on a model by 100 meters. That model is 100 meter by 50 meter, 100 meter in length, 50 meter in width, and we are simulating the sea waves, generating the sea waves, and how the sea waves are affected to the coastal area. Studies are going on that particular model. This is the one model. Similar, we have the all major port, then river engineering models CWPRS is having. So with the large area, with 600 acres area, it is situated near Khadakwasla Dam, and water we are getting for this running the model, water from the Khadakwasla Dam. So this is a brief about the CWPRS. And apart from river coastal engineering, we are having the foundation. We are studying the soil. We are studying. We have the having the division of concrete testing, soil testing, earthquake engineering, seismology. Then instrumentation for calibration of pumps, calibration of current meter, calibration of recently we are nodal agency for the National Hydrology Project, in which automatic weather stations, rain gauges, then DWLR, surface water level measurement. All these instruments will be installed at various sites by the state agency, and CWPRS will be giving them as a guidance to how to operate, how to calibrate, and how to repair. So because CWPRS is having a multidisciplinary organization, having the basically it's a civil engineering organization, but well supported by the instrumentation engineer as well as the mechanical engineers also. So with this, I will start my today's topic. First of all, what is remote sensing? As you are aware that obtaining information about an object, area or phenomena without physically coming into the contact is called as a remote sensing. Here you can say this is an object, these are the building, trees, and the image is captured by this satellite, that is called as a remote sensing. Now take the simple example, a photographer taking a picture of any function is also a kind of remote sensing, because that object is captured by the photographer in his camera. Now, what are the source of the light? That may differ. If it is an indoor shooting, then source of the light is tube light in that room. Now, for remote sensing, the source of the light will, one of the sources of the light will be sun rays. The sun rays are reflected through the object and it is captured by the satellite. This phenomena is called as a remote sensing. Now, you may aware we have already learned about there are two types of satellites are in the Earth. They are called as a remote sensing satellite and and geostationary satellite. First of all, I just want to give the difference between these two satellites. First satellite is a geostationary satellite. Geostationary satellite is basically used for the communication purpose and the meteorological application purpose. The reason behind that, I will say this satellite is a stationary with respect to Earth. What does it mean? It means that satellite rotates around the Earth with the same speed as the speed of the Earth. Naturally, when it should rotate around the Earth with the same speed, it should be at high altitude as of 36,000 kilometers above the Earth. That's why it can look. So what does it means? It looks particular area by 24/7. Suppose Indian stationary geostationary satellite launched by the India government, that is INSAT satellite, they are always looking towards the Indian regions, so that these satellites are best useful for the communication purpose. All our communication call, suppose I am calling from here to Delhi, it is routed through satellite, that is geostationary satellite. Of course, there are other communication protocols are also there, but one of the media will be a satellite. Similarly, weather forecasting, these satellites are useful because it is always look towards the Indian region. However, since it is being placed above 36,000 kilometers above the Earth, these satellites are not useful for the remote sensing purpose. The reason behind this, the picture captured by this satellite will not be as clearer, or resolution will not, in technical word, resolution will not be as higher as it will be very coarse. So you will not get the detailed information. Then what is the other alternative? Other alternative is near Earth polar orbit satellite. It is a much lower altitude, range between few hundred to few thousand kilometer. Typically, it is 900 to 1200 kilometer above the Earth. But the problem of this satellite, because this satellite will continuously rotates around the Earth, so it will not come to that place or above the India. If you want to take the pictures of the above the Indian region, it will take after first picture. If it takes today, then after 21 or 22 days only it will come back on this particular area. But the sensor with higher resolution can be used. It is useful for remote sensing, and most important thing, it is a sun synchronous. What do you mean by sun synchronous? At all points at given latitude will have the same local mean. Uh, this is a technical definition, but in short, if that satellite moves around above the Indian region, suppose today at 10:30 a.m., so in the next visit it will come exactly at 10:30 a.m. only. Why? now all remote sensing satellite are sun synchronous. What may be the reason? As an engineer, as a scientist, if you think what will be the major reason, the reason behind that, you can come see remote sensing applications is nothing but comparing two imageries, three imageries, or more imageries. So suppose if you take one imagery in the morning and another imagery in the evening or in the afternoon, then you cannot compare these imageries because the light illumination will be different. Or I will say it will be difficult to compare these imageries. Similarly, it will be difficult to analyze these imageries as the light intensity will be different. So to avoid that, and for the technical reason also, these satellites are sun synchronous, means it will pass over the Indian region at 10:30 am all the time. Similarly, these satellites are useful to capture not only Indian region picture, it will capture all the pictures moving when he is moving around the globe. I think PPT is slightly slow. Kindly. प्रोफेसर निंबाळकर सर.
हा सर.
एक दोन मिनिटं.
हा
दिसतंय ना?
हो दिसतोय, पण पुढे आता पुढची स्लाइड
जात नाही. तेच एक दोन मिनिट. So to understand this, what is swath? Because the satellite is moving, revolves around the earth, sensor sees a certain portion. Now see here this satellite. Can you see my cursor? This is a particularly when I am moving this cursor, this is a swath. Sorry, Nimbalkar sir.
हाँ सर दिसतोय कर्सर इज सीन
moving. ठीक है. So this portion what the satellite see is called as a swath. Then what is satellite orbit? Well, see, normally all these satellites are moving from north to south. All remote sensing satellites are moving around the earth from the majority north to south. The path followed by the satellite, it referred as a orbit. Satellite orbit are matched to the capabilities and objective of the sensor that they carry. Each satellite will have the sensor payload. I will give the details about that sensor payload also, because while ordering the imageries, we need to understand this sensor payload. Orbit selection can vary in terms of altitude, their height above the earth of the surface, and their orientation. Normally, these are slightly oriented by a few 15 to 20 degrees to the north. Now, what is polar orbit? Generally, remote sensing satellite are low Earth orbit satellite. I already told you. It is several hundreds of. It is about Earth, about 900 kilometers. Most remote sensing satellite follow the polar orbit path. What is polar orbit path? This satellite is moved around the Earth from north to south, and the Earth is moving from west to east. So that one rotation is called as a polar orbit. Maximum area of data acquisition exploiting the Earth rotation. See, these are the polar orbit, or this is called as a polar orbit.
सर हेलो रानडे सर हेलो हॅलो. काय झालं?
सर येतो ऐकू? हा सर. हो, फक्त मला शेअर नाही दिसत आहे. तुम्ही जरा शेअरचा ऑप्शन द्या. मी तुला मेल पाठवतो. प्रिंट आउट काढायचं.
त्यांना ते परत शेअर करायला लागतं.
हा दिसलं सर. सर आवाज येतोय का?
हा सर येतोय आवाज. तुम्ही आहे ऑलरेडी आता इथे शेअर दिसताय.
मी करतो शेअर करतो.
हा.
व्यवस्थित काढून द्यायचं. मी तुला मेल पाठवतो आणि एक सेट प्रिंट काढायची. संपूर्ण सेटचे 2 सेट काढायचे झेरॉक्स. हे 3 होते. एक त्या 2 डेनला द्यायचे आणि एक आपल्या फायदा ठेवायची. सर स्क्रीन दिसतोय का आता?
हा येस सर, दिसतोय सर.
दिसतोय ना? प्लॅटफॉर्म, सेन्सर आणि इमेज.
हो दिसतोय.
ठीक आहे. Sorry for the issue. Of course, we'll run with this. So, before coming to the point, we were there. For satellite imageries, we should know what is the platform, what is the sensors, and what are the imageries. The meaningful distinction between the distinction between remote sensing, platform, sensor, and images. So, what is platform? Really, I am sincerely apologize for the delay in between because of the internet connection, but now it has restored. So, what is the platform? The craft on which the sensing device is mounted, it is called as a platform. Then, what is sensor? The sensing device or the instrument itself is called as a sensor. Then, image. The image of data acquired by the sensing device is called an image. So we will see the different various platforms available in the remote sensing applications. For example, remote sensing platforms are sensing devices from 1 meter to 36,000 kilometer height. As we say in the InSat satellite, it is 36,000 kilometer above the Earth. But 1 meter is the normal our camera or photographic camera. So these platforms are ground-based, aircraft-based, space shuttle-based, or the satellite-based. As you are aware, you are watching a cricket match or even football matches, and nowadays there are the spider cams are also there. So these are also we can call as a remote sensing platform. Now there are two types of sensors are available on the camera. One is called as a passive sensor, and another is called as an active sensor. The question will come in your mind, what is passive sensor? It is a natural light when it is available and the energy radiated by the sun reflected by any object is sensed by the satellite. This sensor is called as a passive sensor. For example, any photographic images taken at outdoor, I will without flash is called as a passive sensor. Now take the example. You will say then what will happen during the night or when there is insufficient light is not available. In such cases, sensor emits its radiation towards the target and reflected radiation emitted band are detected or measured by the microwave system that called as a active sensor. Another simple example, if we take a picture, indoor picture using a flashlight, then that particular camera is having and with the sensing element. So that particular sensor is an active sensor. Now the remote sensing, passive sensors are human eye, camera or radiometer. But active sensors are radar, sonar and laser. Because of this active sensors, many applications are available in this system. Now we have completed our first part. What are the different satellite, geostationary and near Earth polar satellite or remote sensing satellite. Now image is captured. How that image is analyzed, we will see about little bit about the digital image processing. Any digital image is representation of two-dimensional image. As you know, it is row and column. It is defined in the row and column. Even daily mobile, what we see is nothing but a sets of images defined in the rows and column. Uh, then each finite set of digital value, that is picture single element, is called as a pixel. Now take the example. This is a scene of particular where you want to represent in the computer or on the mobile. The image is taken by the camera or by imaging system and it is a represented on your screen or a mobile with the help of digitization. See, each pixel, the one dot or one square, it is named as a pixel. So this image is represented by so many rows and so many column picture. So this process is called as a digitized image. Why it is done? Because computer only understand the digitization value or digitization of the picture, not by the whole picture. Now here how computer will understand this value is he knows particular this pixel by number of number of rows and his column number or other row number and column number. Identification of the location of this pixel, row number and column number. Now the third value, whether it is a white, whether it is a black or whether it is a gray, it is represented by a particular cell, that is we call as a depth value or the intensity value. Now pixel value typically represented in the gray level, I already told you, that is also called a intensity. So original this picture is represented by the computer. आई इधर बैठ सकती originally represented by the pixel uh, and it is stored in a computer language. Now in another picture, if you see the tip of the deer is represented by pixel. Pixel that the deer is a single pixel. सर आवाज येतोय?
येतोय सर, आता येतोय.
पिक्चर पुढे जात नाही. 1-2 मिनिटं. नहीं, मैंने ये लगाया है, डोंगल लगाया। ये इसमें लैपटॉप को ये नहीं है फिर लैपटॉप को डोंगल नहीं लगा सकते। आया क्या, नेट आया क्या? नहीं, अपना सप्लाई का मेन सप्लाई का प्रॉब्लम है।
अगर इसमें होगा ना तो इसमें अपन वाईफाई कनेक्शन कैसे कर सकते हैं ना, आपका वो वाईफाई पे है ना, मैं भी वैसे करती हूँ।
सर एक 2 मिनट मैं लैपटॉप पर ट्रांसफर करते हूँ।
हाँ यस सर यस।
नहीं ये है इसका चार्जर। Okay, can you see the now, sir?
Yes, sir. It is visible.
Electromagnetic spectrum is defined now. मध्येच कुठेतरी हँग झालं होतं. ठीक आहे. हो गया. डाउनलोड नहीं किया इसमें. ठीक है. The electromagnetic spectrum is defined as the spectrum at all the types electromagnetic radiation in which each type of radiation type. Now the energy interaction with the earth of the surface. We have seen the primary source of the energy is the sun. The incident energy is reflected and sensed by the satellite, but many energies are absorbed or retransmitted from this energy. So we will not go in detail, but I want to just emphasize over here, if it is 100% incident energy is there, hardly 10% are get reflected or sensed by the remote sensing satellite. So important part is our sensors should be such a powerful that 10% reflected energy can be sensed effectively. Now, particularly if you say this is the electromagnetic spectrum, gamma rays, X-rays, ultraviolet rays, infrared, radar, FM, TV, and so on, so on. But only visible light is from 0.4 micrometer to 0.8 micrometer wavelength. In that wavelength, only visible light is possible, and remote sensing applications or sensors are used. This. Why this? Will be answered in the next picture. Now, if you see, this is the atmosphere, and where all spectrum of the light is available, but transparency through atmosphere is 100% possible in only visible range, that is 0.4 micrometer to 0.8 micrometer and few in infrared. So that particular spectrum is always used for remote sensing application. No other spectrum is used for remote sensing application. This slide I have kept over here, but detail I will explain in further slides. See, as I already told you, 0.4 micrometer to 0.8 micrometer, we are having the visible range, in which if we divided this band into 3 or 4 bands, because first of all, I want to emphasize the remote sensing imageries or any imageries are normally represented in gray scale. Those who knows about the principle of the TV, or earlier when it is used to, we have studied in 12th standard or even in first year engineering, there are the only black and white, or the gray is the natural color, for which when we added the 3 basic color, blue, green and red, then the picture becomes either it is a true color or the false color. What is true color and what is false color, I will explain in detail, but just keep in the mind what is the in next slide. If the picture is taken by the single camera with the wavelength of 0.4 to 0.8 micrometer, then that big picture will a black and white picture. If the same picture, now this is the black and white picture taken in a single camera from 0.4 micrometer wavelength to 0.7 micrometer. This is the sensing devices. Intensity, the difference of intensity, we can see the difference of intensity. That's why we can identify this is a tree, this is a girl having, she has weared a dress. But can you tell the color of the platform of the top, or what about sachet? No, because this is a single intensity color. If it is a 8-bit data, then 0 to 256 shades are available in this data. So 0 is black and 256 is white, or vice versa. You can assign to that, and computer could understand that is the third value. What I told you earlier, that x, y, and z value. Z is the depth or intensity of that particular value. Now instead of that, if I divide this band into 4 or 3 bands, 0.4 to 0.5 micrometer one, 0.5 to 0.6 another, and 0.6 to 0.7 third one, and a given to a color, basic color B, G, blue, green, and red. So this camera, I am having the 4 cameras in the same sensing element, and defined this is for 0.4 to 0.5 micrometer, this is for 0.5 to 0.6, this is for 0.6 to 0.7, and captured the picture and assigned the color. Now how it has changed now. When I assigned the color different, 3 different colors, 3 different intensity, using increased spectral resolution, 3 sensing wavelengths add the information about this color, RGB, and this picture becomes a 2-color image. Now in the remote sensing, this is the pan camera or single camera used in our remote sensing application, which is a black and white image with higher resolution, and this is a list 3 camera or a which is for IRS 1C and 1D satellites. Now there are true color and there are false color. As I have already told you, if we assign a blue, green, red, that is 0.4 micrometer, 7 micrometer, we have 3 different colors, 4 to 0.2, 0.5 to 0.6 green, 6 to 0.6, then it becomes a 2-color image. Instead of that, if I'm not 0.4 to 0.5, but I am using next band, red band, and near infrared band, that is 0.5 to 0.8, and divided into the 3, and assign instead of BGR, I assign green, red, near infrared color to that, then it is become a false color image. All satellite images are used as a false color image. Why? Definitely the question will come in your mind, why it is that. See this and this picture difference. Water is blue over here, it's clearly visible blue water, but here it is a bluish. I will not say it is a blue one, but it is a bluish one. Then the land portion or the vegetation portion. Barren land and vegetation land both are looks like here green or blackish. In your TV, it may be seen as a black, but here it is a blue one. When we present in color, the is shown in the and barren land, it is a red, it's a grayish things. So you can easily discriminate between land and water in false color combination in FCC image. That's why FCC image is morely used in satellite or remote sensing applications. Now in this picture, it is more clearer. The first camera used captured by in this camera is the first picture of the river. Then second camera 0.6 to 0.7 micrometer captured in red band, and the third camera 0.7 to 0.8 is the near infrared band. Now as an individual, if you see, if we are using a different spectrum, the information what we get in different cameras are also more. In this camera you can bed portion. Here the sediment is more prominent than the water. If you see this near infrared band, here the water information is more prominent than sedimentation. So each band has the peculiar information. So you can use that image as an individual band, or you can use as an image as a combination of these 3 bands, and then combination of these 3 bands is a false color composite image, that is called as a FCC. Now the applications of each band. See, if you take a first band, then in coastal application, coastal environmental or chlorophyll absorption are more prominent in the first band. If you take a second band, then the green vegetation or the rock soil discrimination is easily identified in the second band. If you take a third band, then discrimination of plants and species are easily identified in the band 3, and in the band 4, that is 0.7 to 0.86 micrometer wavelength, the delineation of water and land geomorph is more prominent. That's why band 4 is more useful for our application, or I will say for the coastal engineering applications. Having said that, we'll come to the what is the resolution, because this information is required while ordering the imageries to NRSC. What is the spatial resolution? The size of the smallest object that can be discriminated by the sensor. For example, the 1 pixel, in other words, I will say, 1 pixel represents on the earth is called as that pixel size is called as the spatial resolution. Greater the resolution, greater the data. The second is the what is the spectral resolution. What we have seen, the width of the spectral band and number of spectral bands which are the image taken, that is called as the spectral resolution. I hope spectral resolution is more clearer. Now we will see few example of the spatial resolution. What is the spatial resolution? The smallest object that can be discriminated by the sensor. Greater the resolution, greater the data. Now, this is the example. This is the first picture Indian satellite has taken on a spatial resolution of 80 meter. This was launched in 1989. India first Indian satellite was remote sensing satellite in 1989, where the spatial resolution of 80 meter. You can see the same portion when the next satellite launched in 1992 by IRS-1C in the range of 36 meter. The same portion is seen, but the size is increased as the resolution is increased. When the next satellite launch IRS-1D, the spatial resolution of 4 meter, the same area as seen over here. And when the resolution increased, spatial resolution of 6 meter, definitely the size is increased, data size will also increase, but the picture is more clearer. This is a single band picture of 6 resolution, and this is the FCC, the combination of 3 band images at the resolution of 24 meter. Now this is the area of Jawaharlal Nehru Port Trust. These are the different berths. This image is of Jawaharlal Nehru Port Trust. These are the different berths. You can see this is the Elephanta Caves. Normally Elephanta Caves we are visiting from the other side of that is the Gateway of India, which is situated this side. From there we are faring and visited to this this particular visit, Elephanta Caves. Now, how the image is acquired? As I said, the source of the sun, that is the incoming solar radiation, 70 to 80% are either absorbed or radiated. Only 10% are reflected and sensed by the satellite sensor. And this satellite sensor is continuously moving around the Earth, but in between there are ground earth receiving stations, and this satellite are transmitting all this data to nearest ground receiving station. Why it is transmitting to nearest ground receiving? There are multiple 5 to 6 ground receiving stations available at different places on the earth. Why it is? There is a limitations of the onboard tape recorder at the sensor or at the satellite. So naturally it requires to transmit that data to ground receiving station from time to time. That's why these ground receiving stations are situated at various locations. One is at near Sriharikota, one is in America, one is in Europe. So Indian satellites are downloading all these images, and these images then up from this ground receiving station are sent to the NRSC, and NRSC is distributing to national remote to different user. Now, as I told you in earlier, each picture is represented in X, Y, and third Z value. X, Y is nothing but the coordinate or represent the coordinate of the Earth. This is the image scanning and representing the X, Y, Z. Then X and Y are coordinates of that particular, and Z value is the intensity of that particular. And this image is captured by satellite and sent to the nearest ground earth station. Now, when we see the picture, this is one of the picture captured by the satellite, and one pixel is called as a digital number. Now, till now, I have told you that 23-meter resolution, 5-meter resolution, or even nowadays Google Earth images are less than 1-meter resolution. What does it means by 1-meter resolution? This pixel size will, each pixel will represent of the Earth image 1 meter by 1 meter. Here I am taking the example of 23-meter resolution pixel image. So this pixel represent on the Earth 23 meter by 23 meter. And when this picture is represented in a 3 band, band number 1, band 2 and band 3, then its intensity value shown over here, it will definitely differ in different bands, I mean to say. So here you can see it is a 67, here it is a 60, and here it is a 85. That's why we can easily discriminate band 3 is more, I will say, delineation of land and water easily, because its impression is more prominent in band 3. Now we will come to the Indian remote sensing satellite, where we get this picture from NRSC. Now we have the variety of picture, list 1, list 2, list 3, having resolution. As I told you, Indian first satellite launched in 1988 or 1989, having the resolution of 72.5 meter. Details we will see in the next picture. But later we launched in 92 36, which is having the resolution of 36.25 meter, and the latest one, Cartosat 2, having the panchromatic image of 0.8 meter. So these are the evaluation from 1989 till 2020-21. The resolution of the images has increased. Now this is IRS-1A, first launched in 1988, IRS-1B launched in 1991, having the resolution of 72.5 meter, having the information of only 4 bands, and revisit capability, that that particular satellite will move above the Indian region after 22 days only. The coverage, that is one image if you order of list 1, the coverage you will get 148 kilometer by 174 kilometer. The IRS-1C launched in 1995, having the resolution of having the sensor of list 3, having the resolution of 23.5 meter, revisit capability remains same. The image cover will be 141 by 1 kilometer. It is also having a pan image of 6.25 resolution, but the coverage will be of the pan image will be 70 kilometer by 70 kilometer. IRS-1D, see 1A, 1B are similar, 1C, 1D are similar. These details are given in my lecture notes also. Same time it is available on NRSC website. You can go through that. But I want to just tell you why these satellites are sent after few years. Behind that resolution, as the time goes, the resolution increases. That is the one of the reason. But each satellite is having its own life. So this IRS-1B, 1A and 1B were there in orbit for 5 to 6 years. Then later 1C to 1D have been launched, and they were there in orbit for this 6 years. Thereafter IRS-P4, I will just go to next slide first and then we'll come back to first. Thereafter IRS ResourceSat-1, that is called as the IRS-P5, launched in October 2003, having the list 3 image of 23 meter, but it is having a list 4 image, that is a color image of the resolution of 5.6 meter. Crossing was 10:30 AM, I already told you, and 1 by 1 kilometer. Later, the Cartosat 1 was 2000 and Cartosat 2 was launched in 2007, having the resolution of 0.8 meter. Now, if you say earlier only 8 images, that means to get 256 shades were possible of any images. Now the latest satellite having the 10 bit, or even the current satellite is having 12 bit, then 2 raised to 12 you will get the shades. So as the resolution of spectral and spatial resolution are increased over the time. Prior to that, I want to mention here that there are two foreign satellites are also available, that is Landsat and Spot. Both are having the resolution of similar to Indian satellite. In fact, India is the third or fourth country only whose remote sensing satellite are available on the earth. So we are really well in advance thanks to Dr. APJ Abdul Kalam, and prior to that those who have established both our INSAT and remote sensing satellite. Having said that, now we have covered what information, whatever the data we are for the applications. Now, how to order, how to analyze the image, now we will see in detail. Now, applications of remote sensing, there are n number of applications in remote sensing, as I was discussing with Professor Nimbalkar sir. Prior to that, NIH has given applications in soil moisture. Another speaker has given applications in different areas. I will cover the mostly applications in coastal engineering. More speaker will cover applications in different areas also. This is, I will say, remote sensing and GIS is not a story of elephant which is sensed by the four blind persons. Those knows this story because बचपन में ये story हमें बहुत बार बताई है हमारी दादी ने और दादा ने. But those who do not know, for the new generation, I will just explain in briefly. Four blind persons are told to identify the elephant. Of course, they were blind, so they don't know how the elephant. They can sense the elephant by only touching that elephant. So four different persons sense or touch the elephant and describe as an elephant. I feel those who have touched the elephant, उसने जिसके पाँव को हाथ लगाया है, he says that elephant is nothing but like a pillar, because he says that as a like a pillar. जिसने उसके पूंछ को हाथ लगाया है, he says the elephant is like a rope, because he has sense only that. जिसने he says it is like a wall. और जिसने उसके सोन को हाथ लगाया है, he says it is a bigger than rope but something different. So everybody is right. At the same time, elephant, whatever they describe, they are right because they have sensed that part. Similarly, the remote sensing software, what I use or what application I have used, I feel that is the onlyest application. No, there are n number of applications. There are direct reading applications. There are so many indirect reading applications like soil groundwater. I will not say because the water is below the water direct. There are so many direct applications. Direct are available. Using remote sensing, we can sense the potential groundwater available on the earth. So with this, I will go to the coastal engineering application where this remote sensing satellite is effectively used. The ports and harbor. As I have said earlier, CWPR is studying major 12 ports and few minor ports, where the layout the ports are designed over here. How that jetty is aligned, how that jetty direction should be there, how the sediments are moving. With respect to that, how the jetty should be constructed. Second thing, coastal processes and shoreline changes. It's a continuous phenomenon. Shoreline changes and coastal processes that can be easily detected with the help of remote sensing images. Wave studies, yes, in certain extent, wave studies are possible. Water quality studies also, I will show you one or two example of water quality studies. Then nowadays coastal zone managements are there. Up to 500 meters, there should not be any construction in the coastal zone. That management can be done. These maps can be easily derived with the help of remote sensing images. How it is used in ports and harbor, proper planning of harbor layout, various port structure and reclamation, dredging requirement in harbor basin, approach channel, dumping ground for dredging material. Similarly, these are the ports and harbor layout के लिए these are useful applications. There are many more, but only few are written over here. In coastal processes or shoreline changes, erosion and accretion. What is erosion and accretion? We will see in later part. Changes in coastal landforms, that is shoal formation or morphological changes, and these are changes are their size and shapes. Water quality studies, suspended sediment pattern. Yes, it is possible to certain level. I will not say deep suspended, but we can see pollutant dispersion easily possible. Oil slicks, yes, it is. We can easily detect with the help of these imageries. Then important part is shallow water bathymetry. Bathymetry, as you know, as we have seen the basics of remote sensing, the rays are reflected from the water can be only sensed by the satellite sensor. So deep water rays are not sensed because they are penetrated. Hence, supplement to field measurement, shallow water bathymetry up to certain 1 or 1.5 meter. Yes, shallow water bathymetry it is possible with the help of remote sensing. Then coastal zone management, monitoring changes of resource management, planning of new development or new cities or new coastal town planning. Nowadays, you have heard your city or your town planning management. You are taking the help of remote sensing as well as GIS. Now, basics of the remote sensing. Any images. What is the multispectral, multi-station, and multi-date? First, I will touch upon the multi-date. If you are observing the same area on a different date, suppose example, if you take the first image in 2000 and the last image is in 2020, then you can easily observe the change between from 2000 to 2020. What are the changes have occurred in these 20 years? That's why this is called the multi-image with multi-date. Second, multi-station. From the different position platform. Suppose on a single platform, on a single satellite, if you are having two cameras, one is on the left hand side corner, another is on the right hand side corner, you will get a multi-station imageries with two different imageries, and this is useful to observe. That is scopic image you can obtain, and you will get the height information, that is depth information. The height of the building can be possible if you are having a two images. See, all images what we see on the TV, what we see on the paper image or paper, this is a two-dimensional image. It is not a three-dimensional image. Huh? Lecture. Two-dimensional image. एक minute. Two-dimensional image are there where the third dimension is depth. We are not 3D picture is not possible, so that is only possible if we take the image with multi-station and multispectral, viewing the same area in several bands. We have seen how these bands are classified. That is called as a multispectral image. Then we will not go in this detail because normally it's required. Now, what are the remote sensing software available? IRDAS Imagine, NV, ILVIS, TNT MIPS, PCI Geomedica, and nowadays ARC Info and ArcGIS also. These are the popular softwares are available. These are the paid software. These are the not free software. But you can easily view or analyze images using QGIS. QGIS is the open source available in the universe, and you can easily sense the picture using the QGIS. Now we will come to the coastal application. Total length of the area available or coastal length is 7,506 kilometers, including group of island for the Indian region. Out of that, there are 12 major ports and 150 minor ports. Out of that, 135 is working, 15 are not working. But see, are the potential available in Indian coastal? There are 12 major ports, 35 ports. So any shoreline changes, major projects WPR has done for coastal engineering is the shoreline changes or the morphology changes. So any changes, what requires? First require a tidal data analysis. Why the tidal data analysis? Definitely I will show you in further. Then selection of particular satellite image. Then what geometric correction, subsetting, then extraction of land water boundary, and then superimposition of shoreline images. If you want to see a particular area, take a Mumbai region or a particularly Mumbai port trust, and what changes has occurred from 1992 to 2020, last 30 years, then first you require to take the imageries of 1990, 95, 2000 or 5-year interval. The question will come in your mind why you are selecting imageries of 5-year or even 10 years interval. See, shoreline changes is not a continuous phenomenon. Normally shoreline changes is a very slow phenomena. It overnight में एकदम बिल्कुल 2 मीटर shoreline अंदर आ गया, very rare case ऐसा होता है, या 10 मीटर अंदर गया, 100 मीटर अंदर आ गया, तो ये definitely it is not happen in anywhere in the world, but it is a very slow phenomena, so it can be detected only in the images of interval of 5-year or 10-year. And suppose if you find a major change, then definitely you can switch over to another imageries in between these years. So that's why selection of satellite imageries is more important. Then the question will come in your mind, why the tidal data analysis? See, when the satellite passes at 10:30 a.m. only, so that time, what will be the tide? You must know. And when you are comparing 95 image with 2005 image, both the images should be on the same tidal level or similar tidal level. Because assume करो एक इमेज आपका 0.5 मीटर टाइडल लेवल पे है and another image is 2.5 मीटर टाइडल लेवल पे है, naturally water spread will be different into these two images and you will not get a correct output. You will see that erosion has taken place or accretion has taken place because of this tidal difference. So that's why you need to you need to acquire information about the tidal data analysis, and you choose normally lowest low tide or low water tide is selected. Now you calculate what are the low tide level at 10:30 of different dates, and then go to the calendar of satellite and choose particular image from that date. Uh, then the selection of imageries. See, as I already told you, here is important if you are comparing last 25-year images. If you are analyzing imageries for river engineering or river engineering application, bank line, then you need to understand prior monsoon image and post monsoon image. Or flood has occurred, then prior to the flood and after the flood, images are more important. So that's why year, date, and month for selection of imagery important. Second thing, revisit capability. As I already told you, satellite passes after 20 days or 21 days. So old imageries are available only after 21 days only, after repetition of 20 days only. But it is possible latest imageries where Indian satellite are on the orbit. So naturally, if 4 satellites on the orbit, you will get the imageries of 5 days difference, 5 to 6. So you need to know the revisit capability of the. Then passing the IRS, particularly for shore application, you need to know few satellites are 10:30 a.m. but satellites are at 12 noon. So this satellite you should know the timing. The tidal condition, what we have already seen, it is applicable for coastal engineering. And the type of data. Earlier we used to get photographic as well as digital. Nowadays, digital imageries we are getting. Nowadays, NRSA can send a different imageries in a different band, or you want a combined imageries of a combined band also available. And the last one is resolution of imageries, whether it is a 24 meter, 5 meter, or 1 meter resolution. Then the methodology of the analysis. Now, all these imageries are available, are the raw imageries, or if you want, you can ask the geometric correction or geocoding images. What do you mean by geocoding image? Till now we have seen we are having the images of representation of coordination of x, y and z. X is nothing but the row value, y is the column value, z is the intensity of that picture. Now we didn't understand on the earth x and y coordinate. Actually all civil engineering application, since you are civil engineer, you know better than me also, it is the representation of latitude and longitude. So any due to curvature of the earth, how that satellite imageries can be represented in terms of latitude and longitude, and then it has its own meaning, and you can compare 2 or 3 different imageries, and you know the latitude and longitude. So convert a latitude longitude image is called nothing but as a geometric correction or a geocode. How it can be done? There are different ways. So left hand side uncorrected or unregistered image. When it is registered, it is a north oriented image. I will show you this unregistered image. When it is registered, north image oriented. How it done with the help of software? See, it requires only 3-point data. That is called we called as a sample data or the exact value of these 3 points of latitude and longitude. Then it can be registered with the help of software. How you can get a 3-point data? There are different ways. Earlier days, when the ground control points, when these GPS were not available, I am telling about the days of 1998, 95, 95 to 98. In this area, we used to take a topo sheet on the left hand side, and left hand side you can see the image. In topo sheet, if you see the road crossing or railway crossing are the permanent mark, and if you click the software on the topo sheet, you will get the value of latitude and longitude. Sir, can you hear me? Hello.
Hello. Sir,
Yes.
you are audible.
Yes, sir. Yes, sir.
Yes.
Getting.
Thank you.
Ah.
Earlier you to what we are feeding this topo sheet to the software as well as image to the software. Side by side, we know this particular value of the topo sheet, latitude and longitude by clicking over here. You can see it is seen over here also, and the right hand side also automatically it is registered. In this way, if we click 4 or 5 points, then this image is getting registered. That is called as a geocoding of the image. एक मिनिट परत चालू होतं. So this is one method. Another method is nowadays when the DGPS are available, exact point you know. So you can go or you can visit to that particular place and take the ground control point, and the value of that particular point you can easily identify. That is latitude and longitude, and that is fed to the computer. So this is the best method nowadays we are using. This is the second method where you can easily coordinate and you can easily identify. Now, when you are selecting the 4 points, the error should be less than point. Less than 1. It should be less than, even say I will say 0.4. Then this particular image is really geocoded well. So that is the method nowadays we are applying. The difference between these two, I want to show you. This is the raw image of Kanyakumari area, and this is a geocoded image of Kanyakumari area. Now the difference in the raw image, if you see here, you can see a row number and column number. And when we click at any point in this image, you can see latitude value and the longitude value. And this image is the north orient. So now different you can easily this that's why geo is more important. So now we will see how this geocoding is happened. This is the unregistered image or the raw image, and which is now converted into the geocoding. So this continuous process, somebody called as a geocoding, somebody called as a geometric correction, or somebody called as a correction of registration. So there are different names. Now once this is the particular image 140 by 140 kilometer available in computer system, but your area of interest is a typical portion, that is, suppose if I want to study at this area only, then you need to have a subset of that image. So that subsetting is feature is also possible in all software, and you can subset the image. Then the third process is the delineation between land and water. There are again three schemes, I would say three methods are available of delineation between land and water. One is automatic. Computer knows the difference, he knows the signature, he knows the pixel value. See, there is a difference, as I showed you DN number. DN number of land is nearer between 1 to 50, and DN number of water will be above 200 or above 150. So computer understand very easily, and he himself can delineate between land and water. This is one method. Another method, this is automatic method. Another method is manual method. By visualization also we can easily mark tick tick. We can each and every point of the delineation between land and water. And the third method is a semi-automatic, because in many features there is a clumsy signatures are there, particularly rock outcrop is there. Then you will not get more clear picture automatically. So where some part we can do manually and some part we can do automatically. So this is possible. Now we will come to the real example of the coastal application. First example. This was the basic things, you know, how the remote sensing imagery is available through through national remote sensing agencies, how we can order images, and now how the image processing is done. And now we will see the application. Prediction of receding low tide line at Trombay Generation Station, Mumbai. This particular project I am giving to all customers basically because this project was referred not only but twice to CWPRS. First project it was referred in 2000, where this is a Tata Electric jetty in this picture. This is the Mumbai area. These are those or the I will for benefit of the area. In front of that is the Bhuj Island, and in front of that this is the JNPT port is situated. The all JNPT port ships are going through this path to this, and in front of this there is Tata Electric small jetty. This is a small jetty, and one Pirpao jetty is there, that is a big one. So this Tata Electric jetty is built for Tata Electric is nothing but is a thermal power station. Next picture again similar. It is a thermal power station situated at Trombay area in Mumbai. It requires you know the thermal power station requires a cooling water for their thermal generation. So cooling water is taken from this particular jetty. It is taken through pumps and it is fed to the thermal system. Over a period of time, not the ample water. So the prediction here, the shoreline is shoreline is accreting, means land portion is increasing, or nothing but in other words, beach is taking place in that area. So we can this we have taken the different years images. Now here you can see green line shows the 92 image of delineation land and water, and red line shows 99 shoreline. Similarly, we have taken 81 image, that Landsat image. Now see the 81, the shoreline was somewhere here, and 999 shoreline was somewhere here. Similarly, if we observe the shoreline where it is there in earlier part and when it is now from 81 to 99, so they are not getting the ample water from this region. Here the shore Tata Electric jetty is there, and again upper portion is change. The reason when we field visit is also important. When we inquired with the Tata Electric, they says we are doing continuous dredging for that particular area. That's why shoreline water. So that's why shoreline is not, because after dredging the water comes there. And upstream of this Tata Electric jetty, this particular portion is having the rock outcrop is there. So there is no erosion, there is no accretion, and this is a BARC area, that is Bhabha Atomic Research Center area. Now, with this imagery analyzed in the Mumbai region, so many portions, the blue portion shows the erosion portion has taken place, and whereas yellow portion shows where the Tata Electric jetty is there, the accretion. Accretion means land formation is more. More phenomena is erosion, but the earth is like that, or the nature is like that, it balances. If somewhere erosion is occurring, somewhere accretion will take place, definitely on the earth. So nature keep balances. So we can see easily there are certain portions are eroding, but certain portion beach formation is taking place. Again, this project was referred to 2015. Again, they want to study what are the changes between, and we have studied. This is called Tata Electric G. This one is a purity. So this is a Tata intake is there. Now the cost increase 2000 satellite images were available, and we could study this. Now this is the comparison between 2006 to 2012. Again, comparison of 81 to 2012. So with this, we have given how they should require to dredge particular area, and how creation is taking place on that particular Tata Electric DAT. Another studies I want to highlight over here, shores triability for the proposed nuclear power plant at Kudankulam, that is Tamil Nadu. Kudankulam is of where the nuclear station is coming. Nuclear thermal require cooling water system. So power station should be as nearer to the coastal side. But after tsunami, they want to ensure that it should not be that close, as because of the tsunami effect, tsunami kind of thing should not affect on their power plant. So they want to study this area whether it is a fairly stable or not. So we have studied with the help of different images from 1990 to 2012. So this is a 98 image with 92. Here you can see the shoreline is fairly stable. 2000 is compared with 92. Why? Because particular area when we visited, a rocky outcrop is there, and the Kudankulam, particularly east coast, downside of the east coast near Kanyakumari, is fairly stable. Again, we compare these are the different images. So this project for Kudankulam, again, few 100 kilometers away from Kudankulam, it is Uwari Fishing Harbor, where this project was referred to us. Again, we have studied a different imageries from 1998, 2004, 2011, and we can easily identify this Uwari area is also fairly stable. So these were the example of particularly eastern coast side, and there is the next example, assessment of shoreline changes for the development of port studies, JSW port at Nandgaon near Maharashtra. This is on the west coast. Of course, west coast is, for our example, west coast is fairly stable, particularly southern part Of course, Gujarat area, there are slightly vulnerable in few coast area, similarly to the Orissa and Bengal. So we again here we compare different imageries 2000 with 2012, same thing, 2006 with 2012, and these are the different imageries from 2000, 2004, 6, 8 and 12. And here the coastal region are fairly stable, so they can construct a port as near with the suitable alignment very easily. Another peculiar study has come to study about the morphological changes at Narmada. This is called as the IPCL jetty. Earlier it used to called as the IPCL jetty. Later
सर,
IPCL is
रानडे सर,
बोला सर.
तुमचे स्लाइड्स जात नाहीये पुढे.
फ्रीज झालंय.
आता हे कुठलं आहे? कुंडकुलम तो
कुडमकुलम वरच आहे. अच्छा,
हां.
नाही मग मी दहेज एक मिनिट. आता
नाही, अजून नाही जात आहे.
एक मिनिट मी हे करून बघतो. शेअरिंग सर मी ऑफ करून परत ऑन करतो.
हां.
सर आता दिसतंय?
हां, स्क्रीन इज आता विजिबल.
एक मिनिट पीपीटी मोबाईल येतो. आता येतंय?
तर स्लाइड्स अजून
येईल ते नेट स्लो आहे थोडंसं. आलं?
त्याच स्लाइड वरती आहे.
हो, मी आता मूव्ह करतो. आता
हां, आली आता नवीन.
JSW village.
असेसमेंट शोरलाईन.
Okay, okay. So I will go back with few slide. Now we have studied eastern coast, western coast near Mumbai, upstream of and downstream of Surat. Nanda is for JSW steel. We have studied the shoreline changes from 2000 where sir slide move होता है ना आता. हेलो हेलो. हाँ, स्लाइड मूव होता है. स्लाइड मूव होता है.
हाँ, हो.
वेळ लागतोय का थोडा? स्लो होतोय का?
हां, थोडा होतीये म्हणजे. हां.
Okay. 2006 compare with 2012, and these are 2000 to 2012. The shoreline is fairly stable. Can you see morphological changes at Narmada estuary slide?
Yes sir.
Okay, fine. So this is the typical studies at IPCL jetty, where earlier we used to call IPCL, now it has been taken over by the Reliance, where the small jetty Bharuch, it is near Bharuch at the mouth of Narmada river. You can see my cursor where the jetty is there. Prior to construction, Narmada which is somewhere in this area, 70 kilometers from the jetty, and prior to upstream of that there is a Sardar Sarovar tank. So what happens, because of in this intertidal zone, what you mean by tidal zone? Low tide will be at 1 meter and high tide will be at 12 meter. 12 means the water rises from 1 meter to 12 meter. So that's why this, you can see at low tide the water will be somewhere here. At high tide this will be totally filled up. So lot of sediments are coming inside this estuary. See, prior to Sardar Sarovar construction, during the rainy season, at least this used to get flushed it out. But after construction of Sardar Sarovar, these sediments are stored or stayed back near this Narmada, on the Narmada estuary. So, what happened? Because of that, silt is bigger are coming to the IPCLT because they are not getting proper depth. So they refer study, and with the help of mathematical modeling and the remote sensing, we could see these are the shore formations at different time period. These shows nothing but a that are clearly visible on the low tide, and they are moving their shape, size, they are increasing their size. So what will be the remedy? The remedy will be, we can dredge. See, these areas are quite big. It is not possible to dredge all area. So we have suggested to dredge the particularly few locations at the bank line, bank side, and which was really affected because that act as a the water flows through this depth particularly. Now, this is the assessed tidal storage at Nan. Wants to have a thermal power station. They want to have ample water study. See, there is a small check dam at Nani Creek. So where the water comes, different that way when it comes on the high tide, small check dam or check bund over here. So when the high tide, the water comes inside, and during the low tide, it gets arrested. So they want to know the water volume available on that particularly area. So again, here the important selection satellite imagery is okay, subsetting is okay. The difference between is correlation of digital count, that is the water availability, with the bathymetry. Few point location we have taken up bathymetry values, and conversion of that digital count or that particular location digital bathymetry value into the digital count has been converted, and with the help of that we have computed the volume of the water available using trapezoidal method. So at high tide, how much water is available, we can go through that, and low tide, how much minimum water will be available. So we can easily assess the water availability with the help of satellite image. As I told you, water quality studies at Bandra, Mumbai. This is the Arabian Sea and this is the Mumbai area. You can easily visualize, particularly this is a river, Mithi river. Due to industrial pollution and slum area, the water quality in this river is very poor. Even while traveling through train, you can easily feel the odor of the with the smell, how this area is more polluted. Even in the image you can see the blackishness of the color of the surface water easily discriminate the pollution. We analyze the different imageries of from 92 to 2001 and latter part up to 2020, and we can classify this image because all these are the water but different color. So with the help of classification method we can analyze the area, exactly area available, pollutant available in this particular area. So with, as I told you, with the help of classification, we can analyze the image. We can classify how much vegetation is there, how much water portion is there, how much urban land development has occurred in this particular area with the help of different classification of particular image. This is an example of 1993 Mississippi flood level this is the Landsat image prior to flood, and it is image after flood inundation. How much area has been affected during the flood. San Francisco urban sprawl also easily identify at different time of period. Of course, question will come in your mind. These are the 84 image, 90 image, 2000 and 2020 image. In 2020, it is 50% urbanization has occurred in the same area, whereas in 84 it was only a 13%. Question will come in mind your how you can detect 85, 90 and 94, 54, because 96 images were available, but 54, 90 and 85, they are derived from the topo sheets. They are continuously updating topo sheets. So urban sprawl area can be defined with the help of updating of the topo sheets. We will not go in detail about monitoring of the weather, but detecting of wildlife, fire, yes, easily available. And one more important thing I want to explain over here, the satellite imageries are acceptable by the court of law. Court has also accepted the satellite imageries because there is no human intervention in these imageries. The famous example in court case in Rajiv Gandhi National Park near Borivali, where the hutment or encroachment has occurred, but the local authorities says there is no encroachment, and the NGO has shown the proof to the High Court that during 1990, 95 and 2000, how this encroachment has occurred, and court has accepted this. So with this, coastal application has been already covered. Of course, next part was not in my mind, but I will just give a glimpse about the morphological changes about the river engineering. This will be for river engineering or sedimentation will be a different topic, but just I will show you few imageries. Here the delineation of land and water is similar to the coastal engineering. So this is a Farakka image where delineation of land and water has taken place as compared of different imageries. This is the October 88 image. This is 99 image, and this is 2006 image. This is 2012 image. And when we compare all these three imageries, see how the bank line is changing, like Farakka hai or Ganga hai, or even north side, all rivers are changing very fast their bank line. That's during the flood time. So this can be easily identified. Now the question in mind, all satellite imageries are, as I shown you earlier figure, with the help of sunshine only they are capturing the image. But nowadays the radar satellite images or the active sensor satellite images are also available. Because of the these normal satellite imageries, due to cloud coverage, the image are not captured because of the cloud coverage. But this radar image doesn't have that kind of limitations, and image can be taken even through cloud also. So radar satellites or images are also latest available. With the help of that, we can easily detect the changes during the monsoon. Similarly, another satellite image location to have a Mahanadi river propose intake water for again thermal power station. So they want to study in this area where the bank, in which bank line the water will be all the time will be available during monsoon and post monsoon also. So different imageries prior monsoon and after monsoon we have studied from 1990-54 topo with the help of topo sheet, and 1990, 99 and 2000. In all the imageries in this location, the ample water is available, so we can advise them or consult them. You can have a proposed intake location at this site for thermal power station. So these are the site location, proposed intake site. With reservoir studies, this is those who are staying in Maharashtra. I just want to show this figure always. This is a Koyna reservoir, big area, this particular area, and these two are the Panchet and near Pune, Panchet, Varasgaon. These two upstream reservoir, and this downstream reservoir is the Khadakwasla reservoir. This is the Khadakwasla reservoir image. This is the Panchet and Varasgaon. Exactly two big reservoirs adjacent to each other, situated in a very peculiar hilly area. So with this, I just want to conclude. The satellite remote sensing could be effectively utilized for the coastal and river engineering studies. There are many applications, but particularly in our applications, mainly in coastal and river, shoreline, for the shoreline and bank changes, morphological changes, shallow water bathymetry, the capability of physical model, and we are doing mathematical modeling also. Technique for solving complex coastal and river engineering problems can be enhanced with the use of satellite remote sensing data. With this, if you have any questions, the floor is open.
Sir, there is one question from the participant Dilip Patil.
Okay.
Hello.
Bola.
If we want image of post flood, then is there possibility that satellite may not have come that place at same time?
Right.
I don't know what he wanted to.
No, I got the question. He meant to say, Patil sir want to say, if we are taking a picture of, take the example of, suppose there is a flood on the 5th of July, suppose. Now he want to take an image of 1st of July and 10th of July, right? So prior to flood and post flood. Now his question is, if there is no satellite passed on the 10th of July, then how I will get the image? That is his question, right? So
yes.
I will answer this. See, earlier days, yes, there was a problem because on the there were only one or two satellite available on the universe. But now there are 3 to 4 Indian satellites are available, and their revisit capability is now reduced from 20 days to 4 days. एक अगर आया है Cartosat 1, if it is not available, then Cartosat 2 is there. So you may not get 10 July image, but you may get 9 July or 11 July image. So, or if at all Indian satellite is not available on that particular period, you may get the foreign satellite images also. So nowadays we are not facing any such kind of difficulty. But yes, earlier कुछ आपको flood देखना है, then there are few limitations in these applications.
Okay. Anybody having any other question? You can either raise hand or put it in the
chat box.
I think, sir, there are no more questions.
Right.
So, on behalf of all the participants and our institute, sir, I'm thankful to you for explaining very nicely the applications of remote sensing in the coastal engineering, and also the basics of remote sensing also you have covered. So I am very much thankful to you, sir, for accepting our invitation and delivering the session for this FDP. Thank you very much.
Thank you, sir, and my sincere apology for technical glitches that is beyond our control.
Okay.
Yeah. Thank you, sir. Thank you.
Thank you very much. Participants, 1 minute.
Sir, I will stop the sharing.
Yes, sir.
Please.
Participants to join immediately at 11:45. We have a next session by Dr. Patil of Maharashtra Remote Sensing Application Center. आता लगेच आहे 15 मिनिटात. 11:45.
धुळेला असेल का पाणी? काही अरे बाबा कॉलेजचं काही करू.
हेलो, हाँ जी, गुड मॉर्निंग मैम, मैं सिटी ग्रुप ऑफ इंस्टीट्यूट तो कॉल कर रहा हूँ।
हां सर, हॅलो. हां सर, निंबाळकर बोलतो. हां.
हो बोला ना सर. येस.
हां, हां. सर मी आता तुम्हाला हे केलंय, तुमचा हे
हो
व्हिडिओ
केलं.
दिसतोय आता आम्हाला. हां.
शेअर करू.
हो, प्रेझेंटर केलेलं आहे मी तुम्हाला. आता आपण ना एक
हो
शेअर करू शकता तुम्ही. एक
हो
2-3
शेअर
मिनिटांनी हे करू. हां?
चालेल. हो
हां.
दिसतंय का सर? शेअर केलं मी.
हां, एकच मिनिट हां. हां, दिसतोय तुमचं हे.
पीपीटी दिसते ना?
हो, पीपीटी दिसतोय.
ठीक आहे सर. येस.
हां.
मी म्हणाल की मग मी सुरू करतो.
हो सर. इंट्रोडक्शन करतो आधी आणि मग आपण
हो
एक
चालेल.
हां, एक 2-3 मिनिटं सुरू करू.
हो.
हां.
येस सर. राईट सर.
Patil sir, can you hear me?
Yes, sir. Yes.
I think I will introduce you first,
Yes.
and then we'll start. So, participants, today we are starting with the second session, and for this we have our guest speaker, Dr. Sanjay Patil, who is working in Maharashtra Remote Sensing Application Center as a resource scientist and the head of this center. So I will introduce Patil sir. Uh, Patil sir, his educational qualifications are PhD in geoinformatics from VNIT Nagpur, then MSc Tech from remote sensing in Barakatullah University, Bhopal, Madhya Pradesh, MSc Geology in ML Sukhadia University, Udaipur. The various summary and the nature of achievements, the important projects coordinated and completed by Patil sir at this MRSAC center, Nagpur. First is Rajiv Gandhi National Drinking Water Mission, for groundwater quality mapping project, then electoral information system, national geomorphology and lineament mapping project, wasteland monitoring project, impact assessment of irrigation projects in the state, uh, the national resources information system project, georeferencing of village map project, then health assessment of crops due to hailstorm, hydrology project of groundwater survey and development agency, regional plan preparation for 12 districts of Maharashtra, Prime Minister's Gram Sadak Yojana, value zone mapping for Inspector General of Registration, Maharashtra State, environmental sensitive areas, mapping for Western Ghats of Maharashtra under MSBB, Integrated Watershed Management Program, resurvey under NLRMP by Land Record Department, ease of doing business, Government of Maharashtra, road information system. He has also coordinated and conducted the various workshops and trainings. At few of them are at this IWMP program at Eshada, Pune, and MRSAC Nagpur. His areas of interest are remote sensing, GIS and GPS applications in natural resources, inventory mapping and management, uh, EIA of irrigation and watershed development projects, watershed development management using remote sensing and GIS, remote sensing and GIS application in infrastructure development. Also, his professional experience is founder head of School of Earth Science, Swami Ramananda Tirth Marathwada University, Nanded. Then 22 years of experience in research and project execution using remote sensing, GIS and GPS technology. He worked with Water Resources Department, PWD and Town Planning Government of Maharashtra. He has also guided various students for PhD from this Savitribai Phule Pune University and also guided 20 postgraduate students of MTech and MSc from different universities for their dissertation work. He has also published the 2 research papers in international journals, 4 in national journals, and about 9 in national seminars and workshops. So I welcome sir for this FDP, and I request you to continue with your presentation.
Okay, thank you निंबाळकर सर. माझा आवाज येतोय?
Yes sir.
Okay.
येतोय.
Then I will shall I start now?
Yes sir. Yes sir.
Okay. Good morning everybody who has joined on this online webinar, and I am here from Maharashtra Remote Sensing Application Center, Pune branch office. So today in my presentation I am going to present the application of remote sensing, GIS and GPS in the field of resources, water resources in the government of Maharashtra. So my presentation is visible and my voice is audible, sir?
Yes sir, presentation is visible and you are also audible.
Okay sir. So I'll just in my first few slides I'll talk something about this department, what Maharashtra Remote Sensing Center is, and what we are doing for the water resources department for the government of Maharashtra. So, sir, shall I continue?
Yes sir.
Okay. So Maharashtra Remote Sensing Application Center, it is like a space application center of the state, established in the year 1988 in Nagpur. Actually, this head office, our directorate of this office is at Nagpur, but we are having 2 more branch offices. One is at Pune, where I am posted as the head of this department, and the other is in Mumbai. Actually, this is a scientific autonomous organization under Department of Planning, Government of Maharashtra, and this department is serving for this remote sensing GIS, GPS technologies to various departments. So one of the major department is the water resources department. So I think some participants should mute their mic so that I can talk properly. Okay, so I'll continue. This being a government department, we are working in so this is a research department, but basically our mandate is to give these remote sensing GIS applications to various departments. So particularly since I'm heading this office at Pune, so what are the departments with whom I am working, and how these department are getting benefited out of this technology? I'll just go in brief about this. So the divisional commissioner is the administrative head of the division, Pune division. So I am working with him for many his day-to-day activities. Then settlement commissioner, who is very important for land records. What the entire land is divided into the forest land and the revenue land. So the revenue land records, entire records, whatever we do the land surveying, mapping, or what measurements, that everything is done by the settlement commissioner. So they are doing so many resurveys and the e-Mozni, day-to-day this measurement activities for various purposes like land acquisition, the people who are applying for measurement of their land. So that entire activity is being taken care by the settlement commissioner. So I'm on day-to-day basis, I am working with the settlement commissioner in Pune. Then collector Pune, water resources department. Water resources department is having a very big establishment. They are having different wings. So I'm working with many people, many senior officers in the water resource department. The other department is groundwater survey and development agency. Actually, the purpose of this office set up at Pune is to facilitate this head of the department sitting in Pune for this application of this remote sensing GIS technology. So water resource department is one of the very renowned department in the government of Maharashtra, and they are located at Shivajinagar, Pune. So we are doing the watershed mapping, watershed development, and then impact assessment. So many activities are there. So I'm trying to focus my activities related to the water resources definitely, but eventually when I am covering the presentation, some additional information I will keep on giving, which we are doing at this department. Then Public Works Department, Agriculture Commissioner, Vasundhara Watershed Development Agency, Town Planning. So these are town planning, PWD, water resources. They are all the civil engineering department basically. They are the government main departments wherein almost all the officers, they are from civil engineering background and they are working in their respective field. Then Maharashtra Disaster Management Cell, this is also now we have seen this very recently. A lot of area in Maharashtra has undergone this flooded situation. Sangli, then Chiplun, Kolhapur. So we are also working with them, and we did for this particular disaster, that I will also I will put up before you in my presentation. Then Maharashtra Agriculture Competitiveness Program, that is again agriculture related. Maharashtra Rural Development Program, wherein the infrastructure is created for the remote areas through this Prime Minister Gram Sadak Yojana. Then Maharashtra Biodiversity Inspector General of, actually this Inspector General of Registration, they are the department who take care of the registrations. When we go for property transactions, when we sell or buy or do some change in name or the property we are going to legally transfer. So we have to do the registration. So that head of the department is the Inspector General of Registration, wherein also all these departments are using this GIS application, remote sensing GIS. That's why I have taken it over here. Then Tribal Research and Training Institute Department, that is also located in Pune. Yashwantrao Chavan Academy, that is Yashoda, is a prime or apex training institute located in Pune, wherein all the government officers, so they are all senior class 1, class 2 or the IS officer, they are undergoing these, they are having a schedule of continuous schedule of trainings. Now it is happening online, but basically it was offline or the campus based trainings that Yashoda takes for almost all the departments. Sugar Commissioner, so many are there. I have just highlighted a few of them. So when we talk about the remote sensing GIS, GIS when you talk, it is a geospatial technology wherein we are creating a database. Creation of database is again a very important activity, and then developing applications on that database is another application, and serving the data through web services, that is the next important part, wherein we are going to give the database to the actual users or various government departments. So as a MRSEC being a nodal agency for geoinformatics in the Maharashtra, we have created the database at different levels. So here we can see we are when we started MRSEC in 1988. So by that time we took the maps from Survey of India and created the database on 1:1 million, and then with the degree seat on 1:250,000, topo seat 1,50,000, and with the development in the resolution, fine resolution in satellite technology, we have gone through 10,000 scale mapping, 5,000 scale mapping, and finally it is 1:500 scale mapping using the drone data or even the high resolution satellite data. So that entire data covers the urban area as well as the rural area of this Maharashtra. And the other thing is, it is a seamless mosaic data of entire state. If I am talking about a particular theme, if I am talking about the water resources mapping, so it has been done for all the districts in the state uniformly. So likewise, we are having a seamless database for various themes for being used for different departments. Okay, I will show some. This is the some snapshot of the basic database. So as I talked about the land record department, so they are the custodian of the land data. So land data, what they are having, this is the village Gauthan map, village map. That is what we call in our layman, that is survey number map or gut number map or khasra map. So all these maps, they are the proper, they are the custodian. Land record department is looking after all these. They have been prepared since 100 Britishers time. Many villages are there. Still, they are having the maps which we are using now, but they have been mapped or surveyed long back, maybe 100 years back or so. So these maps needs to be updated now. That is the resurvey part is going. That is the ongoing activity with land record department. That is the resurvey of the villages and the Gauthan area. That is the Basti areas. Okay, so this is one of the map. So under this project, Maharashtra Remote Sensing Center, what it, because this is the basic requirement of all the departments. Everything is happening at ground level on this at this level. That is survey number level, or any scheme is happening or any transaction is happening. That the lowest unit is the village level or survey number level. So we have created this survey number data for entire state, which is very much used in water resource department also for different projects and for different activities. So once we have completed long back in 2001 to 2004. There are around 44,000 villages in Maharashtra, and we through government we got all the maps. We scanned it properly, digitized it, and then we have converted the digitized these drawing files into save files, and finally into the GIS database. So these database was very systematically created, covering all the villages, because the maps, input maps were not like uniform maps, because Maharashtra what curved out in 1960 was through from different states. So the like Marathwada was from Nizam, the Gujarat and Maharashtra was a Bombay state. So my point is that, so all these maps were in different format, different scales, different regions. So since we created it, we brought everything into a GIS. Now a uniform database is now available for the whole state. On completion of the rural area, we switched over to the urban areas. So urban area are having the city survey maps, what we call city survey maps. So these maps are on 1:500 scale. So these maps also we got from land records. We scanned, digitized, and geo-referenced with the high resolution. That time in 2009, when we completed this project, the resolution best available was 1 meter resolution from Iconus satellite data. So we purchased all the satellite data from NRSA Hyderabad, and we completed this activity. Now there are some part left out. Just I'm covering the whole area for the whole. Left right part is that the some village Gauthan areas wherein there is no map at all. No, till date, no agency or no government department has done any kind of survey there. So to cover that area, so that the villagers also can be given the city survey, city survey areas or the property cards, considering that, so that they will be having some economic benefits, or to get the loans or some financial empowerment of those areas. So for that, now this Swamitva Yojana, some of you might have heard about the flagship program of our Prime Minister, Swamitva Yojana. That is part of that is started in Maharashtra, and now it is implemented in all the states in the Maharashtra. So in this project, the Survey of India, which is the major, the main agency or the apex agency of the Government of India, MRSAC, and Land Records, we are working together to do the mapping of all these Gauthan areas using drone data. So drone is having better resolution or best resolution compared to the satellite data. There are the advantages, pros and cons, or the limitations you might be discussed in last 2-3 days. So using drone data, we are creating the left out areas, that is the village Gauthan areas. So with this, we are having a complete administrative database of the whole state. So which are the other themes which we are having the database? They are the administrative boundaries like state, district, because we talk a lot about the GIS applications, then modeling and so many things. But basically we need to create the data, that is the thematic data or the base data or base layers, what we can call. So administrative data, development boundaries like watershed boundaries, the forest boundaries, tribal area, irrigation command areas, or the different medium, major, minor irrigation projects. Their water inundated area, that catchment area, command area, all these things are there. Then like agriculture department, wasteland mapping, forest department, then water bodies, rivers, wetlands, drainage, canals, that have been covered. Geology, in geology, we are having a lithology, geological structures, lineaments, they are all in the database. In groundwater, we have created a groundwater potential maps. By integrating some of the themes like slope, contours, land use, we have created a groundwater potential map that is being used by this GSDA, that is Groundwater Survey and Development Agency. Then built up areas, different industrial areas, settlements, habitations, settlement locations. One more thing I would like to highlight over here. So earlier I told that Maharashtra is having 44,000 villages, but that they are the administrative villages. But if you go to the habitations or the locations, they are more than lakhs. So we have mapped all these areas. Like one village may be having some wadi vastis at different locations within the village. That also has been mapped by MRSAT. Then crop area, under crop area, sugarcane area, rabi, sorghum. These are some of the major crops in Maharashtra. So every year we are mapping, every season we are mapping all these cropped areas. Transport, we are having a fantastic data on transportation network, having all the road network as per the PWD norms, PMGSY norms, and railways. Then we are having automated weather stations, IMD data, rainfall data through the coordination with the different government agencies in the Maharashtra state. So these are all the departments like agriculture department, water resource department, irrigation, that we have earlier it was being called, or irrigation, water supply and sanitation, revenue, forest, environment, relief and rehabilitation, wherein this flooding data we are supplying to this agent department, education, health, soil conservation, water conservation, PWD, MIDC, MEDAN, many. So almost all the field departments working in the government domain, we are linked to them. Being a nodal agency of the government of Maharashtra, we are working with almost all the departments. So, as per our topic, areas of water resource studies using remote sensing, and what could be the areas? What are the focus areas wherein we can apply this technology of remote sensing and GIS, GPS for water resource department? So, first is water balance studies. This is a very important area when we talk about the water conservation and all that. So, we need to carry out the water balance studies. Using different methods, available methods, or people are creating their own modeling and something they are doing. So flood modeling, inundation mapping and modeling, watershed development, then river basin planning and management, water distribution system management, groundwater management, floodplain management, urban storm water management. So these are some of the major areas wherein we can use the remote sensing GIS technology. Then I'll come to the main department, that is the water resources department. What water resources department, how it is linked with MRSAC, or how we are working together, that I would like to highlight over here. So we have signed when the MRSAC being an autonomous organization, the modality of the working is that when any department approach or MRSAC approach to that department, we understand each other. What are their requirements basically in day-to-day working or for any project work? After understanding the requirement, we propose them. So these are some of the, whatever they may be having 100 points. So everything may not be covered using the geospatial technology. So whatever the possible areas wherein we can put to use this technology, we address to them, we make the presentations, then we sign the MOU, memorandum of understanding with them, and then work starts. So already we are having a MOU with the Water Resource Department, Government of Maharashtra. So what we are doing under this project, that is a mapping of jurisdiction of the Maharashtra Water Resource Department Offices Steel Division. So first of all, we have to address their administrative setup. So because this is the remote, this is not like administration based department, because they are working in various remote areas. Projects are there in rural areas at different locations. So they are having division office, executive engineer sitting there. They are having subdivisions and JEs and deputy engineers. They are working. So their jurisdictions are totally different compared to any other government line department. So what we did, we have mapped all the their jurisdiction, like right from the secretariat level to the chief engineer, his jurisdiction, superintending engineer, his jurisdiction, likewise executive engineers, deputy engineer, and all that. Otherwise, then all the command areas, mapping of command areas, the river bodies, and all those dam and canal network mapping, existing, new, proposed, ongoing projects, everything we are covering under the mapping of this data. In addition to that, some of the things which they need to map on the field. So to do that activity, we have provided them the Jalashruti mobile application. So this mobile application is having all the facilities as per their need. When they go to the field, they will come to know where they are standing, what is the district, taluka, or the which command area, who is the officer looking after that area, what is his capacity, what is his designation, what is going to map. So everything is being well defined in the Jalashruti mobile application. So, and then once we create the database, we have to validate it. Validation is very important because different people are working in the same using the since people are changing their approach, their way of working, everything gets changed. So whatever the inputs we are getting through them may not be uniform. So they may have some errors, or that needs to be validated. So once we create the database, we go for the validation activity, and then once the data is validated, that data is finalized with the consent of Water Resource Department and as per the quality check parameters of MRSAC. And that data is then finalized, freezed for further applications. So I'll just a little bit about the Jalashruti mobile application. So this Jalashruti mobile application developed by MRSAC has prepared a jurisdiction called the office module. The file sent to KDC. So this is the KDC is their coordinating office, which is located in the Pune. used to back the end. The necessary corrections which may be required to in the database can also be done, as the same can be shown in the remark column. So this is some of the snapshot of that Jalashruti application. So one will give the mobile application is being given to the enter officer. They can just they will install that application into their mobile. And now the mobiles are so advanced and everybody is now having the smartphones. We need not give any special specifications of the mobile. So normally any mobile that is able to handle this application. So then when there will be a dashboard on the mobile application, it is dam related, office, water body, river, or if it is canal, send manager, KTVR, or if you want to quit, you can quit with this button. And then this is all GPS enabled mobile application. They can record all the latitude, the coordinates, latitude, longitude, or even the altitude, whatever they get from the GPS. So once they record all these things, then there is facility to take the photograph of that object, whatever they are going to map. If suppose there is a check any suppose there is a canal or any distributor or any structure, engineering structure. So they want, if they want to take the snap, they will take it from this mobile application and it will send to the M. So whatever they record the data, that entire data, once it is sent, it will go to MRSAC server. Then we do we check the data. If any error is there, any data missing is data, we'll keep on communicating to them through mobile or what. Then different WhatsApp groups are there. Now communication has become a very fast everywhere, so there is no problem. Everything is being communicated to the concerned field officers. Now you see WRD data validation. How we do the data validation? Now this is the validation of the Purna project. This is the Purna project in Amravati district actually. Then validation of 18 KP Prime Minister Krishi Sinchan Yojana project completed. Remaining 8 projects are in progress. MRSAC and WRD targeted to complete 100 projects in 1 year. So some of the projects are completed and the remaining projects are in progress. So this is the dam wall, this is the discharge point, river, this is one of the village. So this is the canal, but we can very clearly see it on high resolution data. Even our Google map, we can see all this. So we try to use MRSAC data or the data which we procure from ISRO or NRSC Hyderabad, we'll try to. But whenever the data is not available or any lacuna is there, we are using even Google Earth for data creation. So these are the drop of falls, VRBs, or where the CR come HR on Sanuri branch. So these are all the engineering this command area network features that has been mapped using this data. So then when we are working together, we need to have some responsibility. We have to share the responsibilities. So like MRSAC doesn't work in like a contractor mode or a vendor mode, because we are a government organization and we are also part of the Maharashtra government. So we work with the department with like a joint activity. We work together. Like in case of Maharashtra Water Resource Department, what they do and what we do. The supply of hard copies or software, whatever the inputs they are having, their own data, that has to be supplied to MRSAC. Then we'll see what format data is in, how it can be brought into the GIS format, or how much it is scanned to be scanning, this is required. So everything we do, this is a long, you can, I will not go through each and every point here, but we define the process entirely and then we'll start our work. Then whatever we map on Jalashruti mobile application, where to see that? If I am a WRD official, I went to the field, I mapped the field features. Now I have sent the data from my mobile application. Now where to see that data? So see whether it is correct or not. So their facility is given, a web geo portal has been developed for that particular department. So this is why I'm talking only about the water resource department. Same thing we are doing with almost all the departments which I have quoted in my earlier slides. So this is the water resources and MRSAC developed the geo portal. So once the data is sent by the mobile application, he can see. Now he can see the location where from which lat long he has captured the data and sent it. So this portal is also in their domain. They can see the everything on this portal like this. So once the data is mapped, they can just click the button or mouse there and they can see what they have mapped it. Like here, water body name is Ardhan Nalaband, where Taluka Satara, village is Kalam. This is this feature. Once we click it, it will get highlighted. And we can see the photograph also. That photograph is having the bearing also. So through 360-degree on in which angle the photograph has been captured, that also recorded on the photograph. Now this is the remote sensing for monitoring of water bodies. This is the regular activity of MRSAC. Every 5 years we are mapping, we are creating a land use mapping of a whole state using at least 3 data, because by geographically it is a huge area, more than 3 lakh square kilometer area. So we can't go with the high resolution. We have to see which resolution is suitable and we can complete the activity and as per the requirement. We can't use every, because every resolution is having its own level, but its own level is also equally important for that particular scale of mapping. So now here we can see this is the satellite data of 1997. This is one more advantage of remote sensing is we can have an archive of data. Many times government need backdated data. They have to go into the history of the data. So then where to get the data? So either we are having whatever data we procured through our working from the inception of this state, the data is available. It has been properly archived in MRSAC and that data is made available. If it is not in MRSAC archive, we can get the same data from NRC Hyderabad. So like this satellite data of 97, Patra, this is the indexing of the data. One reservoir has come up. You see this, you can see this is the reservoir. You see there, it was this reservoir was not there. When you see the data of this is the 1989, 1997 and 2006. Just don't get confused. This first one is the top left one is 1989 data, wherein this water body was not there. In even 97 it was not there, but it came in 2006. So that way we can keep on the mapping of new water bodies coming up in the state using the satellite data. So this is study areas from Samudrapur Taluka of Wardha district. This is the sum just for presentation purpose, but this is we are doing for entire state. Now this is another example. This is Vadgaon Dam in near Nagpur. So here it is again a major dam, Vadgaon Dam, and it is a major supply to the MIDC of Nagpur, that is Butibori MIDC, and also to nearby factories, industries, and the domestic purpose. So this is a big dam. So this dam was not there in 1997, but if you see in 2000 image within 3 years. So within 3 years this dam has been constructed and the water has been now it has been closed, and you can see the standing water or the water reservoir came in between 1997 and year 2000. Again, our working is in a different kind of mode. It is not like only giving the data, creation of data, or because the line department gives the different, they are having a different kind of deep, every day they seek something different thing from remote sensing GIS, or they need something for their own purpose to show it to the government or to make a project proposal or RFP or tender or something, some things. So many things they are linked with this GIS database now. So like this is one of the requirement of water resource department, that is integrated water plan for subdivisions of the river Krishna. So the Maharashtra government water resource department. Sir, is it fine, sir? Shall I continue? There is a noise.
Yeah, I will just mute the participants.
Sir.
Now I think I have
Okay.
muted all.
Then I'll continue.
Now you can continue, sir.
Okay. So I was talking about the Krishna Basin. So this is the map of Krishna Basin. So in what they want for the to prepare integrated water plan for this basin, they need geological structures like faults, lineaments, then GSD watershed maps, because they are the standard watershed mapping done for GSDA, and it is being used by all the government departments. Then land use map they want to have a major drainage maps, slope, soil erosion, soil texture, transportation network, then administrative map, satellite images, basin map, index map, river gauge, and isohydral maps. So since they whatever the ready-made things are with us, whatever already created by MRSAC, straight away we can create the maps or charts or presentations and we can give it to them. If that is not available, then we have to see what is the source of that database. We have to go to the source, we have to procure or we have to get that data, and then we have to convert it into a GIS and we can use it. So there is a huge potential of digital data on various themes like administrative, but these are all the things, the administrative point of view, resources point of view, then derived, everything cannot be derived from the satellite data, but some of the things are there which we can derive indirectly or by integrating some of the database. Like I was talking about the groundwater potential maps. So we can't get the groundwater potential by looking at the satellite image. So we have to create some of the GIS layers like slope, what is the land use, what are the contours. So we have to integrate all these things. And then what is the lithology of that area, what are the rock types of that area, what is the holding capacity, what are the aquifers in the ground. So we are considering all those, we have to integrate the data. So that is the indirect way of creating a new database as per the need of the government or the public. Then satellite data of various Indian or foreign satellite data, that everything now satellite data, the best available resolution as on today is 32 centimeter data world, that is the world view 4 data. That also we are using the data, but since high resolution data we can't use it for the whole state. But even then we are currently doing one project wherein we have used a 50 centimeter satellite data for entire state. We have created a digital elevation model, contour, slope, everything using 50 centimeter data. But since it is a huge database, it took 3 to 4 years to create that database. That database will be published or will be finalized by MRSAC and will be provided to the user departments maybe by the end of next year, maybe by the end of 2022. So it is a huge activity going on at MRSAC. Then the type of projects already completed. So this to have the field, which are the areas wherein we can apply this technology. So these are the things which already done by MRSAC. So mapping of water bodies on different scales, that is one thing. Mapping of pre and post monsoon water spreads. So we can map every water body having actually geographical area more than half of the hectare, or maybe if it is less than that, we are mapping that as a point layer. So if it is more than half of the hectare, we are mapping that as a polygon. So we can map, we have mapped all the water bodies. And the next, this is the base already created. Every year what we do, we see the what are the additional water bodies they have come up through different projects. That only we keep on adding those to the database. Okay, then this we have to map every year. That is the pre and post monsoon water spread, because every water body is having different water levels, and depending upon the geographical area, the water it is being lifted from the water bodies are under different purpose. So its level keeps on changing. So every pre monsoon, that is in the month of April, May, and post monsoon, that is in the month of October. September, at the end of October, we are mapping all the water bodies in the state, which are all the visible water bodies on the satellite data. They are being mapped every year. Then mapping of aquatic vegetation. So we are simultaneously we are having one more project, that is the wetland mapping in the state. So again, it is the central government project, wetland mapping. In wetland, we are covering the aquatic vegetation also. That is also important. Then mapping of canal network with high resolution satellite data, that is being done. Mapping of various drainage, cross drainage structures, road bridges, culverts, aqueducts. These are some of the regulators, etc. for the canal network. Then command area mapping, catchment area mapping for selected irrigation projects, because some of the activities are also being done by water resources department in-house, their own. So they are also having their own GIS setup. So, but they everything is not there. They are, because some limited area they are covering, and rest of the area MRSAC is doing this activity. Then various resources input for location of the dam based on which actual survey can be taken. Mapping of irrigation potential achieved based on satellite data through this project, that is the Accelerated Irrigation Benefit Program. That is again the Government of India's program, that is called AIBP program. Then preparation of command maps with the cadastral boundaries. So command maps also, not only what we do, once we prepare a command area, Then we overlay the village boundary, and then again we overlay the cadastral boundary, that is survey number, cut number, or khasra number boundary, so that we can reach to the landholder, who is the owner of that land, how much area is irrigated under his possession, how much is left, and this all the field level details we get through this cadastral data and the satellite data by integrating these two things. Then impact assessment of irrigation projects. So this is another very important area wherein we can apply the remote sensing application. Impact assessment, whatever the irrigation potential is there, whether the entire potential has been explored or being utilized or not. So this again a very subjective area, and we have to take up this because by field surveys or that, it may take a lot of time or maybe a lot of manpower. Now one more thing I can share with you, every department is having a short of manpower, and then many things are they are being given to the or outlook to the different agencies for carrying out the activities. So impact assessment of watershed development program. So a lot of watershed development through the central government, state government departments, they are doing so many watershed development like Jal Yukt Shivar and that Pani Foundation. So many things are there on the ground. So we have to assess the impact, whatever the structure infrastructures we are creating on the ground, whether it is being helping it to conserve the water or not, that we have to assess periodically. And then okay, the map showing status of various irrigation project in a district and location. So states various irrigation projects are there, they are having their own setup. So we have to provide them the maps, whatever we are creating, because every field officer or every government department doesn't have the GIS GIS setup or a lab. So they need to have some handy outputs created through remote sensing, maybe PDF files or JPEG files, or maybe the presentations or reports, or even the printed maps on different scales. Now you see, this is one of the project that is the map prepared by irrigation department, georeference map overlaid by the HR data. So this is the, you see, this is the satellite image. On this satellite image, whatever the command that map they have given to us, it has been georeferenced and put it on the properly matched on the satellite image. Once it is georeferenced, the data it is into the map is in GIS format. So we are having the all data set in a common projection system. So it will get perfectly overlaid with one another. So we can from this we can map the water actually water spread. On the water spread we can put the this village cadastral map and village boundary map, so that we can analyze village wise or cadastral wise the inundation of the water bodies or the beneficiaries or the land acquisition or the whatever government procedures are there, they can be eased using this data. Now you see Kochi barrage map prepared using the remote sensing data. They also ask us where are the potential sites to create a dam. Maybe the major sites it has been already exhausted, major dam sites. But for minor dam, for KT, for percolation tank, or maybe for medium project, they are depending. They are also trying to get this probable or the potential sites for the development of the, like this is one of the Kochi barrage map prepared using remote sensing data. If you see, this is the contour layer. On contour layer we have overlaid the this drainage map and then the village kasra map. So this is one of the potential area where can they can create a barrage or a dam here, and a new project can come over here. Then assessment of irrigation potential created by AIBP. So these are the they were limited projects. There were 25 projects assigned by the government of India to MRSAC to assess this potential created through AIBP. What are the hurdles? Why the entire potential has not been created? So everything has been studied in well details. At a very minute level it has been studied. So initially it was a 5 irrigation project, but we have completed 25 projects. Then Purna irrigation project, Sivna Takri, Kumbi, Mazalgaon, Kasar Sahib, very close to Pune city. So these are the projects wherein we have done the assessment of irrigation infrastructure and irrigation potential. The delay, but then what were the everything has to be spelled out initially, because these line departments their needs come as the project goes ahead. They create a new and new things. They ask or they demand some new things. So that also we have to take into consideration, and then we have to work with them, because after all, MRSAC is a nodal agency or a scientific department to handle the database. We are not implement as a MRSAC. It is not a implementing department or implementing any field implementing agency. So that entire implementation is with the line departments like water resource department. So as per their name, we have to fulfill their requirements. And then like assessment of irrigation structure, proposed and constructed lengths of irrigation canal. So as per proposal, what was the proposed length, and actual construction of what is done? If it is not completely done, what were the lacunas or what were the problems then because of it is held up, the part is missing. So that way we are doing the entire canal assessment. Then percentage of physical progress of the irrigation canal, hydraulically connected lengths, then number of structured structures, that is they are the structured, identification of critical gap areas. So these are the areas wherein we are doing the assessment. Then assessment of irrigation potential created and balanced irrigation potential that can be created with by solving or resolving some of the issues. Now this is one snapshot. You see, this is the assessment irrigation created for this one project, wherein we have mapped all the canals, their sub-canal tributaries and everything. So IP assessment is carried out independently for each terminal canal. Then hydraulic connectivity from the parent canal and from the irrigation source forms to the primary requirement for the consideration of physical potential created. Then individual canal wise IP irrigation potential are aggregated hierarchically to upstream the parent, because it is a network of canals. So everything there, though they are connected, some may, if it is a tributary, the sub canal, it will affect the further the network of the areas. So that way we have to take care of the entire network. Now these are some of the things, assessment of the IT structures. So hydraulic connectivity from source to the reservoir is verified. If no hydraulic connectivity exists, then IP created is considered is as a zero. If the project is not completed, then we have to when unless it is commissioned, it is it is a zero practically. That you can agree with me. If hydraulic connectivity exists, then any gaps or pending structures in the canal section are there, that has to be checked. If there are no gaps or pending structures within the canal section, then it is having a complete potential area. So irrigation potential created under this terminal equal to the designed irrigation potential multiplied by satellite derived canal length and the proposed canal length. That way also we analyze the or assess the this irrigation potential. Then these are the some of the things you are aware of. We have mapped all the basic features, like if this is a canal, then connecting canal, footer barrages, which are the road crossing bridges, where are the aqueducts, if any river or the tributary is crossing the canal, then super passages, if there may be a railway line. So these are all different features. This is not something individual. So we have to take into consideration and all the themes, all the features which are affecting or which are crossing across the canal network. So this is one of the example satellite derived irrigation infrastructure map of Purna medium irrigation project in Amaravati district. So this is the project wherein we have mapped entire detailed mapping has been done, and then what we found that has been highlighted over here. The this is one of the location northwest of Hirapur village, Chandur Bazar, Amaravati. Structure well type fall and village road bridge. So this is a village road bridge and this is the canal, how it is getting structured. So we can see how it is being blocked, a Purna medium project. So if any thing, any repair thing is there or whatever the day-to-day management activities are there, that also we can highlight over here. Now you see. You can see this. I will not go through this entire text, so I'll just highlight the observation on ground DY1 left bank canal discontinuous on the ground level. Now you see this is the location, or you can see on the satellite image here. So this is the part, maybe because of land acquisition the activity could not be completed, but the part is missing. Unless we make this continuity or unless we complete this section of the canal, this doesn't have any meaning. So we have to identify such areas from the satellite data where we can see where are the gaps are there or the blocks are there. So those blocks can be people, they know it. It is not like the irrigation people, they are not aware of this because they are the executors on the ground. But if once it is highlighted, they can take up in their maybe for whatever the procedure government they have to follow. So we are highlighting these things. So because of this, the entire potential has not been created. So then the things may move forward. This is another project, that is the satellite derived irrigation infrastructure mapping of Sivna Takdi medium project in Aurangabad district. So this is the balance potential, because you see this is the dam, this is the balance IP. Because of some problem, the entire irrigation potential has not been created. So these are some of the details of the the project. So all these details are provided by the Water Resource Department, because whatever the data, the official data records, archives, they have to share with MRSAC while doing these project activities. And now we do some activities at the district level, taluka level. So like it is updated map of Gadchiroli. So this is the entire irrigation related or water resources map of the Gadchiroli district in Vidarbha or in Eastern Maharashtra. The status such as completed projects, administrative approval projects, ongoing projects held up for the forest land, maybe clearances from the Minister of Forest and Environment. There are some projects under inquiry, ongoing projects. So all these have been highlighted over here. So at a glance, you can see what are the projects in a particular district and what is the status, whether they are completed or they are ongoing or whatever they are held up or whatever the any clarification they need, clearance from any department. So everything is put it together so that the decision makers like secretariat level or the senior officers like chief engineer, so they can see entire thing at a glance. Now another activity that is again related to the, now what we talk about, we are talking about the water resources that covers the surface water resources as well as groundwater resources, everything, aquifer mapping and all those things. So for groundwater, the impact, this watershed development is one of the very major activity happening throughout the state and throughout the country. So once it happens, then we are there to assess it. So with the impact assessment, what we call. So this is the impact assessment done using the different satellite data, pre-project data and post-project data. You see, this is part of Badnapur Taluka in Jalna district. So this is the satellite image of January 2006 and this is the satellite image of January 2010. So within this 4 year, lot many soil water conservation activities have been done in the area, and they asked to assess it using satellite data. So you see, while doing any comparison or the impact assessment, we need to have the satellite pass of the same time. Like, you know, the upper image is 19th of January and the lower image is 17th of January. I mean, they are very close. Or maybe within 5 days or week or fortnight, that also. We can't compare the satellite data acquired in the month of December, and that cannot be compared data acquired in March, April, May. So that will not be a logical thing. So whenever we do the impact assessment or any change detection study, we assure that, or we will see that the pre and post data is of the same season or same with some technically sometimes we may not get the data of the same date, but it should be a very close date so that we can logically or scientifically compare the two data sets, and after that we can create the statistics like this. So what are these are the major areas: water bodies, vegetation areas, non-vegetated areas, because water conservation activities are very small activities. Cement nala ban, mati ban, the percolation tank, or even your farm pond. So they are not like reservoirs, big activities. They are small activities. So their impact is, of course, number of the activities are more. So we can see the impact which is visible on the ground. So we can see any new water bodies have come. If you see this area, if you see this area, the number of bodies, you can see there are 2-3 more water bodies have been come up. If you see this greenery of upper and lower, if you highlight, if you focus on this area, Rajewadi, here you can see earlier the vegetation was less. After implementation of activities, it is having a more impact. So vegetation intensity or vegetative cover has been increased. That also you can see. So we can see the same area by comparing its pre-satellite image and post and the actual structure on the ground. We can go with the mobile application or even our own application. There are so many geotagged application freely available on the Play Store. So anybody can record the latitude, longitude, or anything on the ground, and that captured photographs can be compared with the satellite data. If I see something on the satellite data which is visible, so that means it should be existed on the ground and it will be there. So we have to go there and capture the photograph. Now this is another area like earlier I was talking about the pre-monsoon and post-monsoon. Now here you see these are almost of the same season. Like this is the Bajra Reservoir in Bid district of Maharashtra. Here you see in the year 97, 99, 2000, the water level or pre-monsoon water level was very good. Post-monsoon, I'm sorry, it is a post-monsoon. It is taken in the month of November. So pre-monsoon, it would be a very minimum water level will be there. So then gradually what happened, because of the pattern in rainfall, maybe any reason, or maybe the siltation or so many other activities, the water level has gone down. So we are mapping such reservoir. This is one of the example I am putting here, but we are mapping all the like Ujni Reservoir or Koina, or you take any Jaikwadi or all any major project or medium or minor project. We keep on and we are not doing this by visual interpretation through the software or through modeling. We are capturing this database for the all water bodies in the state. Now this is another project, that is the Mazalgaon project. So this is same condition. Now you see, because of sudden rainfall coming anytime, anywhere, and we are facing the flood situations. So in such cases, we can see sometimes with 1 or 2, 3 huge water spill, the reservoir or that water body gets filled up. And once it is completely filled up, then there is a issue of if further heavy rain comes, then it leads to the creation of the flood situation. So then controlling the water discharge, that everything is they have to look into this water resource department. They are the main people, or they are the civil engineers who are looking after all this and situations, different situations like flood situation. This is one of the application which I developed in my office in Pune. Gunjavani closed pipeline irrigation. Gunjavani is there in Pune district. So this is the water Gunjavani reservoir. This is the Gunjavani project. This is the Neera Dam, and then this is the Gunjavani command area. So as per the original project proposal, it was a open water command area, like as usual the other command areas. But after some time, they thought of having closed water line pipeline. So then so that water can be served to the end user. There will be minimum wastage of water or the seepages, leakages of water, or so that it can be avoided. And I think the most important thing is there will be a lot of nowadays land acquisition is a very big problem everywhere, not only in Pune or in Maharashtra, but everywhere. People are not ready to give easily their land, and they are having their livelihood and their rights. So considering that also important aspect of land acquisition, this closed pipeline irrigation project is a very good option, and it is being implemented now. This L&T has got the contract for this particular project, and whatever the MRSAC has given all the details, you see all these entire details up to the end user, like who is the landholder, that level information or the project details has been shared by MRSAC with the department. And with that, like canal alignment provided by WRD, 5-meter contour data, because it is a planning data. When they do for implementation, they have to do again a ETS survey or maybe very minute survey, so that it will be meter or sub-meter level survey. Because by that time we were having only 5-meter contour generated from SRTM data. Now what I earlier mentioned about the Mahabhumi project, wherein we have created a 50 centimeter digital elevation model. So there we are going, we have created 2-meter data, or we can, with interpolation, we can go up to 1 meter or maybe half of the meter. So that data is very much useful to the water resource department. And then we are having this cadastral data, then road network, drainage network, water bodies, then administrative boundaries like taluka and district. So this entire activity has been done within a week. So you see the power of GIS and remote sensing. So that well, since the data was already created by MRSAC or it was already available with MRSAC, that can be put to use. If we go at if we start from the creation of the database, then it might have taken months together. This is I'm going one by one activities. I'm just different kind of activities. I am just showing it to you, or I'm demonstrating to you. So this is another activity. Like Namami Gange project is there in Uttar or in North India. So similar kind of project is there in Namami Chandrabhaga. Our Bhima river is called Chandrabhaga river. So that is also facing a lot of problem, pollution problem and flood problems, and so many things are there. So under the project, like it is a chief minister's like in a flagship program, that is the Namami Chandrabhaga project for river basin, Bhima river basin. So they came to us, they want to plan this. Then we whatever the data. So initially we have to start with the administrative setup, where the basin is there, what are the area coverage of that area of interest of that basin, then what are the talukas, districts. So like this is the administrative setup. This is the ridge line of Bhima basin. So it covers this much part is in Maharashtra, then it goes to the Karnataka. So this Bhima basin is in almost 5 districts, Ahmednagar, Pune. We see Bhima is there. It is not connected as to Sangli, but it is connected. The part of Atapadi Taluka is part of Bhima basin. Then Sangli, Solapur, Satara. So these are all the districts and the respective talukas which are there. Not only that, we can see all the the water bodies are the big reservoirs, rivers in this western part of the basin. How the basin is then this is the Ujni Dam, which is the biggest reservoir constructed on the Ujni or the Chandrabhaga river or this Bhima basin. Now you see these are this is the basin. Then which are the tributaries or the rivers which are part of the Bhima basin, Man River, Nira, and all these are the major rivers which are the getting connected to the Bhima. Bhima river basin. Then these are the some details we have to give. As per their need, departmental need, we keep on creating such a database. So they will create a nice, colorful report and they present to the concerned minister or the concerned higher authorities and they get the proposal. And then this is another project, that is the SEMA Command and Canal Area Network. This is the SENA project in Solapur district. So this is the SENA river and this is the canal, left canal and right canal. This is the right and this is the left canal. And how much now it is the objective of this project is to make the assessment of this or potential assessment of this command area. So how we did this, I will show it. So we took the help of satellite data. So satellite data procured from NRSC, we have to first georeference it. Now it is coming as georeferenced data. But since as a state agency, we are having our own projection system. If the data provided by NRSC doesn't match with MRSAC projection system or the MRSAC database, then we have to again georeference it and we have to match it, because matching is a very important aspect in this remote sensing GIS. Whatever we are doing a lot of overlaying. So unless or until they are perfectly having a matching in at coordinate level, that will not it will not be useful data, because then it will lead to many errors. So that it is very big, very important precaution we have to take into consideration. So this is the entire NERA command area. I'll go to. Now then we have created a complete land use of that area. So not only the NERA under command area, outside command area, now there is a lot of lifted irrigation which we can't map as a command area, because that is having different schemes and many people they are using. They are not so the irrigation department or WRD, they are having the data, but mapping of the lifted irrigation area is not so easy, because it is not controlled by any feature or any controlling like canal or something on the ground, because the people the farmers, they are directly putting the pipelines and taking the water lifting from the different sources. Now this is the data again. This is the with respect to the command area, SENA command area. Then I'll come to this was the another area wherein we can assess the different command areas. Now the another application of remote sensing and GIS is that disaster management. I'll come to the disaster. Now we are well aware of what happened in last week or 10 days back in Maharashtra. Still people are suffering. People, they are not getting the whatever they have lost, or they are not getting. Many people are helping. It is again a socio-economic issue. many NGOs on individual level also people are helping to the affected people. Then what we can do? We can do the preparedness. So what happens if we are prepared? There is a department, water, this is the disaster management cell at Mantralaya. One IS Adhikari, IS officer is heading that department, and and every district is having a district disaster management plan. So preparedness things are there, still they are there, but that sometimes because of the negligence or something, they are not being kept updated. So if preparedness is having some information about the, if suppose boats are there or any people who wants to help the in flooding situation, their contact numbers and some of the local things that needs a regular updation. So preparedness is the basic thing. Then prediction is again we have to look after the we are dependent upon IMD, Indian Meteorology Department, or some SkyMat, some government private agencies. So they are giving the predictions through, now we are getting predictions through WhatsApp or through portal, through television. Then the damage assessment. So once then here is the between the prediction and damage assessment, there is the incident. This is the incident line. This place the disaster happens, and once it happens, then we have to do the damage assessment. Now we are doing the already we have done the started this activity for Kolhapur, Solapur, and the Konkan area, and then in damage assessment, we can see the loss of properties, loss of human being, cattle, everything that has to be assessed, and then comes the rehabilitation. So if like that one village is that is having, because of the landslide, the entire village they got affected. So now the government, honorable CM has also declared that there are so many villages in the western Maharashtra or in Konkan area, they are vulnerable to uh, this kind of disasters. So they need to be mapped, they need to be rehabilitated. So again, that activity will definitely come to MRSAC, and we have to get involved into this rehabilitation. Then where to rehabilitate, the potential sites of rehabilitation. That again we have to analyze and submit to the government. Pre-disaster prediction pages is for preparedness of advances to the handle the disaster. So pre and post, there are the two pages. Preparedness, if preparedness is at a very good level, then there will be minimum damage, and once it happens, we have to go for the this assessment. Okay. Then an example of disaster management activity using remote sensing GIS. Despite limitation of cloud cover and long revised periods, satellite have been provided vital information towards precipitation of forecasting of the warming, inundation mapping and damage assessment, flood plain management. Now you see, you might, everybody knows that optical remote sensing and then micro remote sensing. So in particularly monsoon area, we can't get the cloud free satellite data. So though we are having a better 1 meter resolution or the 50 centimeter resolution, because of the and flood happen, one flooding area means there are clouds, heavy clouds in atmosphere. So we can't use this satellite data. So here we have to use the radar sat data or the micro satellite data. So through micro satellite data, we can assess or we can come out with the inundated area mapping. So which are the locations, places which were underwater during the flood situation, that can be mapped, and that we are doing it with the help of ISRO, MRSAC, and that management, water resource department, and disaster management cell. Now you see there are also again some modeling is happening or the prediction. So if we have a big reservoir like Uzni reservoir or any reservoir is there, from where in flood situation they have to release the water. So then the flood level prediction for 1 hour after water release. So if a particular cubic of water is being released, 10,000 cubic or maybe 25,000 cubic. So if we release the water within 1 hour, how much area is going to get affected, that can be seen over here. So these are modeling can be done. We can do the modeling. There are different models are available, and we can also create in GIS our own model, and we can predict which are the probable area which may get affected if we release the water for 1 hour for this particular discharge. Likewise, if it's 1 hour after 5 hours, what is going to happen? So area after 5 years, if continuous situation happens, then definitely there will be an increase in the flood situation or the area underwater. Then after 10 hours, again it will, this is a period, it will start raising, and then once we stop discharge, it will come down to its original position. So both way we can keep on monitoring the flood situation or the water spread on the ground. Now this is the case study of 2019. Now whatever the current flood situation, we are studying it. The study is in process. We are not yet published the data, or we are not yet submitted the data. Some of the inputs, very primitive inputs, we are already given to the government of Maharashtra. But detail mapping or detailed study is in progress. So now what I am showing you is the what we did in the same situation was there in 2019 also, 2 years back. That time we used the radar sat data. So this is the Maharashtra heavy rain near real time inundation mapping. This is the near real time. So like for optical remote sensing, we have to wait for some time. But through this NRS, this satellite network, in-house, but Indian network as well as foreign network, so ISRO or National Remote Sensing Agency, they are providing near real-time satellite data, that is the optical satellite data or the radar sat data. So you see, the flood happened on 6th and 9th. So immediately on the same date or maybe on the next date, we could get the satellite data. And on the same data, by that time, the flood was there, the water, standing water was there, and it has been properly mapped using the radar sat data. Now you see Kolhapur, and every time our entire database, GIS database, is in a very standard format. If I talk about the administrative boundaries, they are having the census codes properly, village code, taluka code, district code. Like if it is a watershed, it is having one assigned code by GSD. So everything is having its own, so that it will be for portal development or for any customization or modeling. We need to have a structured standard satellite database, the GIS database or satellite data or any database, so that we maintain the entire database. So here you can see which were the most affected talukas in Kolhapur. Sirod was the most affected area, having more than 15,000 hectares of the land was underwater. Then Ghatkalangle and Karveer, that is Karveer or Kolhapur, and then Kagal. So these are the talukas, 4 talukas. Every year they are facing this flood issues problem. And these are the other where there is a less problem or very small area that is undergone for flooding. Sangli is another area, Miraj, Tasgaon and Valwa. So these 4-5 talukas from Kolhapur and these 3-4 talukas from Sangli, every year they are facing the lot of problems. So then distribution, this is the list of the hierarchies, or who are the from whom we have taken the satellite data. That details are mentioned here. Now you see actual, this is the data. You can see this is a 3D satellite data. And this is the digital elevation model created through the SAR data or the radar sat data, radar sat 2 data. And here we can see these are the major rivers, and this cyan color, this light blue color, that is showing the actual water spread during the flood. And that has been again validated with the ground data, because this revenue department, they are having because they have to do the Panchanama while giving the compensation, they have to complete all the administrative procedure of the government of Maharashtra. So we are referring that their field inputs with satellite derived inputs, and we are trying to correlate it, or we are trying to validate it. And we found that it validates around 90-95%, at least I can say 90% matching we could found whatever the data field machinery has captured and the satellite data. Now this is again the zoom area. You see, this is the Sirod Taluka of Kolhapur. This entire area, every year there again there is Almaty Dam. That is also one of these disputed issue. I can't comment on that, whether that is leading to the flooding in Sangli and Kolhapur. That is again debated. Many people talk about that on either side. So but with the satellite data, with radar sat data, we can assess the actual situation on the ground. Then crop area estimation in Kolhapur. Once it happens, then we have to assess what we have seen in radar sat data. So these are the areas they were underwater during the flood situation. Now underwater means the entire crops, the existing there, they are lost or we have damaged that, or so we have to assess that. Again, if we have to go with the catastrophe, what we do on this flood area map, we will superimpose the cadastral map, village map, and then we go to the revenue records. Suppose Gatu number 10 is there, who is the owner of that, what was the crop he has taken, that has been again captured by the Talati and in Satbara. So that data and whatever the what we assess, we are having the flooding data. So we through pre-flooding optical data, we can come to, we are having the, we can assess the data for that particular area for existing crops. So before flooding, what was the crop, that also can be mapped using the satellite data captured pre-flooding. Here we are using the Sentinel data. We used it already. This is activity completed. Similar activity we are doing now for the same area. As Sangli and Kolhapur districts are dominated by sugarcane and have horticulture too, acreage estimation is carried out using satellite data in May. So after June, we can't get the satellite data, cloud-free satellite data. So the last available satellite data was 2000, May 19. As these crops were, because they are the annual crops like sugarcane or the horticulture, we can see their signatures throughout the year. So May doesn't matter. It is a May data. We can see the actually standing sugarcane or any horticulture crop, so we can map it. So all these crops were standing in the field and will also have there during the flood time in the month of June, August last year in 2019. They are liable to be affected due to the flood. So here we have to use the very judiciously and logically the database. Everything, nothing is ready-made here. We have to apply our logic, our experience, and then we have to come out with the solution wherein we have to put remote sensing and GIS technology for the last or to get the output for implementation. This is one of the very interesting in Pune area. So this is the Khadakwasla Dam, and this is the actual current canal which flows through the Pune city and goes out the Pune city. Almost it is within corporation area it is flowing. Now one idea came to one of the senior WRD officer, chief superintending engineer. If we do the underground pipeline to cross this city area, so that will whether it is feasible or not. So that study has been done. The elevation graph of existing has been created using this digital elevation model. Now if we can have a straight tunnel, we need not to go like we have to follow the elevation for tunneling and all that. So lot of area can be, there will be expenditure definitely, but this much land can be available for development. One benefit, sometimes people lose their lives sometimes in when the canal is having the water full discharge. So many things can be avoided if we can have a underground pipeline just to cross the Pune city. So there's such new ideas or some many things comes to their mind, and sometimes it gets materialized on the ground also. So like transfer of Western Ghat or the water to the Eastern Basin. That is also many people are studying that. At many places it is not feasible. They have find out some places where it is feasible, and with some small creation of small dam or by through the tunneling of the through Western Ghats, we can divert that water which is going towards Arabian Sea, that can be diverted to the eastern part of the Maharashtra. So such things are there. So very interesting remote, the very in different ways this technology is being used in the Maharashtra. Now if we see, if the government takes the decision to have an underground canal for the city or maybe pipeline through or anything underground pipeline. So these are what are the elevation areas. So you can see the different elevations that we need to assess the alignment of the proposed, if at all it is a proposed underground pipeline to instead of to close that open canal. So such analysis can be done using the digital elevation model created through the satellite data. Okay. Now these are all the things or what I talked many projects or many things with respect to water resources department. Okay. Then there is another department, that is the water conservation department, or the water like this integrated watershed management, Jal Yukta Sivar, or so many NGOs, they are working on the ground for soil and water conservation, so that the groundwater can be improved, or groundwater recharge can happen. So this is one of the other, that is the Jal Yukta Sivar. It was the flagship program of our previous government. Now there is a Mahagadi project, but this was the project of our previous government. So once they thought of having the water conservation planning, so we have to identify the potential sites for development of the water conservation structures. So where I need to take the barrage, where I need to take the cement band, where I can create a loose boulder structure or any other VAT, or there are the different activities or structures are there, well defined and proven structures are there and approved by the government of Maharashtra. All those structures have to be, that location has to be identified. So to go to that level, we need to have some of the resources data, base like data. Base map, it covers administrative everything, plus drainages, contours, road network, all those things are there. Then we have to refer the contour, where we can get the slope or the terrain, physiography of that area. Then groundwater map, land use land cover map, slope map. Then we need to know the soil depth. What is the soil depth? What is the soil drainage? It is then soil erosion, land capability, texture. So these are all the parameters. They are applicable to all water resources. We can't separate out these from. These are water resources depend upon all these, the basic thematic parameters. Now what we did then, so we have integrated the database with some analysis. We have analyzed the data, all these parameters, what I have shown in my previous slide. So all these parameters, they have been assigned the weightages and they have been integrated. And on the integration, what we got the output, that we have, I'm going to show it here. The union of geomorphology, slope, soil cover will help to identify the 6 important zones in the. So once we analyze them, there are the important zones are there. Every activity is not applicable to any place. So activities related to the zone, like runoff zone, upper recharge zone, lower recharge zone, storage zone, lower storage zone, and then command areas. So what we can do in the upper area, so we can have CCTs, we can have gully plugs or loose boulder structure, earthen nala bund, or another way I can say you, we are having the drainage orders. So what are the activities which can be taken on drainage order 1, 2, 3, 4, like that. So initially, if it is a drainage order 1, we can't create a cement nala bund there because it is a small beginning of the channel. So there we can have only gully plug or loose boulder structures. On second order, we can go for earthen nala bund. On third, fourth structure, we can go for. So these way on the both ways, by the ordering the drainages or by integrating and creating the model, we can identify the locations for soil and water conservation activity. Now you see, this is the satellite based integration. You see, this is the slope area. Now this is, you see, this is particular area is as good as it is the watershed. If you see the satellite image, you can come to know this is the ridge of the watershed, and these are the downslope areas, and water is going out of this watershed. This is the pour point. So from satellite data, what we did, from satellite data, we have derived the geomorphological map. From same data, we have created the slope map using the digital elevation model and contour data, and then we have done the soil mapping also. So this is the basis of the source of the data. These are the derived data. We have integrated all these for a particular watershed. Its name is PGAA4, and then we will come to know that this. If you see the CCTs, where we can do the CCTs as upper ridges or the upper areas or the elevated areas. So this area it perfectly matches. Once we integrate it, and if you see the location on the ground, it fairly matches. The gully plugs are the, first of all you will get the CCTs. After that you have to have the gully plugs, and then earthen nala bund, and then cement nala bund, and then major percolation tank, KTVRs, and then medium measure. These are the things. So as per the order, we can have this. So while doing this analysis, we have done the field visits also. Whatever we have created, whether it is matching on the ground, whether it is fit on the ground, that we have to check before implementation. So that is also very important part of remote sensing activity. remote sensing, this is one of the technology. It is not everything. So that it doesn't cover 100. Once you are using remote sensing GIS, when you need not go to field, it is not like that. So field visits, field data collection, that is equally important, because through this technology we can have more and more accuracy. We can save the time, we can save the money. That is the advantage of this technology. So before that, now you see this is the activity. So with this is the water resource development plan of particular watershed. So Maharashtra is having more than 1,500 watersheds. Then initially what we did the entire Maharashtra at watershed level. So which are the watersheds which are having high priority? So you can see these all red colored watershed. They are having high priority for water conservation, because the water level is less, or there is more soil erosion, or the need of the people, the shortage of drinking water. So considering all these parameters, we have analyzed. So if you can see, these are all the hilly areas wherein there are high priorities, then moderate priorities, low areas or least priority, they are all the command areas. Like this is the Godavari command area, Bhima, Krishna, this is the Krishna, Bhima, then Majra, any likewise Tapi. So command areas having the least priority for watershed development. And there is a thumb rule. If the area or a particular village comes in a water command area, we need not go for water conservation. That is the thumb rule in government of Maharashtra that I can share with you. Now, once we have completed, then we have to create create the output. So that it will be usable to the end user or the implementing agency. So likewise, we have created an action plan of maps. This is the IWMP Integrated Watershed Management Program, wherein we have integrated all this and we have identified this particular drainage line or the is suitable for cement nala. This is suitable for gully plug, earthen bund. This is water body, micro watershed. So all these are, then we have to give the credits to whom? Though MRSAC is created the data in GIS format, but the original data is of that particular parent department. Like we are talking about the cadastral data, that is the data of land records. If I'm talking about the roads, that is the parent department PWD. If I'm talking about the resources, the WRD, canal, command, that is their data. So we are getting the data from the different water departments. So that is why it is having a legality or valid data or authentic data, what we can say. So we are working everything with the authentication. This is again a treatment map of, this is the area treatment map and this is the drainage treatment map. So these are the two treatment maps we create. And likewise, under Jalyukta Sivar, this is the one village I am showing it to you. We have created such maps for 11,000 villages. Among 19,000 villages under Jalyukta Sivar and 11,000 villages under IWMP. Some of the villages are overlapping. So overall around 28,000 village maps on this level has been created by MRSAC and been supplied to the implementing agencies. Now you can see the spatial distribution of watersheds. So under IWMP, almost half of the geographical area of Maharashtra was covered for soil and water conservation activity. I was part of this project since beginning, and at many places very good work has been happened. That again the groundwork depends upon the local people, how seriously or how sincerely they implement on the ground. Okay, these are the some of the details I was talking about. There are 11,000 villages we have covered under IWMP and 19,000 villages under Jalyukta Sivar. So these are the that time, within 1 or 2 months we could create this data. Since everything ready was available with us, we could create this database within a very short span of time. So these are the land use map. Just I will not go in land use map. We are creating while doing the impact assessment. We have to assess the class. Which class has gone to, like earlier I have shown in Badnapur 2006 image and 2010 image. So if some geographical area is not going to change, it is a fixed area. Only the land use is changing. Some of the, suppose agriculture area has gone into built up area, wasteland has gone into the plantation. So that way we have to. So this is the change matrix of that area. So T0 time is base year, then the T1 is your assessment year. So considering this, we can nicely we can analyze which land use has gone into the which other type of land use. Consider, and the net area will be same. Like this one, then check. This is now this area. So these are the areas wherein they have taken the check dams, contour bunding, nala bunds, other. So this field, this has come from the field. So they have gone there in the field with the mobile application. They have captured the data and they have come out. Now you see this is the check dam. Check dam where you can see this is the first order, second order, maybe on third order. Likewise, now you see this is the Nalaband. Nalaband is on at 1 or 2 orders. And this is the check dam. So likewise, we can visually we can analyze or we can assess whether the activity has been properly put at its appropriate place or not. Then to see the change in vegetation cover, we are as usual we are talking about the remote sensing GIS. NDVI is one of the important parameter in our any satellite data analysis, but optical satellite data analysis. So this is the NDVI of particular area in Satara. So this was in January 11 and January 13. You see. So and this is all database digitally derived. There is without any human intervention. There may be some satellite data related errors, but there is no human induced error in analysis of the vegetation cover using normalized difference vegetation index area of this area. Now we and the project wise we are coming with the conclusion. What are the and there are some villages where we could find the negative also. So there is no impact at all. There are few places I can't at this point of time I can't tell you, but we have found both at many watersheds they are having a very good impact. Many watersheds having a moderate impact, but there are few watersheds or few activities that doesn't show any impact on the ground. Then we have to evaluate that thing. What are the things gone wrong, or whether the area selection or the appropriate location activities. So everything we have to be analyzed so that we will not do such errors or the mistakes in future. Okay. Then this is some of the media cover. Pani Prashna or satellite data ची माहिती. He was my earlier director MRSAC. He came from ISRO now. His deputation is over now, and he went back to ISRO. So we keep on interacting with many field people that we sometimes get a media coverage. Smartphone करणार जलसंधारण कामाची तपासणी. So this is happening. We did it, and that has got a very good media coverage. Now I will come. This is all about water resources related activities of MRSAC. So MRSAC is working in very different activities. Like if you consider civil engineering point of view, we are working with the town planning. So they are creating the town planning, various DPs, development plan they create. So that is, but it is not directly related to water resource department. That's why I have not included in my presentation. So we are working with many agriculture department, school, health, you name any government department, we are there. So that way, when our team is very small, like we are around 20 scientists. The total strength of MRSAC is around current the establishment as per record is 52, but we are only 32 people are there. We are also facing the similar the issue of manpower, availability of manpower. So that is something which is not relevant to this discussion. Whatever the data we have created with the different departments, then how to make this data available to their department as well as the public or to the academia. So we have developed the different geo portals. You can take so these are the list of geo portals created by MRSAC for different departments. I will just, since it is having a the data dissemination related, or some of them are in open domain, some of them are having login password, or some of the respective department has not given us the permission to put it into the public domain. So anyway, they are having different status. So like we are having a MRSAC geo portal, that is Maha Geo portal, wherein we have tried to keep all the satellite data, all the vector data or the GIS data. But one thing I should highlight here, the data is for viewing purpose. You can only view the data like how we can view the Google Map or Google Earth that way. Where we can take the screenshot or something that way only. But any data is not downloadable on your system. You can't download anything. But you can see everything, and that will definitely help you. If government gives a permission or any particular department, then that particular department data can be given, and that is again under consideration. Many people are, many departments are thinking in that direction. So near future, we may get this data to public or to the students and academia. Jal Yukt Shivar Abhiyan, it's having its own portal, road information system. So this road information system is having complete network of the state, right from expressway, national highways, MDR, ODR, or village road, or even small car tracks and even footpaths. Whatever was visible on the satellite data and in toposit, that has been captured into the GIS database. Then integrated water information, forest department. It is again one of the major department. So we are working with forest department. So they are having their own geo portal, SIDCO, Maharashtra MIDC, remote sensing GIS based mapping of water supply and sanitation department. This is one of the water related issue I should highlight on this. So water resources, water supply and sanitation department is responsible for water supply to the urban areas, to local bodies, or maybe the villages or small hutments or the settlements. So there are more than 5 lakh resources, water sources from where the water is getting pulled or that it has been drawn for supply. So it could be a tube well, dug well, small reservoir, some in the cluster of villages schemes, corporations, councillors, so many things are there. So entire water resources has been mapped by MRSAC, and for this activity we have got a gold medal in e-governance from the government of India. So this is a very big activity we have done. Then Mahatma Gandhi National Rural, this is the NREGA related scheme. NREGA, they are also doing many activities. So to keep the track on completed activities, ongoing activities, we have developed this portal. Then Mumbai Port Trust, Water Resources Department, what I have shown so many things related to this. Sericulture, GSDA, health, school, municipal administration, disaster management, weather, so many things. So such a small scientific department can do so many things for various departments that you can judge through these portals. So these are some of the snapshot of the actual portals. If you go to MRSAC portal, mrsac.gov.in, you can see all these links for that particular portal and you can view the data. You cannot download the data. That I am again telling you again, data is not downloadable, but you can use the data, you can create the printouts or you can even proper map prints also can be generated in PDF format or JPEG format. So you see whatever I was showing earlier, this is the mapping of land use for JNPT, GIS based mapping of JNPT, national land use mapping, horticulture, desertification is also one of the projects we are doing with ISRO Space Application Center Ahmedabad. Desertification mapping of the Maharashtra state. That is also where the land getting degraded due to the natural phenomena or maybe because of human induced activity. Both the things are getting mapped and we every 10 years we are doing this. So 2 cycles we have completed and we have found that there is the trend is that the desertification is happening in our state. Maybe now it is on a very small scale, but if you consider future, so that may have a very big impact on our land. Then integrated forest management, then this is the MNRDA, PCMC, PMC. So the mapping of even if we are working with this power sector, we have mapped all the high tension lines in the state, all the power stations, hydropower stations, coal. So everything has been mapped. Not only that, whatever this Maha Urja, that is the MEDA, MEDA is having their own non-renewable energy locations like where are the windmills, then solar farms. So everything has been mapped. We worked. So what happens? We worked with the particular department, and we worked that at that point of time, the entire data gets created. Then the future of that project depends upon the line department. If the interaction, if the project activity gets continued, then data will be automatically get updated. If the line department doesn't support or it doesn't come forward, then that gets stagnated there itself. So this is having a mixed database. Some of the database are updated, some of the database they are not updated, and some of the database that doesn't need any updation, like geological map or soil map. So there are such a maps that is not going to change in a short time. So we don't map it again and again. Then I'm talking about the orthorectification of the data. We are having a ground control points throughout the state. Then geoinformatics, mineral. We are working with this geology and mining department also. Where are the these quarries are there, sand mines are there, coal depot, all the whatever the minerals are there and minings are happening in the Maharashtra. That also has been properly mapped by MRSAC. So this is the MRSAC its own identity in the state and at national level as a responding and dependable center. With the commitment and dedicated efforts of the staff of MRSAC, we will always take the lead and remain competitive. MRSAC put on record that excellent cooperation from the line departments. Our governing body. Actually, I will talk about the administrative setup of MRSAC. MRSAC is just a scientific autonomous body of Maharashtra government under the administrative control of planning department, government of Maharashtra, and it is having a governing body. An honorable chief secretary of the state, he is the chairman of our MRSAC body, and the secretaries like water resource department, rural development, agriculture, they are the member of MRSAC governing body, director NRSC, director general of IIT Mumbai, RRSC, forest department, PCCF, mining department. So likewise, there are 13 members, and this governing body will have a periodic meeting, and whatever application related issues, administrative related issues, or any thing government of Maharashtra is thinking in this line. So these things are getting cleared or getting discussed in the GB, that is the governing body. Apart from mapping activities, the main thrust of MRSAC is towards the dissemination of information and creation of application. So what we have seen these so many number of geo portals that earlier we were doing only the mapping, but now mapping most of the part is over. Now we are going for higher and higher mapping. Under Mahabhumi, we are doing the mapping of all the features using 50 centimeter data. But that will take another maybe at least 2 years. It is a huge activity and that is going to take some time. But the first part, that is the creation of digital elevation model, DTM, DEM, and that activity is over. The data is orthorectified. It will so that it will have a proper geographical accuracy, and once that is ready, it will be supplied to the department and maybe in future to the other users. MRSAC has already rolled out the state geo portal or intranet and will make the efforts to host the internet hosting policies. So we have to, being a government organization, we have to follow all the norms of government of India or maybe the government of Maharashtra. We have to take them into confidence, and then only we can publish the data or we can disseminate the data. Now, this is my last slide, but it is a very important slide. You see, what was the Dr. Vikram Sarabhai? He was the founder of ISRO, or is the man behind what we are seeing the space technology in our country. So his vision was, the space technology should be put to use to the common man and the people. That was the vision of the Dr. Vikram Sarabhai. So we must be second to none in application of advanced technologies to the real problem of man and society. And we are going ahead with this vision of Dr. Vikram Sarabhai. Just to show his vision or how he was a visionary, that is the just downside. Once Dr. APJ Abdul Kalam said, I was spotted as a young scientist by Vikram Sarabhai. Means you see the person, he judged Dr. APJ Abdul Kalam at that stage when he was a young scientist, so that but he see the vision, how visionary he was. You can, with this statement of Dr. APJ Abdul Kalam, we can judge that. So because of his vision, we are here as a space technology, maybe through ISRO or different states are having their own remote sensing or space application centers. So MRSAC is for Maharashtra, it is Maharashtra government organization, or we are working for Maharashtra. With this, I will conclude my presentation. And thank you very much, Nimbadkar sir. You have given me the opportunity to interact with all the people on this occasion. Thank you so much, sir.
Actually, sir, we must thank you. So, on behalf of actually all the participants and our institute, I'm very much thankful to you, sir, for sharing a very nice information and the work that your department is doing, and the tremendous potential that this particular technology that has.
Yes, sir.
So, sir, before concluding,
Ah.
there are some questions. I think I will just go through it.
Okay, sir.
Uh, uh, that Mr. Sandeep Shishode is asking, where can I get updated administrative map of Maharashtra? And
Okay.
why do we use British map?
Correct. So administrative setup is such a setup that doesn't need updation. In the sense, updation when it happens, you see the state boundary not going to change. District boundary is the next level. So whenever there is a creation of a new district, then only the updation will come. If new taluka, new village, that is again a process. It is happening. We see the what we have, number of district in Maharashtra 10 years back and today. So district may be new district may be created by the time. Administrative boundaries are the government decisions. Unless government take some proper decision for bifurcation or submerge or clubbing some administrative units, we don't need any updation. One thing again, I will go a little bit detail. We have geo-referenced all the village maps. 44,000 village maps geo-referenced using the PAN data in 2001 to 4. So that was that data. So whatever the district taluka bound, I will just in short, brief, I will explain you. One village we have geo-referenced. Then we have geo-referenced the adjacent village. Then adjacent village. So when we geo-reference two villages and when we put together, they were not perfectly matching. Either there was a gap or there was an overlap. So we have sorted or we have resolved all these issues by taking satellite on the background. Satellite was showing the village boundary as a bund or maybe the common river or something. So by taking some natural feature which is visible on the satellite image, we have fixed the boundaries. So that way, by resolving all these overlapping and underlapping issues, we have matched all the villages like first village, second, then we have created taluka, then district and whole state. So our data is of that level. If I am saying my district boundary means my district boundary is matching with the villages on the boundary of the district. This is the level of data we are having. Now updation is again, it is very good in context of this technology upgradation can happen and we are doing it under Mahabhumi. Now earlier we used 5.8 meter PAN data. Now same activity it is ongoing activity we are doing with the 50 centimeter data. So with the resolution, high resolution, there will be definitely upgradation or the changes in the these boundaries. So once it is completed, again Maharashtra government will have a updated or more accurate administrative boundaries.
Okay. Actually, there is one question that is there. How can we control urban flooding? So this may actually.
No, sir, there is a committee formed by the government of Maharashtra to study the flood situations, and I'm one of the member of that committee. And just now we have visited the Bhima Basin. So MRSAC is part and parcel of all the flood committee, like what I have shown for the 2019 floods. So similar activity we are doing. So all these things goes to the committee. So committee will assess what are the reasons or causes of flooding and how it can be mitigated or how it can be controlled. So that is a very big area. And the very in near future will get the reports, authorized report, the government approved reports in this regard.
Okay. Okay, so I think, sir, there are no more questions. I wanted to ask you, sir, like suppose
sir.
our students, we want to, they are.
Sir. Sir, you are not audible, sir. Sir, you are not audible.
Not audible.
Now it okay. Now it is restored. Yes,
Regarding the undergraduate and postgraduate projects or dissertations they are doing, whether your office can help us in
definitely.
working.
As in my resume, I mentioned I guided so many people for.
Yes.
So that is what. But the modality is that if they are having suppose 6 months or 4 months dissertation time or that academic time for completion of the dissertation, they can come to MRSAC. So if they come to MRSAC, we'll share everything what related to his project. We'll share it without any charge, everything. But the thing is that he can take only the output with him. He can create a dissertation report. We will not allow him to carry the database. But he can use our data. He can do the studies or whatever ideas he is having. He can. We'll give complete freedom, all facilities. Very latest softwares, everything is there. So I normally in Pune office I take 4-5 students every year.
Okay.
Yes, sir.
Okay, sir.
And even then, if somebody needs somebody needs some layer specific small requirement is there, I'm always there to help the students.
Okay, sir. Okay, sir. Then, एक minute. Just let me see if any. Okay, so there are no many questions. So we are once again, sir. I will thank you for
Thank you, sir.
sharing all the information and very wonderful session that has been conducted. Very highly informative. Okay, thank you.
Thank you, sir. Thank you from my behalf and my office. Thank you, sir.
Okay, okay,
Okay.
okay.
Shall I quit, sir?
Yes, sir. Yes, sir.
Okay.
Yes. See, for the participant, next session will start at 2:30. Participant should note that next session will start at 2:30. कालचं त्या शमिता मॅडमचं आता चांगलं होतं बरं माहिती सांगितलं. महाराष्ट्र रिमोट सेन्सिंग ऍप्लिकेशन सेंटर पाटील पुण्यात आहे त्यांचं. कोण होते पाटील म्हणून काय झाले जेवणासाठी अर्धाच केले आहे ना त्याच्यामुळे लोक आता बाहेरच जातात आणि काय झालंय एकमेकांसोबत अशी एकमेक आणि बाळासाहेबांची ऑर्डर असल्यामुळं गव्हर्नर एक तास किती
त्याच्यामुळे शिक्षा सगळ्यांना मिळाली. माझं मत आहे.
एक तास एवढी सुट्टी काय करत नाही. हे सगळं सगळं डेटा सॉफ्टवेअर सगळं आता फ्री अवेलेबल आहे. सगळं काही द्यायची गरज नाही. पुन्हा फक्त हे पाहिजे म्हणजे रिमोट सेन्सिंग जे आहे सगळं फ्रीली होते आता. काल त्यांनी ते सांगितलं
बरोबर आहे.
डेटा पण मिळतो म्हणजे आता.
माझं काय म्हणणं आहे की हे जे आहे वेबसाईट सिलेबस मध्ये टाका ना. ये ओके ना. जाऊ तू जेवायचं नाही. ते स्पायरल बाइंडिंग पाठवते 2 पेपर. बघा मिनिट्स ऑफ मीटिंग, त्यानंतर स्ट्रक्चर आणि त्यानंतर सिलेबस बोलते सगळं बरोबर. आयत्या पाहिजे घेतले. ओके. होतं मी बघतो. बरं बघतो. येस ऑफकोर्स मला किती. ओके ओके. बरं तू कितीपर्यंत आहे. बरं चालेल ठीक आहे. ओके येस ओके. हा ओके. तयारी चालली सगळं 30 किलो त्यात ते सगळं बसलं माहिती. हो वेइंग मशीन घ्या घरी. आणि रेडी टू इट बऱ्यापैकी पॅकेट टाका त्याच्यात. ओके ठीक आहे. हो उद्या देतो चालू. हो 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 संतोष. आणि आता दुसरं काय म्हणतोय तुम्ही मध्ये जी शाखा काढलीच नाही ते करेक्शन केलं ना. म्हणजे मी पाठवायला लागलो होतो ते म्हणजे त्याच्यासाठी मी सिलेबस परत पाठवलं. स्ट्रक्चर मध्ये जे आहे तसं त्या सब्जेक्ट मध्ये आहे ना तेवढं फक्त बघतो. काय करायचं ओरिजिनल स्ट्रक्चर बघायचं. आणि उद्या सकाळी दिवशी काढून दिलं तरी चालतं.
तेवढे प्रोजेक्ट ते करतात काय करत म्हणजे नुसतं वॉटर रिसोर्सेस तुम्ही काय करतात?
तो आपला विषय आहे त्या लिंक आहेत ना त्याच्यावर आपल्याला आवाज काय म्हणतो म्हणजे मग तुम्हाला सुद्धा भविष्यात शोधायची वेळ येणार कारण आता ऐकलं छान छान वाटलं तू पुढं आपल्या प्रायरिटीबद्दल तुम्ही विसरून जा. खरंच जर विद्यार्थ्यांना करावं वाटत असेल तर त्याला सिलेबस हा एकमेव आहे.
प्रोजेक्ट मध्ये त्यांनी म्हणजे प्रोजेक्ट वगैरे असं करू
एमटेकची घ्या ना मग
ते म्हणजे आणखी 4 मुलं तरी घेतो म्हणजे
कुठली असतात
ते नसणार
बोलायला सुरुवात केलं ना की सगळं बोलायचं सोडायचं
ते म्हणले आम्ही
कुठे सेंटर
आणि कुठे माहित नाही ते कोणत्या संताकडे दिलं होतं माहितीच नव्हतं आणि इतकं असं इमोशनली आपण काय हे पण नव्हतं.
मला पण सांगा बरं कसं
हां त्याचा ॲड्रेस असंच येतं महाराष्ट्र रिमोट सेन्सिंग ऍप्लिकेशन सेंटर त्याचं मेन त्याचं ऑफिस ते नागपूरला आहे आणि इथं पुण्यात हे पुण्याचे हेड आहे.
आपली मुलं मला वाईट कधी वाटत नाही पवार मॅडम त्या मुलांसमोर चांगलं काम करून घेतलं एलसीआर मध्ये पेपर पब्लिश झाला तुमचा माल सुद्धा झालेला नाही आहे पुढच्या बोलून ऑपरेट केलं आणि ठीक आहे पिढीच आहे आम्ही काय केलं हे बक्षीस का त्या एलसीआर मध्ये पेपर पब्लिश केलं हे बक्षीस तर मुलं कशी असणार फुकटची मार्क पाहिजे त्याला मोबाईल पडलं ते फळाच्या गळ्यामध्ये पोरं बांधायची दाखले काय झालं का ओरडले असं का आता 2 वर्ष झाले आता पुढचं बघा कॉन्फ्लिक्ट करतो थोडा काय विषय झाला ह्याच्यानंतर बहिणी आमच्या तिचा आवाजच बंद झाला त्याच्या आता काय पैसे कळत आमच्याकडे होती ना 85 वय करतो 85 आहे आपण गावात म्हणतो आवाज बसला वाच्या बसली असते तर आईला घेऊन आईला घेऊन 2 वर्षातून ऑपरेशन ती करून म्हणतात डॉक्टरमध्ये काय ना तुम्ही घेऊन जाणार गावात काय होईल तिला घेऊन आलो वाकडे कसे आलो 2 वर्षातून आई इकडं 10 वर्ष केली कोरोनाच्या लग्नाला गेलेली तिथं राहील आता इकडे तिला खुश आहे मला इथं राहायचं ठीक आहे वाकडं कशा आल्या कोणाला तिथून तिला मग करता तिथून आमचं राहणार त्याच्यामुळे माझ्या सगळ्या त्या गावात मला घरी येणं गरजेचं लगेच तुमच्या आईनं कळलं का हो सांगा ना काय पोलीस केस वगैरे काय नाही पाहुणे एकटेच होते तिथं पाहुणे मी कंपनी कामावर गेले सोसायटीच्या लोकांनी ते हे केलं रिलेटिव्ह पोलीसमध्ये त्यांना रिलेटिव्ह पोलीसमध्ये त्यांना सांगितल्यामुळे त्यांनी मॅनेज केलं इथूनच गाडी पुन्हा ॲम्ब्युलन्स आणि दुसरी गाडी सगळं गाड्या गावावरून कडेगाव तिथून इकडे आल्या फोन केला तसं आम्ही करतो कुठं त्या कोणाकडे त्या पाहुण्यांना पोलीसमध्ये त्यांना सरळ सांगितलं की आम्ही गाडी त्या गाडीची घालून काही नाही बघा तिच्या त्या शॉपिंगमुळे आम्ही सगळ्यांनी एका दिवशी सगळं होता ज्यांना माहिती ज्यांना कळलं तेवढं बाकी कळवलं मग ती येणार ही गाडी येणार हे फ्लॅट आता जवळजवळ 1.5 कोटी कुठं चांगलं सारा म्हणतो नाही येईल बरं घाटकोपर पासून आपण लागतोय आम्हाला सुद्धा काय आणि आता काय झालं मुलगा एक मुलगा आहे मोठा आहे भाऊजी कोणत्या कंपन्या चालेल काय TCS रिझल्ट लागल्यानंतर झालं का रिझल्ट आला माती ऍडमिशन सुद्धा बोलून जरा मॅडम काय म्हणाल्या असं झाले मोठे भाऊ आहेत का खूप छान होतं आवाज फार डिस्टर्ब होता
ते मधनं हे होत होतं त्यांचं काय माहित नाही
माझं ऑफिस आहे. बघा काय झाले रक्तरंजित क्रांती.
आत्ताच ऐकलं का आत्ताच यांचं ते पाटलांचं याच्या कालचं त्या शमिता कुमार आणि यांचं आता होतं ना म्हणजे तेवढं ते
रेकॉर्ड केले का?
रेकॉर्ड चालू आहे ते रेकॉर्ड ते होतं ऑटोमॅटिक ते पीडी पॅटिक करतात सांगितलेले ते कारण ते
गोष्ट आहे रेकॉर्डिंग 10 दिवसात मागून घ्या.
बरं
सगळं झालं म्हणून काय म्हणून पाठवायला तिकडे
हो तिकडे पाठवायचं त्यांना
मग
प्रॉब्लेम येणार आहे.
कोणाचा
मध्ये व्हिडिओ पाठवला होता ना
हो हो
ते गॅप होईल ना.
हो
थोडा विश्वास तुमच्यावर पण आहे. विश्वास आहे का तुमची ओरड आहे. 225 रुपये किलो सुद्धा थांबवणार. काय त्याला गाडीसाठी फ्रीज घेऊन आला सवाल एवढं बिल कसं मंजूर करून द्यायचं. आता माझे खेळ पैसे गेले पुन्हा मला फक्त मार्ग इतिहास भविष्य काळ आठवत नाही. 60 रुपये वाली महत्वाची
पाठवून द्या म्हणजे करून पाठवून द्या म्हणजे खर्चाची पावती नाही रोज पाठवून द्या म्हणजे माझा तो एक पुढचा मार्ग आहे. आता सकाळी जे रिक्वेजिशन दिलं ते समजा
झालं नाही आपण सर्व दुःखी बरं आमच्या घरात मी एकटाच काम होत आहे.
आमच्या घरात काय आहे माझ्या घरात मी एकटाच आहे.
तुमच्या घरात नाही आलं
माझ्या घरात मी एकटाच आहे म्हणलं
नाही जाऊ आहे ना एक आहे नाही घ्यायचं असं पण आम्ही काय
जास्त मोठ्या बोलू नका. तुम्ही ऐकलं त्याला खरं वाटायचं. जर तुम्ही ऐकलं
तुमची इच्छा पण बघा दुसऱ्यांना खरं ऐकू नये.
आपल्याला खरं वाटेल असं म्हणालो मी
ते सांगतोय मी म्हणजे आम्ही खरं बोलतोय दुसऱ्यांना ऐकू नये अशी इच्छा आहे. अरे अरे पापाचं भेटलाय सण होणारच नाही ना. आम्ही बोललेलं खरं बोललेलं दुसऱ्यांना ऐकू नये इथपर्यंत तुमची मदत गेलेली आहे. पाप आहे बघा सगळं
काय नाही त्याच्या एवढं
सांगायचं कसं त्याला जिंमत दुसरा माझ्याकडेच होत नाही.
काय
भाजीत तेल हो
तुमच्या लॉजिक प्रमाण भरपूर झालं. तुमच्या लॉजिक तुमच्या थिंकिंग प्रमाण ते भरपूर झालं. तेवढं त्याला
क्लायमॅक्स काय माहिती आहे काय ती भाजी मीच केली. आपला आहे एक सेकंड.
आता तुम्ही कोणाला बोलता?
फक्त त्याच्या पुढची गोष्ट काय आहे? ते हे ते ना टेक्निक हे मी निश्चितला विचारून काढतो.
क्लायमॅक्स होतो.
त्याचा तो म्हणजे मी असं म्हणलं तुम्हाला कळत नव्हतं. त्यात आहे हे वाक्य म्हणजे दोन अंगलट तरी येणार नाही. तेवढं दोन तर जायला नाही. एवढं पाहतो मला काय म्हणायचं घ्यायच्यात ना शिक्षकांच्या बाहेरच्या त्यानुसार प्रिंटआउट काढलेले तर त्यांनी संबंधित शिक्षकांना येणार त्यांचे फीडबॅक आला ते सोडून जे होते ते सोडून
बाकीचे
दुसरं पाहिजे पुढे मोठ्या थोडस मोठा असा असावा त्यांनी असावा अनुभवी असावा जिज्ञासू असावा हुशार असावा
बरोबर तरी तू कसंही करायचं
फुकट काय करायचं आम्ही मान देतोय त्यांना भारतीय विद्यापीठाचे नाव येणार आहे
सही करायची एक संधी देतो
मान आहे
शिकायचं काम देतो
कंट्री गेलेच म्हणतो
मी तुम्हाला विचारणार होतो
हा आलं 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 बघा सर. ओके.
काय नाही बाबा निवांत आहे. जेवण झालं की फोन पाहून चालतं.
टॉप व्हिडिओ. ओके. हॅलो.
नाही सर चालू आहे काय आता काय. होय ना. सारखे वरच राहायचे.
अच्छा. हॅलो.
हॅलो सर. हॅलो,
हा
आवाज येतो का सर माझा?
हा येतोय येतोय. हॅलो.
हा,
माझा येतोय ना? माझा येतोय ना?
हो येतोय येतोय.
हा बरं.
तुम्ही आता ऍडमिन म्हणून म्हणजे इथं कसं ऍडमिन आलंय.
तुम्ही को होस्ट आहे काहीतरी.
हा मी को होस्ट आहे.
हा
तुमचं
आता
ऍडमिन म्हणून आलंय. बहुतेक आता ते तुमचं नाव तिथं एंटर करावं लागेल. म्हणजे तुमचं नाव येईल तिथं. मी ते सांगतो आम्हाला. तुम्हाला शेअर करता येते का बघा, खाली शेअरचा ऑप्शन आहे.
रिॲक्शन. हा अच्छा.
शेअरचा
ओके.
ऑप्शन आहे बघा खाली.
स्विच ऑडिओ, कनेक्ट टू व्हिडिओ सिस्टीम, कॉपी मीटिंग लिंक. अरे बापरे.
नाही, खाली खाली तुमच्या याच्यामध्ये शेअरचा ऑप्शन येतोय का? थांबा, तुम्हाला इथं
शेअरचं नाही येतंय मला.
थांबा एक
शेअर
मिनिट.
कंटेंटचं ते ऍक्टिव्हेट नाहीये.
थांबा थांबा एक मिनिट.
हा
तुम्हाला
आत्ता
त्यांनी
आलं.
आलंय का?
आत्ता आलं. हा
आलंय ना?
आत्ता आलं. हा बरोबर बरोबर. आत्ता
हा हा
आलंय.
हा.
आत्ता आलं सर मला.
हा, तिथं तुमचं ते पीपीटी बघा बरं उघडून. तिथं त्याला शेअर करता येते का? शेअर म्हणा आधी. शेअरला क्लिक करून मग
शेअर
हे करा.
केलं. मग विंडो करायचं का?
शेअर म्हणून मग आपण जसं करतो ह्याला. सर आता इथं ह्यांना शेअर करायचं असेल तर
विंडो
म्हणजे इथं
विंडो
शेअरला क्लिक करून हे करावं लागेल ना.
टाईप करावं लागेल.
हां,
शेअर करायचं. खुर्ची विंडो येते.
त्यांना आली असेल का तिथं? हा शेअर
तुम्हाला आहे का शेअरची?
आता इथं खाली दिसतंय तुम्हाला शेअर आलाय का सर खाली?
हो आले शेअर आले शेअर
हा
आलं होतं.
मग तिथे क्लिक करून त्यांनी
प्रेझेंटर केलेलं.
हा प्रेझेंटर केलंय मी आता त्या ते आत्ता ऍक्च्युली ट्रायल बघतोय उद्या आहे त्यांचं शहापुरे सर.
हॅलो
हा
माझं हे डेस्कटॉप दिसतंय का सर?
यू आर साइन्ड ॲज
हा हे डेस्कटॉप दिसतंय
लॉगआउट
म्हणजे माझं स्क्रीन
हो
दिसतंय तुम्हाला?
हा लॉग आउट वगैरे असं ते हे येतंय.
एक मिनिट माझी स्क्रीन दिसते ना आता म्हणजे?
हो 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 हो
ओके एक मिनिट सर एक मिनिट
पीपीटी बघा टाकून.
ओके एक मिनिट ना सर बघू आता दिसतंय ना माझं डेस्कटॉप?
थांबा आता नाही दिसत आहे.
आता नाही दिसत
लिव्हिंग थांबा अजून तर नाही आलंय कदाचित वेळ लागत असेल थोडा.
दिसत नाही का?
नाही अजून दिसत आहे.
अरे बापरे.
फक्त ते तुमचा कर्सर दिसतोय का काय? तो कर्सर ह्याचा दिसतोय तुमचा पण
बरं
हे दिसत नाहीये स्क्रीन.
आता माझं स्क्रीन नाही दिसत. बरं एक मिनिट
नाही
सर मग हे करतो ओपन आणि बघू मग ते तरी होतं.
हा
स्क्रीन दिसतोय का सर?
नाही अजून.
थांबा एक मिनिट.
तुमचा व्हिडिओ दिसतोय म्हणजे आता तुम्ही दिसताय पण
हा
हे नाही दिसत. हा आला सर आता.
ओके
हा आला.
येस सर
हा तुम्ही आता हा ठीक आहे मग
एक मिनिट हा
उद्या तुम्हाला 11:45 सांगितलंय ना सर?
हो आता फुल स्क्रीन दिसतंय ना?
हा आता दिसतोय फुल स्क्रीन.
हा ओके ठीक आहे ना सर दिसतोय ना?
हा दिसतोय सर. ते बेसिक जे आहे ना बेसिक रिमोट सेन्सिंग वगैरे आता ते झालेलं आहे. तुम्ही ऍप्लिकेशन वरतीच हे करा म्हणजे जास्त.
अच्छा ते 2 तास होणार. बरं 2 तास होईल का नाही माहिती नाही ते.
त्याच्यात मग थोडं काय सॉफ्टवेअर किंवा कुठले डेटा सोर्सेस वगैरे
किंवा थोडस स्किप करेन फास्ट घेईन.
हा चालेल
फास्ट करेन थोडस.
हा
त्यांना सांगेन की ही
दीड तास जरी झालं ना दीड नंतर एक 10-15 मिनिटं आपण डिस्कशन वगैरे असं होतं.
ओके
हा
ठीक आहे सर
ठीक आहे ना. तुम्ही ते खाली ऑरेंज जो क्रॉस आहे त्याला हे करून मग तुम्ही लिव्ह करू शकता आता.
हा एक मिनिट आता हे स्क्रीन शेअरिंग हे आलं. अच्छा ओके हे परत शेअर आहे. अच्छा ओके शेअर म्हणजे ते हे दिसतंय. ओके कॅन्सल ओके एक क्लोज आहे ते करून टाकू ना क्लोज करून.
हा ते क्रॉस जो आहे ना ऑरेंज मध्ये रेड तिथं तुम्ही हे केलं ना की तुम्ही बाहेर पडाल म्हणजे मग.
येस
हा
ओके
हा
थँक्यू सर.
हॅलो निंबाळकर सर नमस्कार.
हा नमस्कार सर.
मी जॉईन झालोय बरं का सर.
झालाय का?
हा तुमचं होऊ द्या. मी नाही तुमचं होऊ द्या जेव्हा मी ऑनलाईन आहे.
हो
म्हणजे ते लास्ट मोमेंटला हे नको म्हणून मी जॉईन झालो.
हो चालेल.
मी माईक
आपण
आणि
आता 2:30चं टायमिंग दिलंय सर
हा 2:30च्या नंतरच ना. मी फक्त जॉईन
2:30ला
झालो
सुरू
म्हणजे काय
करू म्हणजे
प्रॉब्लेम
बरोबर आपण.
करेक्ट. तर मी आता व्हिडिओ आणि माईक स्विच ऑफ करतो. 2:30च्या
थांबा
दरम्यान
एक
मी
मिनिट
जॉईन.
मी तुम्हाला थांबा एक मिनिट मी हे करतो जरा. तुम्हाला प्रेझेंटर मेक प्रेझेंटर आता तुम्ही तुमचं हे शेअर करू शकता सर.
तेच प्रेझेंटेशन ना.
प्रेझेंटेशन वगैरे
एकदा
आता
टेस्ट केलं की होऊन जाईल आपलं.
हां. बघून बघा नाहीतर म्हणजे ते तुमचं
नाही लगेच
प्रेझेंटेशन.
करतोय ना सर. हे
हां,
थोडं
हां.
वेळ लागेल त्याला पहिल्यांदा.
हां. हो.
हं.
अ, अ,
दिसतंय
हे
सर?
दुराई स्वामी
कोड
सर, एक
हां सर.
विचारायचं होतं मला.
हां सर.
हॅलो.
हां सर बोला ना.
तुमच्या आता तो बायोडाटामध्ये मला जे दिलंय ना,
हां.
त्याच्यात GISच्या संदर्भात काय सांगू म्हणजे तुम्ही GSDAमध्ये होता ना ग्राउंड?
ग्राउंड वॉटर सर्व्हे. मी
हां.
IRS इंडियन इन्स्टिट्यूट ऑफ रिमोट सेन्सिंग अँड NRSA मधून GIS रिमोट सेन्सिंग केलेलं आहे.
तो कोर्स केलेला आहे. मग तो ह्याच्यात
तो
मला वाटतं नाही म्हटलेलं का ह्या
नाही म्हटलेलं आहे.
अच्छा. बरं ठीक आहे. आणि
आणि
तुम्ही मग
नाही हां.
GSDA म्हणजे काय ग्राउंड
ग्राउंड वॉटर
हे
सर्व्हे अँड डेव्हलपमेंट एजन्सी
त्याच्यामध्ये मग
गव्हर्नमेंट
तुम्ही रिमोट
महाराष्ट्र.
सेन्सिंग आणि हे वापरलं होतं का?
R&Dला होतो मी. तर आम्ही
R&D.
ते
अच्छा.
रेग्युलर
हां,
वापरतो
हां.
ते.
ते पण म्हटलं नाहीये मला वाटतं. मग मी ते
नाही.
थोडं
आता
मेन्शन करतो.
ब्रीफमध्ये
हां,
किती
हां.
तुम्हाला ते म्हणजे वाचून दाखवायची गरज नाही सर. जे काही तुम्ही बोलाल थोडं इंट्रोडक्शनमध्ये दॅट इज गुड
हां.
इनफ.
चालेल. ओके. ओके
येस
सर.
सर. मग आपण आता दिसतंय माझं स्क्रीन राईट?
हां, स्क्रीन दिसतोय तुमचा आता.
आर्टिफिशियल रिचार्ज पोटेन्शियल कृष्णा रिव्हर बेसिन. त्याला थोडं क्लायमेट चेंज आणि याचं थोडं एडिटिंग करून मी सादर करेल.
हां.
हं? चालेल सर.
याच्यामध्ये तुमचं GISचं हे येईल ना ह्याच्यात?
हो बघ ना. कंप्लीट GISच आहे.
हां. बरं.
जेव्हा आपण
ओके सर.
कृष्णा बेसिनला येतो ना,
हां.
तेव्हा डायरेक्टली आपण ह्यालाच जातो. म्हणजे हे सगळं
बरं.
रिमोट सेन्सिंग आहे. कसं
हां.
आयडेंटिफाय करायचे, हे
ओके.
सगळे रिमोट सेन्सिंगचं पार्ट आहे.
हां.
राइट हे सगळं. आणि मग
ओके.
GISचं पार्ट सेकंड पार्टमध्ये आहे. हे
हां.
रेनफॉल डिस्ट्रिब्युशन रिव्हर बेसिन झाल्यानंतर हे इथून GIS स्टार्ट झालं.
हां.
कृष्णा
हं.
बेसिनचं हे
हां.
डिजिटल एलिव्हेशन मॉडेल आहे. आणि हे
ओके.
आपण कसं यूज करतो GIS फ्लो चार्ट आहे.
हां.
राइट आणि हे
हां.
लेयर्स आहेत त्याचे GISचे काय लेयर्स केलेले आणि मग ते कसं एक्स्ट्रॅक्ट करतो वगैरे हे इथं सांगणार. आणि मग
हां.
हे GISचे वेगळे लेयर आहे. जिओलॉजीची लेयर आहे. राइट मग पाणी पातळी कशी मोजतो. राइट
हां.
इन द फील्ड
हां.
कशी मोजतो आपण आणि त्याचं कसं हायड्रोग्राफ बनवतो आणि मग
हां.
ते GIS मध्ये कसं वापरतो.
अच्छा.
हे
ओके.
GIS जनरेटेड मॅप आहे डेप्थ टू वॉटर लेवल.
ओके. हां.
ओके 99चं आहे आणि 2005चं आहे. म्हणजे 2
ओके.
वर्षाचं कसं चेंज डिटेक्शन करतो आपण.
हां.
हे
तुमचा
हे
सर आत्ता जो म्हणजे हे जो आहे PPT तो असा हे होत नाहीये का? मूव्ह होत नाही
काय?
मला वाटतं. तुम्ही
नाही
आत्ता जे
होईल ना.
सांगत होता ना,
हां.
तो
नाही होईल ना. हॅलो सर.
हॅलो सर.
हॅलो सर. मला
हां.
ऐकू येते ना.
आत्ता जो फक्त स्क्रीनवरती तो टायटल जो आहे ना आपला,
हां.
आर्टिफिशियल रिचार्ज पोटेन्शियल इन कृष्णा रिव्हर
का
बेसिन तो आलाय.
बाकीचं दिसत नाही?
बाकीचं आत्ता नाही
फक्त
दिसलं मला.
नाही स्टॉप शेअरिंग करून मी परत करतो रिफ्रेश. तर
हां.
ते जर प्रेझेंटेशनमध्ये असं झालं तर मला सांगा प्लीज.
बरं.
म्हणजे
हो.
पार्टिसिपेंटला पण सांगेल मी ते सांगायला.
हो. हं.
एकच मिनिट. आता दिसतंय.
नाही अजून नाही आलं.
मी परत करतोय. थोडं डिले असणार.
हां.
शेअरिंग कंटेंट येत नाही. तर थोडं विद्यापीठात नेटचा इश्यूज आहेत. पण
हां.
ऍक्च्युली आतापर्यंत कधी झालेलं नाही.
हां. नाही थोडा
दिसतंय ना?
मगाशी पण सकाळच्या ह्याला पण थोडासा डिले होत होता. ते
हां.
कधी-कधी
पण
हे
जास्त नाही व्हायला पाहिजे आता असं जसं.
हां.
आता दिसतंय?
अजून नाही आलं. तुमचा आता व्हिडिओ येतोय.
हां. शेअर ना सर. मी बाकीचे जे आहेत ना सगळे ॲप्स
हां.
बंद करतो म्हणजे अजून
हां.
हे नाही. आणि मग व्हिडिओ पण बंद करतो. जेणेकरून आपल्याला बँडविड्थ जास्त मिळेल.
हां, व्हिडिओ हां, ते बंद केलं तर हे
आता यायला पाहिजे ॲक्च्युअली.
अजून नाही आलं. नाव येतंय फक्त तुमचं आता.
ओके, मी रिफ्रेश करून बघतो.
हां.
मी परत जॉइन होतो सर, बाहेर
बरं.
पडून.
हं.
विद्यार्थी आहेत टेस्टिंगला प्रॉब्लेम आला. पावणे 11 वाजता ते हे पाठवलं. अखिल मेहता कॉन्क्रीट टेक्नॉलॉजी नाही ना, इंटरनल असेसमेंट आहे. बरं
सर आज मुझे बैक पेन बहुत ज़्यादा आता था. वॉलनी भी लगाए, ये वाटर हीटर, ये मंगाए हीटर भी, बैक पेन एकदम से चिनास खिल गई थी. ऐसा मैं सस्टेन नहीं कर पा रहा हूँ, प्लास्टिक को से बैठ नहीं पा रहा हूँ. आपके पास में समस्या का बता दो सर. तो मैंने घर से मंगाया भी है लड़के को बोल के, जो गार्ड है, लेकिन वो काम नहीं कर रहा है.
क्या है वो?
तो ये एक्चुअली ऐसे पीठ पे लगा दिया जाता है.
हाँ हाँ, गरम वो
हीट कर देता है. मुझे लगा शायद कुछ हुआ होगा टेम्परेरी, अभी ठीक हो जाएगा 1 घंटे.
हाँ.
लगाया मैं, पर कुछ आराम नहीं मिला सर. उसको ये कि लेटना, एक तरफ लेट के वॉलनी लगाने को कहा है डॉक्टर साहब से. बात सही है कि लेट जाओ 8-10 घंटे.
लेटने से ऑटोमेटिकली होता है. मेरा मालूम है.
हाँ सर,
कहीं भी लेटना.
हाँ, बीच में आपकी प्रॉब्लम थी.
काय विषय
अरे मूवीज खराब हो
का सर.
ते आता मला सेकंड इयर सेकंड सेमिस्टर मार्कशीट सापडलं.
हां, जाधव ना? काय म्हणताय? कुठे कुठे आहे तुम्ही? झील पॉलिटेक्निक. बसा.
ऍडमिशन किती सीटची इंटेक 180 इंटेक असेल त्यांची वॉकेशनची.
हो का?
ऍडमिशन म्हणजे सर कुठे जातो
कुठल्या?
मला मी ते डेटा पाठवतो विचारलं सर ना सर काय म्हणते आपलं एक तुम्हाला विचारलं नाही नाही तुमचं ऍडमिशन आहे विचारायचं बोललो तर म्हणले थोडंसं इकडे गोष्ट करत म्हणजे एकदा बोलू द्या तरी मी दोघं आपल्याला सीईटी आत्ताच आहे सीईटीला फॉर्म भरला तर ते आपण घेतो नंतर काय करणार किती तारीख आहे सीईटी 11 तारीख तर त्यांनी फॉर्म भरले ऍक्च्युअली आज तारीख किती 4 आहे 2 तारखेला ती संपली आम्ही एक्सटेंड केली आता थोडी मला माहित नाही आज मी बरेच जणांना ते लिंक पाठवलं कंपल्सरी आहे सीईटी सीईटीच्या ऍडमिशन हा प्रॉब्लेम तशी मार्केट मुलं फारशी काय म्हणतात आपल्याला ईपीसी यावं त्याला सगळं फीस वगैरे किती देतात हा फीस किती आपली 1,20,000 पण ते गेम असल्यामुळं ते मुलांची एससी एसटी समाज कल्याण याची इथे काही तसलं नसते ना ही कमी मुलं येतात खरंच ज्याला करायचं तुम्ही आता डिप्लोमाची विद्यार्थी त्यांचं म्हणणं काय असतं मग आम्ही राबतो आणि ईसी पाहिजे ती पाहिजे ती पाहिजे काय 2-4 मिळाले तरी भरपूर आहे त्याच्यात आणि का या तुम्ही कुठं असतात सर्व्हिस नाही MBA क्वालिफायर मध्ये मी काय लावलेलं नाही कोण अच्छा ते कसं काय त्या ऑपरेटरला विचारायचं ना फोन ते एनबीए फ्री क्वालिफायर असतात रेग्युलर स्टाफ असतोच प्लस व्हिजिटिंग पण असतं तर काय काय तो व्हिजिटिंग तो म्हणजे आपण त्याला म्हणू ना मॅथमॅटिक्स आहे तो एमबीए वगैरे पण ती एमबीए मध्ये इंजिनिअरिंग क्वालिफिकेशन आमचं एमबीए चालू अशा वेळेला कोणतं लागतं काय ती आपला जीपीपी नाही तो सोडलं वाटतं सोडलं ते व्हिजिटिंग होती ते करत होते ऑनलाईन मुळे सगळ्यांचं बोल बाळाबरोबर तुमचं कॉलेज ऑनलाईन काहीतरी आता एक वेगळे एक्झाम चालू आहे ऑनलाईन.
हॅलो सर. हॅलो सर. हॅलो सर.
हॅलो.
हॅलो सर. को होस्ट
हां.
करता का सर? शेअर करता येईल मग.
नाही, आता मी तुम्हाला प्रेझेंटर केलंय.
अच्छा, ठीक आहे, ठीक आहे.
प्रेझेंटर केलंय म्हणजे तुम्हाला आता शेअर करता येईल.
दिसत नाही, आलेलं नाही, ऍक्टिव्ह झालं. ओके सर.
हां.
मला वाटतं ते कनेक्शन स्लो आहे कदाचित इकडं विद्यापीठात.
हां हां. किंवा तुम्ही व्हिडिओ सर बंद करून मग हे बघता का?
हां, पण ते जास्त फरक नाही पडत आहे.
नाही ना?
नाही, नाही. दिसतंय सर प्रेझेंटेशन?
हां, पहिली स्क्रीन आली तुमची आर्टिफिशियल
हां.
रिचार्ज पोटेन्शियल वगैरे.
करेक्ट, करेक्ट. आता
हां, हां.
चेंज होतोय ना स्लाइड्स?
नाही, अजून नाही झालं. पहिली तीच आहे.
नाही ना, मी चेंज करतोय. परत एकदा मी शेअर करतो. एंटायर स्क्रीन करून बघतो म्हणजे. आता दिसतंय सर?
हां, आले आता. हां.
आणि चेंज दिसतंय का?
हो, हो, हो.
नाही, चेंज केल्यावर दिसतंय का?
हां, बघा बरं आता. आता पहिलीच ती स्क्रीन आली आहे तुमची टायटलची.
झाली का स्लाइड चेंज?
नाही होत आहे अजून.
काहीतरी प्रॉब्लेम आहे वेबएक्सला. एक मिनिट, स्टॉप शेअरिंग करून परत. आता सर शिफ्ट दिसतंय का?
एक मिनिट, अजून नाही आले तुमचं हे दिसत नाहीये पीपीटी. अजून नाही दिसत आहे स्क्रीन.
नाही.
नाही.
मग आता सगळे ऑप्शन्स आपण करून बघितले. दिसतंय सर?
व्हिविंग म्हणतंय पण अजून स्क्रीन नाही दिसत आहे तुमचा.
अवघड आहे आता. स्क्रीनच दिसत नाही म्हटल्यावर. कारण मी सगळे बाकीचे ऍप्लिकेशन्स बंद केलेले आहेत. रिफ्रेश करून बघतो.
सर आता इथं काय स्क्रीन त्यांचा दिसेना झाला, काय करायचं?
स्क्रीन शेअर करतोय सर मी.
स्क्रीन शेअर करतात ते पण ते दिसत नाहीये काय ते. हां, आता आले
दिसतंय
सर.
सर?
हो.
हो, पण स्क्रीन चेंज होतोय का?
थांबा, आता हे फ्युचर वॉर्मिंग अनदर वर्ल्ड आलेला आहे तो.
चेंज केलाय मी आता.
हां, आता ते वरते हे दिसतात. काय म्हणायचं म्हणजे आता ते.
हे
हां, ते
आता
पूर्ण. हां.
आता चेंज झालं का?
हो. होतंय स्लोली.
आत्ता कुठलं स्लाइड दिसतंय सर?
हां, आता ते जे तुमचं सगळा पूर्ण हे जे आहे ना तो दिसतो आता.
नाही स्लाइड दिसतंय का?
आता परत गेली. आता नाही दिसत आहे परत.
नाही काहीतरी
वेगळी लिंक किंवा करून परत ह्याची टीम्सची लिंक करून परत हे जर होत नसेल तर नाही का? नाही टीम्स वरती हे करून परत हे ते स्क्रीन म्हणजे
नंबरच नाही माझ्याकडे.
पीपीटी हे होत नाही.
दिसतंय का सर?
नाही अजून दिसत आहे.
नाही
मगाशी आले होते.
त्याला म्हणा व्हॉट्सअप चेक करतो का नाही. त्याचा नंबर घ्या ना.
राजकुमार सावंत.
दिसतंय सर?
नाही सर.
नाही मग अवघड आहे कारण सगळं करून बघितलं मी आता.
नाही मग हो सर त्यांचं हे
को होस्ट करता का मला को होस्ट?
ते दुराई स्वामी म्हणून आहेत सर. को होस्ट करायला लागेल का तुम्हाला?
हा कारण प्रेझेंटर म्हणून
प्रेझेंटर केलं
नाही होत नाही ना प्रेझेंटर. को होस्ट करून बघा ना सर.
को होस्ट का? को होस्ट त्यांना सांगायला सांगितलं सर. एक मिनिट मी सांगतो बघतो. को होस्ट म्हणजे त्यांना सांगायला करायला.
तिथं राईट क्लिक करून
तिथं 3 डॉट येतात बघा.
एक मिनिट कुठे इथं
क्रॉस आहे ना सर त्याच्या बाजूला 3 डॉट्स आहेत तिथे.
नाही आता ऍडमिन बालेराव सरांचं नाव होतं ना.
नाही यांचं सरांचं
हा हे मेक को होस्ट.
हा येस सर.
ओके
ओके सर. हां आता 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 दिसतं का बघा तुम्ही. शॉप शेअरिंग करतो पूर्वीचं आणि मग परत हे करूया आपण. इथं काहीतरी एरर
व्हिडिओ येतोय अजून.
हां सिलेक्ट विंडो करतो रिचार्जिंग. आणि अलाउ करतो. आता दिसतंय सर?
अजून
आता यायला पाहिजे ऍक्च्युली.
आलं सर. आलं काही प्रॉब्लेम नाही.
स्लाइड चेंज होतो
हो.
का?
आर्टिफिशियल रिचार्ज पोटेन्शियल इन कृष्णा रिव्हर बेसिन इंडिया.
करेक्ट. आता दुसरा स्लाइड चेंज केलाय मी.
एक मिनिट थोडा लॅग असतो तो.
1859.
एक मिनिट सर. ते येत राहतं ते.
नाही यायला पाहिजे आता.
सर तुम्ही स्लाइड शोला जा ना.
तुम्ही स्लाइड शो करताय का?
हा हो ठीक आहे. 2001 दिसतंय स्लाइड?
आता मी जी वाचली ती आहे तिथे स्लाइड.
पहिलीच आहे स्लाइड.
मग शिफ्ट होत नाहीये.
होईल
वेळ
सर.
नाही लॅग
हा झाली बघा सर. 1859.
हा म्हणजे खूप वेळानंतर होतोय ते.
थोडा लॅग राहतो
थोडा
सर.
लॅग
बँडविड्थ मुळे ना थोडा लॅग असतो तो.
50 आहे आपल्याकडे स्लाइड्स. 2 तासात होणार नाही मग.
नाही होतं सर. होतं ते आपोआप होऊन जाईल. ते बँडविड्थ आपोआप कमी जास्त होत राहते. होतं ते.
चालेल.
करूया का सर चालू मग? चालू करूया का? मी इंट्रोडक्शन करतो.
येस सर.
Okay, good afternoon, everyone. So now today we have for the third session Dr. Raymond Durai Swami from Geology Department of Pune University. Sir is going to talk on artificial recharge potential in Krishna River Basin using remote sensing GIS. Okay, I will introduce Durai Swami sir. Dr. Raymond Durai Swami completed his graduation from Nauroji Wadia College, Pune, and post-graduation and PhD from Department of Geology, University of Pune in 94 and 2008 respectively. He worked as project assistant from 94 to 96, then for DST JRF 96 to 98, CSIR SRF 98 to 2000, and before joining Groundwater Survey and Development Agency, that is this GSDA, Government of Maharashtra, as junior geologist 2000 to 2009. He presently works as assistant professor at Department of Geology, Savitribai Phule University, Pune, and has varied interest in igneous petrology. So that is all this geological aspects of this thing. He also did this courses related to remote sensing from Indian Society for of Geometrics. He has successfully guided 5 PhD and at present 8 PhD research scholars working in diverse geo-environmental topics are registered under his guidance. So I request Durai Swami sir to continue with his presentation on artificial recharge of groundwater in Krishna Basin.
Thank you, Nimbalkar sir. Thank you for the introduction, and I hope the participants will bear with me for this talk. Okay, so I will share screen my presentation, and hopefully we will have a good interactive session. As you know, water is the exceller of life. Okay, and water is very important in the present day context. We know that all around us it is monsoon, it is raining, and we are basically in 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 peril, especially because of the landslides and the floods. Okay, so all of this thing that we are getting to see is the effect of water. Okay, and water is a very important. Okay, there is a psychology of water, economics of water, politics of water. Okay, water is central theme. Okay, and in the context of constitution, water normally is in the state subject, so states decide the course of the water. Okay, so this talk is using remote sensing and GIS to understand how to manage, plan, and projects related to development and to aquifer management. Okay, in the climate change scenario. Okay, so I am trying to share my screen. Hopefully, we will be successful in doing that. हॅलो निंबाळकर सर.
हॅलो. हां हां
सर मी शेअर करू शकत नाही कारण मला वाटतं आय एम नॉट अ को होस्ट नाव.
नाही, को होस्ट आहे तुम्ही,
पण माझं शेअरिंग ऍक्टिव्ह नाहीये.
थांबा, तुम्हाला प्रेझेंटर
त्यांना
केल्यावर
प्रेझेंटर केलेला आहे, रेमंड सरांना प्रेझेंटर केलेला आहे.
हां हां हां.
नाही, पण माझं शेअरिंग स्क्रीन येत नाहीये. जे पूर्वी येत होतं ना. नाही, इथं
सर आता
दिसतंय
चेक करा. रेमंड सर आता चेक करा.
आता बघा म्हण.
नाही ना. Can you help me?
तुमचा व्हिडिओ दिसतोय रेमंड सर.
हो,
तुम्ही शेअर पण करू शकाल आता.
नाही ना, सिलेक्ट विंडो मध्ये स्क्रीन येतोय. दिसतंय का? हॅलो सर.
नाही, अजून नाही आलेलं.
नाही ना. It's showing screen sharing.
सर आलं होतं आता. रेमंड सर आता आलेलं.
इथं मला एरर येतोय अबाउट रिट्राय. ओके, एक मिनिट सर. पूर्वा, can you do my laptop up?
नेटवर्क इश्यू असेल का पाटील सर?
बँडविड्थ कमी पडते असं सांगायला लागले. एक मिनिट, कंटेंट शेअर व्हायला लागला असं इथं मेसेज आलाय. एक मिनिटभर वाट बघूयात.
इथं मला एरर येतो इथं. इग्नोर म्हटलं तर काय होईल? नाही, जातच नाही पुढे ते. ओके, मी लॅपटॉप वरून ट्राय करतो टू जॉईन. सर दिसतंय आता?
नाही, अजून नाही आलेलं.
रेमंड सर, एकदा तुम्ही मीटिंग लिव्ह करा आणि परत एकदा सेम लिंक करून जॉईन करा.
चालेल, एक मिनिट.
एकदा ते ट्राय करून बघूयात.
येस सर.
सर होल्ड दिसायला लागले.
आला आता स्क्रीन आता.
सर
हां.
संतोष सर
हां. हॅलो.
रेमंड सर जॉईन झालेले नाहीत का अजून?
बघतो मी आता परत.
हॅलो.
अरे नाही दिसत ते याच्यामध्ये सर्चमध्ये तर नाही येते ते अजून. त्यांना हे असं केलं तर जीमेलची लिंक वगैरे पाठवून त्याच्यावरनं होऊ शकतं का? काय नाही ते का बँडविड्थचा प्रॉब्लेम असेल तर?
तेच प्रॉब्लेम यायला लागला सर.
हं?
तेच प्रॉब्लेम यायला लागला.
हं.
पण मला माझ्या जागेपासून काहीच करता येत नाही. मला बोलता सुद्धा येत नाही.
नाही दिसत, ते जॉईन झालं म्हणतात आणि काय दिसतच नाही. आहे ना. हा, आता ह्यांना प्रेझेंटर करू का? मेक अ प्रेझेंटर. त्यांना अनम्यूट कसं होत नाहीये? प्रेझेंटर केलंय. हॅलो पाटील सर.
हा सर बोला की.
ते आता ते दुराई स्वामी सर जॉईन
हा सर
झालेले
बोला.
आहेत. दुराई स्वामी सर जॉईन झालेत. हॅलो.
निंबाळकर सर बोला.
हा बोलतोय मी. आवाज येतोय का? हॅलो.
रुद्राई स्वामी म्हणून आहेत का?
हा, RADURA असं दिसतंय इथं. RA दुराई स्वामी. हा, त्यांना अनम्यूट करा बरं.
हॅलो.
आणि त्यांना अनम्यूट करा.
निंबाळकर सर.
हा. हॅलो.
गिड्डे सर.
सर आवाज येतोय का तुम्हाला? पीडी पाटील सर.
येतोय.
आवाज कट होतोय, मला आवाज क्लिअर ऐकू येत नाही कुणाचा.
हॅलो, येतोय का आता?
हा, मला येतोय आवाज सगळ्यांचा, पण त्यांना येत
तर
नाही.
मलाही येतोय पण त्यांना येत नाहीये.
हॅलो पाटील सर.
हॅलो.
पीडी पाटील सर आवाज येत नाहीये.
येस निंबाळकर सर.
हा, ते हे बघा दुराई स्वामी सर जॉईन झालेत, पण त्यांचा आता त्यांना प्रेझेंटर केलंय मी त्यांना. त्यांचा काही आवाज नाही येत आहे. हॅलो.
हॅलो. हॅलो. हा. तुझा आवाज आम्हाला ऐकू येतोय बरं का? हॅलो.
निंबाळकर सर.
तोच प्रॉब्लेम आहे. तुझा क्लिअर
त्या
आवाज
सरांना
ऐकू येतोय. निंबाळकर सर
रुद्राई
बोलतायत, मी
स्वामी
बोलतोय,
सरांना मी
ज्योती
अनम्यूट
बोलते.
केलंय. चेक करा, त्यांच्याशी बोलून बघा.
हॅलो दुराई स्वामी सर.
दुराई स्वामी.
हॅलो.
त्यांचं स्क्रीन शेअर होत नाही वगैरे असं काहीतरी प्रॉब्लेम आहे.
हॅलो, त्यांचा काही आवाजच येत नाहीये.
हॅलो
नाही.
सर.
हा
नाही,
आले बघा तुमची स्क्रीन सर.
आले का
हॅलो,
एक मिनिट ऐका.
शिफ्ट होतोय का सर?
हा स्क्रीन दिसतंय आता तुमचं.
माझा आवाज ऐकू येतोय?
हो येतोय, तुमचा आवाज येतोय. कमी आहे थोडा.
ओके सर.
हा
कळलं का? स्क्रीन शेअर होते, आवाज येतोय त्यांचा पण बारीक येतो. लॅग असणार आहे थोडंसं.
पहिली स्लाइड दिसते आता सर तुमची.
दिसली
हो.
पहिली स्लाइड दिसली म्हणतात.
चालतो सर आणि मग
हा
दिसते.
ठीक आहे पिढी.
तुम्ही आता एक एक करा, म्हणजे पुढे जावा, बघूया होतंय का.
हो मी केलंय ऑलरेडी.
हा
सेकंड स्लाइड वर गेलोय.
नाही आली सेकंड स्लाइड.
GIS बेस्ड आहे. दुसऱ्या कशात येणार नाही का सर तुम्हाला? झूम वगैरे?
तुमचं प्रेझेंटेशन चालू
नाही ना सर.
सर
झाल्याशिवाय मला
सर सर
बोलताच
सर
येणार
दिसायला
नाही.
लागले. शेअर केलेलं दिसायला लागले सर.
पण मी स्लाइड चेंज केलंय. आता दिसतंय का? 1859. ओके. आणि
हो, थोडं स्पीड कमी असेल.
2001.
चालू करा.
1859 ची इमेज सेव्ह होऊन गेली.
नाही, 2001 च मी प्रोजेक्ट करतोय आता. 55 स्लाइड आहे सर GIS चे, त्यामुळे
नाही येते का?
बोला निंबाळकर सर.
त्यांचं आपल्याला त्यांचं जर PPT घेऊन आपण शेअर केलं आणि त्यांनी नुसतं बोलले तर करता येईल का? तसं होत करता येईल का? त्यांचं प्रेझेंटेशन आपल्याला इकडं हे करता येईल का शेअर?
हा सर, तुम्ही शेअर करू शकताय. तुम्हाला मेल पाठवायला लावा त्यांना. तुम्ही तिथून
हा
हे करा. मी तुम्हाला प्रेझेंटर करतो को-होस्टच्या ऐवजी.
बर. आता ते दुराई स्वामी सर. हॅलो. त्यांचा आवाज येत नाही. कुठे गेले?
ते लेफ्ट झालेत.
लेफ्ट झाले का? नाही तर दुराई स्वामी दिसतात नाही तर. दुराई स्वामी सर. पाटील सर टीम्स वरती ट्राय करायचं का? हॅलो.
सगळ्या पार्टिसिपंटना लिंक शेअर केली पाहिजे
हा
आणि ते हे होणार नाही मग शक्य.
हा
YouTube वरती लाईव्ह टेलिकास्ट होणार नाही.
नाही होणार का?
YouTube वरती लाईव्ह टेलिकास्ट होणार नाही. तुम्ही हे घ्या.
काय?
काय म्हणायचं, तुम्ही मेल त्यांच्याकडून मागून घ्या
हम्म.
आणि तुम्ही तिथून प्रेझेंट करा. मी तुम्हाला प्रेझेंटर केलेला आहे.
आत्ता का ह्याच्यावरतीच का? त्यांना सांगू का पीपीटी पाठवायला? ओके ठीक आहे बघतो.
हा हा हा
हा पीपीएस म्हणजे काय आलं?
पीपीएस काय असतं? पीपीटीच्या पीपीएस आलं. तो सीट नंबर आहे 2114 390 214. कोण आहे? नाही नाही, मी आता मार्च बोलतोय ते सर्व दोनशे चौदा कोण आहे? 2114 390 214. हा तो सेम सेवन दाखवला म्हणजे एक पण असणार काय कळत नाही. मला फक्त लागेल फोन केलं ना, 215 आहे. 390 मध्ये 390 काही त्रास असणार आहे. आदित्य अग्रवाल
You need access. नाही ना. ऍक्सेस डिनाइड म्हणते, परमिशन विचारली तर ते परमिशन रिक्वेस्ट सेंड म्हणते, परमिशनची रिक्वेस्ट जाणार ना. मग त्याने रिक्वेस्ट ग्रँट केली तर ते आपल्याला ऍक्सेस मिळणार. ते लांबचा खेळ आहे. आता पण 3 वेळा रिक्वेस्ट पाठवली परमिशनची.
निंबाळकर सर, तळगावकर सरांच्याकडे आहे.
टेन्शन मध्ये मला दिसायला लागली तुम्ही.
पोळी सोडवायची कशी?
काय बरोबर.
सामान्य पोळी उघडी करून आम्हाला
बरं, मला एक मार्गदर्शन करा. फुकट
अजून पगार नाही.
अँटी ग्लेअर ग्लासेस काहीतरी शब्द.
प्रॉब्लेम काय?
नाही, मला अँटी ग्लेअर ग्लासेस बद्दल माहिती पाहिजे. करायचं मला.
अँटी स्किड म्हणते का?
पाय विसरू नये.
कसं अँटी ग्लेअर? हो हो, चष्मेवाल्यांकडे तो त्रास.
पाऊस पडला की त्याच्यावर पाणी
तिथे कुठे आहे? माझ्या बरोबर समोर आहे. काहीतरी आहे इथं बॉम्ब म्हटलं नाही, हे माझं हे चाललं खबर.
आवडते त्यांनी पाठवलेला जो पीपीटी आहे ती पीपीएसच्या फॉर्मॅटमध्ये आहे. पॉवर पॉइंट स्लाइड शो. आणि ते ओपन करायला परमिशन नाहीये. मग ते परमिशन साठी रिक्वेस्ट पाठवली, 3दा पाठवली की त्याच्या जीमेलला स्टोअर असतं.
हे बघा आता झालंय
झालं का?
हा, आता इथं स्लाइड कुठं जाऊ, ह्याच्यात मीटिंग म्हणायचं जाऊ का? आणि शेअर स्क्रीन.
शेअर करा म्हणतात, बाकी नाही. स्क्रीन फोन चालू ठेवा.
शेअर कंटेंट. आता हे रिचार्जिंग ऑफ कृष्णा बेसिन ना. आता आलं का म्हणजे याच्यावर
तुम्हाला दिसतंय का ते कृष्णा बेसिन? झालं.
दिसतंय का आता
त्यांनी कुठल्या नावाने जॉईन केले तर दुराई स्वामी सरांनी?
आता इथं
त्यांना अनम्यूट करा. तुम्ही फक्त बोला म्हणा. आता शो बी दाखवतो म्हणा. मी शो दाखवतो म्हणा, तुम्ही फक्त बोला. बोला. अहो, मी काही करू शकत नाही. मी गेस्ट आहे, मला कुठलीच परमिशन नाही.
हे बघा इथं
गेस्ट म्हणून पहिल्या लेक्चरपासून जॉईन आहे. पोस्ट नाही काही नाही. आपलं नावच नाही. आपण गेस्ट आहे. नो परमिशन. अहो आहे माझ्या
भालेराव सर होस्ट आहेत. भालेराव सर होस्ट आहेत.
त्याला दिसतंय का बघा?
हो, मला दिसतंय सर.
मी आहे.
हॅलो.
परमिशन नाही कुठली, मला बोलता पण येईना. मग इथं बोलायला यावं लागतं काय असेल. पिढीचं दिसतंय का ते 1857 ची स्लाइड?
नाही, 1857 नाही.
हॅलो हॅलो निंबाळकर सर. हॅलो,
दिसते ना?
दिसते सर स्लाइड.
हॅलो.
रेमंड सर कुठल्या नावाने जॉईन आहेत सांगायचं. रेमंड तुरायस्वामी असंच नाव आहे म्हणतात सर.
हॅलो.
त्यांना
हॅलो. हॅलो सर.
हॅलो सर.
हा, ऐकू येते सर मला.
हा, तर तुम्ही आता सर मी स्लाइड्स करतोय पुढे, तुम्ही चालू करा मग.
हो, शेअर झालेले आहेत, पण
हा.
मला इथं अबॉटचं हे येते
काय
मेसेज.
हो का, तुम्हाला नाही दिसत आहे?
मला दिसतंय, पण मला
हा.
पुढे जाता येत नाहीये. तुम्ही नेक्स्ट स्लाइडला जा बरं.
आता तुम्हाला कुठली दिसते स्लाइड?
1859.
हा
हा, पुढचं.
पुढची येते का?
हा, पुढचं येतंय. हे पीपीएस केलंय तुम्ही, राईट?
हा हा
हा, ठीक आहे
रेमंड
सर.
सर,
हा,
निंबाळकर सरांनी हे ऍक्च्युली शेअर केलेलं आहे. निंबाळकर सरांच्याकडे तो ऍक्सेस असणार आहे. तुम्ही
करेक्ट.
फक्त प्रत्येक वेळी निंबाळकर सरांना स्लाइड चेंज करायसाठी सांगा, निंबाळकर सर स्लाइड चेंज करतील.
हा.
हो, पण निंबाळकर सर ह्याच्यावर नाहीये कदाचित,
कशावर?
ग्रुपवर
आहेत
आहेत ना. मग मी नेक्स्ट
माझा
स्लाइड
आवाज
म्हणतो.
येतोय ना?
हो हो हो, नेक्स्ट स्लाइड.
हा हा.
हा, तर सर हे जे पीपीएस आहे ना, हे बंद करा आणि पॉवर पॉइंट प्रेझेंटेशन हे करा.
नाही
आता
आता
होईल.
याच्यावर नाही करता येणार का?
हा, पीपीएस पेक्षा पीपीटी केलं ना,
हा.
नाही त्याच्यातले जे अॅनिमेशन आहे GIS चे ते दिसणार नाही तिथं.
रेमंड सर, तुमचा व्हिडिओ ऑफ करा. तुमच्या व्हिडिओमुळे तुमचं स्पीड कमी पडते इंटरनेटचं.
येस सर.
हे आधी सर आपण हे बघूया आधी हे करून.
ओके सर, ओके, ठीक आहे. पहिल्या पानावर जाणार.
हो.
रेमंड सर, तुमचा व्हिडिओ ऑफ करा. व्हिडिओ चालू केले की तुमचं स्पीड कमी पडते.
सर
फक्त
माझा
ऑडिओ चालू
व्हिडिओ,
होते रेमंड सर.
माझा ऑडिओ बंद आहे सर. व्हिडिओ बंद आहे.
बरं बरं, ठीक आहे सर. मग आता हा, चालू
घ्या
करा
सर.
सर.
हो
हा.
सर, ओके. Hello participants. We are sorry for this technical glitch. There is some problem with the screen sharing and the bandwidth. So please bear with me. We are going to use GIS and remote sensing to demonstrate how we can use surplus waters during storm surges and during flooding to recharge the Krishna river basin. Okay, you know that water does not fall potentially in different areas of a watershed or in a different areas of the basin, and we will demonstrate to you how remote sensing and GIS is used to mitigate problems of flood and droughts in the Krishna river basins. Next slides. So because of water, previously people used to basically migrate, okay, from one place to another in search of livelihood, in search of agricultural produce, and in search of jobs. Okay, but we know that in the climate change paradigm, we can see that the earth is beginning to get heated because of industrial development and additions of anthropogenic carbon dioxide because of burning of fossil fuel. Take for example this 1859 image of the Rhone Valley in Switzerland. You can see the glacier has come down up to the village. Okay, and in 2001 the glacier was completely gone. Unfortunately, we do not have the animations to show you this, but please remember that the entire glacier in the Himalayas, the entire glaciers in the Alps, okay, and in the Andes and in the Rockies are no more rivers of ice, and they have melted. So even the perennial rivers are basically no more perennial because the ice has melted. Okay, next slide please sir.
एक मिनिट, हा कुठे गेली ते?
Okay, so today we are faced with all sorts of anthropogenic carbon dioxide, okay, additions of carbon dioxide by seeing that today the temperatures are rising and beyond our control, and the rise is supposed to be 1.5 degrees at present, and in the future, basically in the next 2050, which is the landmark year, we find that global warming, the temperatures are supposed to be anomalous and warm, that is up to 3 degrees Celsius, because of which all of the ice in the Himalayas and the alpine belts will melt. Remember, ice is fresh water, and fresh water reserves, they feed the rivers and the riverine system. We are selling people dreams of interlinking of the Ganga and bringing water to Tamil Nadu, but the rivers in the Indo-Gangetic plain itself are deficient of water. Okay, and remember I said at the start of the lecture that water is a state subject. So we must ask who is giving the water and who is willing, which state is willing to share the water. Bihar, for example, is deficient in water. We use waters from the Kosi. So the fresh water that is following on the Indian subcontinent is static. Okay, and we need to understand this paradigm in terms of climate change model. So what is the prediction in the climate change? So if the temperatures exceed, or the earth warms up sufficiently, then all of the ice on the third pole, that is the Himalayas and the Alps, and in the north pole, in the Arctic Sea, and in the Antarctica, will start melting, and the freshwater budgeting of the globe will change. So because of heat, there will be more evapotranspiration. Because of the heat, there will be melting of the ice, thick ice caps in the Arctic and in the Arctic, and there will be increase in sea level. Okay, so many of our areas, for example, Mumbai, okay, has zero elevation above mean sea level, and Mumbai has zero elevation at Kolaba. Okay, so if there is a rise of 1 meter water, then many of our low-lying areas, including countries such as Holland and other places, Kerala, there will be erosion, for example, and Maldives and people in Bangladesh will be displaced. Okay, they obviously will have to go to the neighboring countries. So we have to understand this, and water being a state subject, we have to understand it for each state. Okay, so next slide please, sir. So the climate change model predictions using the IPCC thing is very clear, that in 1880, this is a simulated model, you can see that the heating was in America and some parts of the globe, such as in Mongolia and inner China. So the hot areas are represented by red, and the blue areas are represented by indicates cooler climates. Okay, next slide please. So 1880 we had a lot of blue, and in 2050 we are, remember, we are 2020, another 30 years to go. The doctors will keep most of us alive, okay, for another 30 years. So we will be witnessing this scenario, and you can see the deviation in the annual mean temperatures. Okay, so in 2050, this is the scenario, that not only the land and land areas will be heated. Look at India, for example, look at northern Australia, Africa, look at Brazil, for example, where you can see in South America the temperatures are very high. Okay, and look at the North Pole. The North Pole is the one that shows the maximum increase in temperatures, 2050. Already we are seeing that effect today. There is lot of forest fires in California, in most of the tundra region. Okay, and instead of snow, rain is falling in those regions, and the Arctic is melting. So we are beginning to see the effects of global change. It is true not only on the land, but it is also true in the oceans. So you can see that the oceans, especially in the tropics, is heating up. Okay, and the Arctic is the place where the Arctic will become free of ice. Remember, Greenland, for example, thawed completely of ice last year. Okay, and there are a lot of wildfires in Siberia. Okay, so it appears that what is predicted in 2007 and in subsequent IPCC climate model changes, that is coming true, or at least appears to be true. Okay, so what is our role? How do we contribute to this climate change? My role, for example, is to deliver this lecture and make you aware of how to use GIS. And remember, all of this is remotely sensed data. So already the maps that you are seeing 1850 and 2050 is based on remote sensing and GIS. Okay, so the various data sets go into preparation of this 2050. So in India, we know that the global temperatures in peninsular India will increase. So what is the effect? Next slide, please, sir. The effect is very clearly, we can see that already large heat waves, okay, you can see. Okay, we seen that in Paris last year, where people were on the roads under the waterfalls front of the Eiffel Towers. Sweden, Stockholm. Okay, when I went to Stockholm last year, last year, Bombay was 27 degrees Celsius. I had taken a jacket, and Stockholm was 37 degrees Celsius. So Bombay was 27 and Stockholm was 37. Okay, so this is the issue. The photo of the man that you could see in that presentation was of Jerry Lips. Okay, in the lower left side you can see Jerry Lips pointing out that the glaciers. Okay, Jerry Lips, there is an he's a great explorer and a great biologist, evolutionary biologist from California. Okay, and in his honor they have named one island, Lips Island, in Antarctica. So he happens to be a good friend and comes to Pune regularly. He is pointing out that the glaciers used to come and meet the sea. Now the glaciers have thinned out. There is no glacier, just some ice. Okay, so we know that many places in the world are heating up. Australia, okay, Europe, many places in the Arctic Circle also are heating up, and because of which all of the fresh water that was trapped for millions of years will be released in the ocean. Can we have the next slide, please, sir? So I will finish the lecture within the stipulated time, so nothing to worry about. So what happens if there is a change in the ocean levels, if there is a change in the evapotranspiration? Okay, India is a monsoon climate type of climate, and therefore most of our water vapor comes from the Indian Ocean, Bay of Bengal, and Arabian Sea. So as India gets heated up in the Thar Desert, it produces a low pressure region. Okay, and the high pressure region is in the Indian Ocean, which is full of moisture because of the sun's rays and because of its evapotranspiration. So all of us know that winds move uh, from high pressure zone to low pressure zone. Okay, and therefore we get our monsoon type of climate. Okay, if there is a change in the ocean temperatures, if there is a change in ocean circulation, then not only in the Indian Ocean, even in Atlantic Ocean, you know the phenomenon of La Nina and El Nino. Okay, so these phenomena even in the other oceans affect the monsoon. So it is because India is an agrarian country, and still 13% of the GDP is contributed from agriculture. Therefore, it is a question of food and water security. Okay, and therefore you last year there was a in 2018 and subsequently last year there have been a lot of seminars organized to ensure food security and water security in the changing climate change model, or the changing climate paradigm. Okay, next slide, please. Do not pay attention too much to the problem with the slides. I can see your chats. Okay, just enjoy the lecture and understand what I'm saying. So if there is a change in global climate change, what will be the effect of rainfall on the continents in 2050? So this is the first IPCC. Nimbalkar sir, can you take this slide slightly up so that we can see the no, sir. Down. Yeah, we can see the scale. Exactly right. Thank you. So we can see this map, okay, where there is a change in rainfall. The magenta or blue indicates high rainfall and the red indicates lower rainfall. So you can see very clearly which are the regions in the world where in 2050, if there is a change in the climate, which are areas that will receive less rainfall. Okay, and you can see very clearly in from this map is that it is North America, it is Southern Europe. Hello sir, Nimbalkar sir, slides disat nahi. Yeah. So it is North America, it is the Amazon basin, okay, Mexico, Central America, South America, especially in the Andes, Chile and many parts of Argentina, but also in the forest, Amazon forest. Okay, Bolsonaro is deforesting the Amazon, increasing cultivation of rubber and growth of cattle. Okay, but he does not know in 2015 already with so much of forest there will be excessive droughts in the Amazon. So the people of Brazil will have to face tremendous problems. Okay, Bolsonaro will come and go, prime ministers and presidents come and go in a nation's history. Okay, but they will create problems. You have seen what has happened to the temperatures, yeah, and water resources in the southern European countries. Okay, Portugal, Italy, Turkey, there is a problem. Turkey is trying to be too globally too relevant. Okay, trying to manage everyone's affair, but it is not managing its own water resources. Okay, Turkey is going to be in trouble. Then of course Iran, Afghanistan is a problem. You know what is the problem in Cape Town, South Africa? Okay, so and in Western Australia in the Pilibara area, you can see that there is already droughts. So Western Australia is drought, Northern Australia is excessive rainfall. So there are floods and droughts on the continent. Okay, now this scenario looks to be true. Already signs of trouble you can see. Cape Town 15, 16 days, no water. Let us look at India, our own country. Okay, India, there is no water deficit in 2015. Okay, in fact there is surplus water. Look at Colombo, look at Kerala, look at Karnataka, look at southern Konkan. So these areas show excessive rainfalls. Are we seeing excessive rainfalls from the past 4 or 5 years? Of course we are seeing. And where is the drought axis going? The drought axis is going from Maharashtra into Madhya Pradesh, the Rewa basin, and into Punjab. Okay, so this is what happens if there is a climate change scenario. If Kerala receives 3000 millimeters of rain, it will start receiving 4500 5000 millimeters of rainfall, and all of the latitudes, agroclimatic zones will shift up. That means the deserts such as Rajasthan will start receiving more rainfall. Okay, so आदमियों को, so sorry, I'm sorry because there is a mixed group over here. So I'll stick to English. So people will have to be taught in Rajasthan if there is excess rains, then they will have to move from bajri, from pearl millets, from jowar to rice because excessive rainfall is there. Traditionally, these people harvest all of their rainfall. Okay, Punjab. If Punjab becomes the next drought prone area, God help this country. Already the farmers are on the road. Right? So farmers are saying something, we have to listen to them. What are the scientists is saying, we have to listen. Whatever the thing. So this is unfortunately not the case. Okay, excessive rainfalls in Kerala, excessive rainfalls. So what is the telltale signs? Next slide please, sir. Okay, so you can see this impact. In Kolhapur, it is getting flooded. In Kerala, there are landslides, floods. Next slide, please, sir. I wish we had more times. So, in the climate change regime, Mahabaleshwar is poised to be the world's wettest place. Okay, look at the map over here to the left. You can see that Mahabaleshwar is receiving more rainfall, more and more rainfall than Cherrapunji and Mohsin Ram. Okay, yesterday the Honorable Home Minister has declared that for the Northeast there will be packages and they will grow millions of trees. Okay, trees is one way of catching the rainfall. But what about the climate change model? Okay, so in Western Maharashtra, which is a drought-prone region, we will have excessive rainfall. Okay, if there was time, we would have dealt with these slides more in detail, but I'm just making the points now quickly. Next slide, please, sir. So you can see this comparative. This is Indian Express last year, 1st September. You can see the total rainfall and the pattern of rainfall in Cherrapunji and Mahabaleshwar. Mahabaleshwar for the 6th consecutive year, if it overtakes 11,000 or 5,000 meters of rainfall plus, then you expect that the Koyna River, the Krishna River, will be in peril. Okay, because the carrying capacity of the river, and there will be floods. So last year there was flood. Last year there was significant flood. This year also the national highway, Golden Quadrangle, gets submerged under the river, gets submerged in the flood. So people are not understanding why the floods are occurring, why Sangli, Kolhapur, these areas are in submergence, large parts of the cities. Because you are beginning to see rainfall. Why people are suffering? Why are they landslides? So all the loose soil and the regolith on the hill slopes, they get saturated with water because most of you are engineers, you know what are disasters. So the toe undercutting takes place, the center of gravity shifts, and you get landslides, and people and property die. It puts a tremendous strain on the administration, on the political class. Okay, because we are not taking nature into account. Next slide, please. And to add it, the dams discharge. Okay, the dams discharge because they have to look after the safety, whether it is Mullaparayar in Kerala or whether it is Koyna, or so you find that the dams release the water, okay, when it is raining, and therefore we have flooding in Chiploon and other places, right? So it's a good ploy by the irrigation department also, that when it is raining it releases the water, so people think that it is rain. Okay, so this is how the politics and when Maharashtra releases the water, when Karnataka requires the water, Maharashtra does not release, and when Maharashtra receives excess of flood waters, Karnataka closes its channel. Okay, so this is the problem. There is a politics between states now relating to water. Okay, and so therefore I chose, next slide please, sir. Therefore I chose to come. You can go this. You can just pass through it. Okay. Please go ahead, sir, because there is no time, too much time for us. Yeah. And so this is what we are seeing in Maharashtra today. Excessive rainfall, loose rock soil, rock failure, toe undercutting, and lot of landslides. Okay, so these are very, very good telltale signs for us to realize, okay, now we cannot help it. We did not do enough. At least let us understand this scenario. As earth scientists, as engineers, we have to understand this scenario. So what can be the mitigation measure? You can't stop the rains from falling. You can't stop the landslides everywhere. So what do you do with excess water? Okay, and when Nimbalkar sir invited me for this lecture, I said, well, let us put it in context, today's context, this talk, and how to use GIS, right? So therefore this is the lecture. Next slide please, sir. Yeah, also those who are from society and other people, you will have to realize excessive rainfall, if there is 5,000 millimeters of rainfall falling in Mahabaleshwar, you will have to teach people to deal with it, including food. राजस्थानियों को सिखाना पड़ेगा कि भाई भात खेती कैसा करना, how to grow rice, because that is not their tradition. Their tradition is to पानी आड़वा पानी जिरवा. Okay, stop the war where it is. गांव का पानी गांव में. Okay, this is our psychology in Rajasthan, Gujarat, Maharashtra, Western this thing parts, Bidar in Karnataka, Kerala, Andhra Pradesh, Tamil Nadu. This is what we were facing problems with low rainfall. Okay, so our psyche is to store water. Now suddenly in the paradigm you are saying that no, there will be more rainfall and therefore there will be more runoff. वैसे तो हम लोग ने सब पेड़ पौधे काट दिया है, तो there is no interception, there is no what you call slowing down of the runoff, direct runoff. In our cities we have paved our roads, we have made glass facades. Okay, so urban runoff is very high, urban flood is going to be constantly on the rise. Okay, so we are creating a disaster because we are not listening to Mother Earth, we are not understanding it. Okay, so there will be a lot of demands for the farmers will have to be taught की बाबा या पावसात दुबार पेरणी करावं लागेल. For example, today in this situation is that Maharashtra IMD declared that there will be normal rainfall. Okay, and many places the cell gap or 40% is deficit in many of the districts. Okay, so people have to do resowing. So these are the problems associated with this. And in Kolhapur and this thing, all of the horticulture, all of the vegetable, all of the milk production is affected. Okay, because of excessive rainfall and flooding. So what do we do with our flood waters? Next slide, please, sir. Okay, so we have to understand that we cannot control the rainfall, that development is required, that we will always have cities growing. Okay, agriculture will not become sustainable if there is the vagaries of monsoon. Okay, if there is a climate change, then farmers who traditionally had the knowledge handed over from generations to generations, they knew when to sow. For example, in Maharashtra there is a tradition called as wari. So people would sow their fields, plow their fields, sow their fields, and once the rain starts, then people would go to Pandharpur. Okay, and when they come back, the saplings will start growing. Okay, so then they can harrow it and they can de-weed that thing. But today the situation is that neither the wari could happen nor they have to do sowing again. Okay, so it reflects on the cultures also. Okay, next slide please. So we have to understand the hydrogeological cycle, and what better than remote sensing. Okay, so in remote sensing we use different direct and indirect methods. Okay, normally it is in the visible spectrum, okay, or it is in the near visible spectrum. So basically using the properties of electromagnetic radiations, we use the sun, or we use x-rays for example, or we use other rays to sense the surface of the earth. Next slide please. So in Nimbalkar sir, next slide please. So in remote sensing, we make direct observations, or we use aerial photographs, or we use satellite imagery. Remember, India is a giant in terms of remote sensing. They have many satellites. Most of them are weather and telecommunication satellites, but others are basically Earth observation system satellites. And therefore, we have a large array of satellites that give us remotely sensed data. Okay, and they are of very good quality, very good high resolution. So using the elements of remote sensing, such as tone. What is the tone? It's basically the darkness. Okay, so if there is a black object, it will look dark. If it is a light object, it will look faint. Okay, so like that is the tone. Just the skin tone. Okay, various shades of skin color, like that you get. So certain objects are always salt, for example. If there is a salt plan, it will be bright. Okay, and water is always black because water absorbs all radiation. So on remote sensing products it looks dark. Texture, so all of these things which I was supposed to explain, we use remote sensing using patterns. So there is, for example, if you see the Qutub Minar, okay, then the image will show Qutub Minar as a vertical pillar, but the associated pattern will be that if the sun angle is low, the shadow will be of the Qutub Minar on the buildings. Okay, so you use direct and indirect observations to detect. Okay, so suppose if there is fields, okay, and then there is gara, there is hailstorm. Okay, so what will happen? The hail will hit the plants. Okay, and what will happen? The leaves will get damaged. Okay, and chlorophyll is active to near infrared. Okay, so what happens? The healthy leaf will have a different signature, and the ones that are damaged by the hail or smashed by the hail, the chlorophyll will die, the mitochondria will die, and therefore the leaf is not healthy. So it will give a different pattern. So you can assess using remote sensing how much is the damage to the crop, okay, in the near infrared. Okay, for those who come from remote sensing background, we call that index as, there are several index, I'm just naming one. It is called as NDVI, okay, vegetation index. Okay, so this is the, that means various plants, various trees will give different signatures, spectral signatures. Okay, and they can be identified and quantified. How much area is forested by natural forest and how much is coming from eucalyptus, even that can be distinguished using remote sensing. Next slide please, sir. Okay, so this is how this is all that I wanted to say, and it is over here. They can be active and passive. Most of the time it is passive, that means we use the energy of the sun to produce remote sensing products. Next slide please, sir. So these are several tools that we use. We can do the terrain mapping from radar, or we can do remote sensing from many things and integrate it with GIS to solve our problems, mitigate our problems. In this case, we want to do it in the Krishna River basin, showing how much, how the flood waters that are creating flooding and damaging, where they can be used to store underground in the groundwater, to keep it as groundwater so that we can use it in the future, thereby mitigating the flood and thereby increasing the water table for future use. Next please, sir. Yeah, so you can skip this one. I have already spoken that Indian remote sensing satellites. So this is an example where you can see the tone and the textures. So here you can see the rougher the, so these are volcanic cones, and you get the rough ones are younger lavas because they are mostly full of surface roughness, therefore they give a black tone, while the ash coming out from the volcano, it falls down, it is fine grained, therefore you can see that it is basically light colored. Okay, to the south east of this image you can see it is light colored, while the fresh lava is, so this is an example of tone. I wanted to use it while defining over there, but we can skip these slides and go directly to the Krishna basin. Yeah sir, so these are, now you can stop over here. So this is the visible spectrum. Okay, you can see a part of this, the volcano is towards the north of this image, to the top of that image, and you can see that again there is a sub recent lava flow, and because of which it's fresh and it is full of blocks, and therefore it is turned black. Okay, the remaining thing you can see over here in the visible light, you can see farmlands actually. Can you see the farmlands? You can see the pattern of the farms. Okay, there are different tones of the farmland. So you can see some farmlands. I do not know whether you can see the arrow that I'm pointing out, but you can see where there it is written tuff and revert volcanic material. There the farm is barren. There is no plantation. There is no crop growing over there. But below the sub recent lava, you can see that the farmlands is gray in color, darker in tone, and that means there is some cropping going on there. Even on the top, you can see that some of the triangular farmlands have basically crops in them because their color is slightly gray. Okay, so it means that there is no river over here, there is no water. It means that how is the crop growing? It can grow from rainwater. Good. But if you take this same scene, as we call it, into the next scene, which is in infrared, next slide please, sir, then you can see clearly. Okay, this is a false color composite. You can see clearly the farmlands, and you can see where the moisture is. Okay, so the red over here, it should have been black, but we have added false color to this. So there you can see there is moisture. Okay, so now you can see the moisture is in the streams. Okay, there are to the stream to the left, to the right, you can see where the moisture is. Okay, so the moisture is towards the north in the stream, then it becomes dry. Again, there is a patch of stream where there is red, that is the moisture is there. Okay, and you can see one small dot over there, that is a dug well. Okay, so that is a dug well. So people have made wells over there, and the tuff that was there is been removed and put across, so it is scattering light, and therefore that there is a bright spot over there. Okay, and the water is given to the field right at the bottom. You get a square where there is crops growing. Okay, so the trees are full of moisture, so you can see that irrigation is going on where there is a confluence of the two streams. Okay, so this is how you can. So otherwise people previously, the same military application is there, people would put a camouflage, cut trees and put it on the tanks and think that not visible. Okay, but in infrared, the leaves are dried and dead, so they will not give the camouflage, they will not be red. Okay, and the tank can be seen clearly in infrared. Okay, so groundwater can also be seen. So these are the two examples that I will give for remote sensing. Let us go fast now. Yeah, so we come to the Deccan traps. You can see that even for those who are geographers and other people on your engineers who will know this, that when two satellites um, uh, have remote sensing project on the same area, then they will produce ortho images, and ortho images are three-dimensional. Okay, just like 3D films. Okay, you have a red and a blue spectacles, and it gives you a 3D vision. So like that, when two satellites intersect and take the photograph of the same area with an overlap, then it will become three-dimensional. Okay, and based on that principle, we get elevations. Okay, and this is the DM produced of the Krishna Valley Basin. Okay, produced from satellite imagery. So this is the digital elevation model. Okay, and using, next slide please, sir. And using remote sensing, we will produce the fracture map of that area like this. So all these lines are lineaments. Okay, lineaments are nothing but fractures and faults. Okay, so rivers, for example, we know that the Tapi and the Narmada rivers flow to the west. Why do they flow to the west? It is not because the slope is towards the west, is because at Amarkantak the river starts flowing and joins the Tapi lineament. Okay, and the lineament is basically an ancient fault. Okay, so the river is flowing through the fault, and that's why rather than water going from Amarkantak directly to the Bay of Bengal, it flows towards the west. Okay, same way with Tapi river. So if you look at the Krishna river also, the Krishna river is controlled by by fractures. Okay, and you can use remote sensing to identify these fractures. Okay, remember, fractures can store water and they can transmit water. So if you want to store water, groundwater, then it is better to put it in the fracture. For example, the Jayakwadi dam is a very good engineering stunt. Okay, but what is there? There is no water in the Jayakwadi. Why? Because the Godavari, mighty Godavari, brings all of the water to Jayakwadi, but the Jayakwadi dam is on a fracture, and so instead of storing the water all of the water from the Jayakwadi drains into the fracture, and therefore there is no water in the Jayakwadi. Okay, so we have to, all engineers know that we have to grout those fractures, but it is, everyone knows that all fractures cannot be grouted. Okay, and therefore there is a leaking this thing. So we have to identify fractures. Next, please. Yeah, so this is the Koyna area, okay, where the Krishna basin starts. So you can see the Koyna dam. Okay, in the small inside you can see the water in the visible one, and then you see the dam, and then you can see a straight line. Okay, even the backwaters of the reservoir is in a straight line. That is because it is in a fracture. Okay, and there is a hypothesis that water from the Koyna dam leaks into the ground, goes into the ground, and then that is because of which there is a rise, reservoir induced seismicity. So you can see over here that the Koyna river flows along a straight course and then bends, okay, because of intersection of two fractures. Okay, so north south fracture and then northwest southeast fracture. Okay, that intersection is related to Koyna. So you can identify lineaments like this. Next slide, please, sir. So rivers normally flow in fractures. This is from Kundalika. You can see that the river normally on the top, which is represented by the black line, is showing meandering. That means it shows like a snake, serpentine movement. Okay, very smooth river. But when it comes down towards the left of the photograph, you can see the straight river courses. Okay, and then it bends at 90 degrees, again bends, and then comes down back. So at, 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 at one end, so most of the fractures control the river drainages, right? So you can store water in the river. Our rivers go dry in Peninsular India because most of them are fracture controlled and the water leaks into the subsurface. Next slide, please, sir. I'm sorry I'm rushing through this, but it is better that we do this. So this is the images of dikes. So you know fractures are there in the earth. If the fractures go down into the 40 kilometers or 30 kilometers and they tap the magmatic chamber, then the magma rises along these fractures and it comes up. Okay, and when it comes up, it gives rise to volcanism. So in Nandurbar you can see uh, hundreds of fractures and hundreds of dikes coming up. Okay, so all these lines that you see like a railway line is basically dikes. Okay, and the engineers, what they have done, because the dikes are impervious to water in majority of the cases, they have made small minor irrigation tanks on it. So all those black reservoirs, they have just built small walls and they have stored the water, right? So remote sensing can help you make sites like that. So wherever the stream intersects the dike, and if the dike is impervious, then 20 meters of earth bund or this thing will store the water, surface water. But if there are fractures, such as there are many fractures over here, if you look at the green parts of this image, then the fractures, the dikes are almost east west. Okay, but the fractures over here are north west southeast. Okay, so the green, so the streams flow in the northwest southeast direction, represented by green farms there, and the dikes are east west. So the dikes are used to store water, okay, and form small minor irrigation tanks, while the fractures actually recharge the groundwater. Okay, let's go fast now. Yeah, so you know that the Krishna River Basin, most of the Krishna River Basin in Maharashtra, Karnataka, and Andhra, and of course Telangana now some parts, it comes in the low rainfall zone. Okay, traditionally on the left you can see that the basin is in the low rainfall drought prone areas of the basin. Okay, and on the right you can see the Krishna Basin depicted by blue. Next slide, please, sir. Yeah, you can skip the slide. Please go ahead. Yeah, we will do this in 10-15 minutes. Please bear with me for the speed at which we are doing this. Sir, Nimbalkar sir, how much time we have? Okay, doesn't matter. I'll just continue with my thing. So this is the Krishna River Basin. Okay, the first basin that you see on the Krishna River Basin to the north.
4:30.
4:30. Okay, sir. I have 15 minutes, so I'll do this in 15 minutes. So we have the Bhima Basin over there. Okay, on top, which is including the city of Pune, where this course is taking place, and you can see the Ujni backwaters over there. Okay, so parts of Maharashtra, you know that the Krishna Basin originates um, in the Bhima River, for example, which joins the Krishna. It's a major territory. It originates at Bhima Shankar, one of the 12 Jyotirlings places. Okay, so it originates there, right up over there, and then flows in the south west direction. Okay, so and then of course you know that the Ghataprabha and other basins originate in the Karnataka area, in the Western Ghats, and they flow down and join the Bhima. Okay, and of course you know that the Koina starts at Mahabaleshwar. Okay, and joins to form the mighty Krishna rivers. So these are the sub basin maps. We have done this in GIS. Okay, you can see the lat and long over here. So what we do is buy the basin maps and digitize them, or we get basin maps digitized already from Central Water Commission, and then this is the basic unit. Okay, so the basin, river basin is there. There are sub basins, and then the sub basins can be divided into watersheds. Okay, so the Krishna basin is truly a transgressive basin, and there is a tribunal, okay, set up for Krishna water sharing between Maharashtra, um, Karnataka, Andhra Pradesh, and of course Telangana. Okay, so this is the first thing we do is to get the basin map, okay, and transfer it onto a GIS platform. Okay, so this is map number 1. Next slide, please, sir. Okay, then what we do is we take a digital elevation model, because water flows from higher regions to lower regions. Okay, so we download this. These are freely available. Here we have used the Aster DEM, okay, with 30 meters control interval, and we have produced, because this is a large area, we have produced a digital image mapping. So what we do is we take the image, we take a bound of that, and we geo-rectify it. Okay, and then we start imposing one layer over the other. So we have the river basin map, and then we intersect it with the elevation map. Okay, so this is taken from the after image. Okay, so this area can be now divided into hilly areas. Runoff will be excessive if there is rainfall. Then the plateau areas depicted over here by blue. Okay, so the hilly areas are depicted from brown to say green, and the blue areas are the flat plateau areas, and then the plains are in purple and magenta, and the coastal lowlands are in light blue. Okay, so now you have a physiographic division. Okay, in the coastal areas there can be more flooding. In the plateaus you can store water, you can collect the water in the hilly areas. So that is the idea. This is how you integrate the data sets. Next slide, please, sir. Okay, so this is the flow chart that we are using. That means the what are the sources. Okay, we use the Survey of India topo sheet, we use the SRTM data, we use the land use land pattern, for example, from the remote sensing. Okay, so we must know, because water use hota hai. If there is a forest area, then there is almost negligible use, so they sinks for water. But if it is agricultural land, then both surface water, and so we must know the land use land cover pattern. Okay, like that we have 7 or 8 layers that we create, and then we integrate it on a GIS platform. Okay, for many of you may be knowing GIS, so I'm not going to do this. We have to complete the talk in 10 minutes, but this is the flow chart that we use. Okay, so the data that we use is very important. The first 7 layers that we have used over here. So I will show you the layers subsequently. Let's go, sir. Next. Yeah, so this is the geology, because what the groundwater is directly dependent upon the geology. Okay, the green areas are of Deccan basalt. Okay, these are good ballast stones, but they are very poor in in storing waters. Okay, so they have something like 2 to 5% porosity, so only 2 to 5% of the rainfall can be stored. Very difficult. Okay, not all rainfall can be stored, only 2 to 5% of rainfall can be stored in these green rocks. Then the pink is basically the metamorphic gneisses, very old gneisses. They have fractures and you can store a very little water in that. So the geology, so in the basalts you have high runoff and low storativity. Okay, the water can be stored where there is yellow sediments. Okay, but the water in the coast you cannot store because it is basically influenced by salt water intrusion. So only those areas that are, and based on these criteria, what we do, we give ranking. Okay, so the yellow will get 8 points, the pink will get say 5 points depending upon its hydrological properties. Okay, and these maps are then given a ranking. Okay, and then we keep adding the rankings. Next slide please, sir. So the best rock on that was the yellow. Next slide please, sir. This is the quantification. Okay, rainfall, then we collect the rainfall from IMD, and we plot the rainfall versus, and we can collect the groundwater levels. Okay, central groundwater board and state groundwater boards. In case of Maharashtra it is groundwater survey development or the PWD. In many places Andhra Pradesh has state groundwater board, and PWD collects, I think so, in 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 Karnataka. Okay, but all of that data is always available with central government water. So the rainfall comes from IMD, and the water comes from the state groundwater departments. So go ahead, sir. Go down, sir, please. Yeah. So this is how we measure. Okay. So there will be in deep water levels, we put the tape and measure the water levels. Okay. And we record the water levels. Okay, so this is done 4 times a year, that is pre-monsoon, monsoon and post-monsoon. Okay, and sometimes in May, the end of it. Go ahead, sir, please. Next slide, please. Yeah, so based on this, we can't see this slide, so just go ahead. Yeah, so that was declining. Go ahead, please, sir. Go, sir. Yeah, go ahead. Okay, so this is the problem when you convert to PPS. Okay, so here is the annual hydro that we get. That means January to May, if we have a piezometer, that is automatic water level record, then monthly rainfall and monthly water levels are taken. Okay, so you can see what happens in natural systems. During the summer, the water table falls down to the maximum. Okay, so summer water table is depicted in red in the small diagram over there, and after the rains, the water level gets charged, okay, in unconfined aquifers, and it rises up. So we have winter water table. Okay, you can see this, people know how much it is. So between the summer and the winter, it is the depth to it is the water table fluctuation. That means rainfall only recharges the difference between summer water table and winter water table. Okay, so that is the fluctuation of the water level. And depth to water table means from surface, from the ground level to the summer water table. So this is the depth to water level. So based on this we produce maps. Okay, next slide please. So this is the depth to water table map. You can see I am just depicting here May 1999. Okay, so deep water tables are in brown or in red or magenta, whatever you can see. So in Maharashtra, you can see only in Sangli, for example, there is deep water tables. Otherwise, there are shallow water tables. Okay, but in Karnataka, you can find, and Andhra Pradesh, you can find very deep water tables. Okay, this is May recording, summer water table 1999. Okay, and in summer also you find shallow water table in 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 the coastal areas. Next slide please, sir. So this is May 99. When you compare it to the other year 2005, you find that in 2005, because the rainfall was low, you find that even in Maharashtra during May you find water table going down. Okay, and a lot of areas in Sangli, in other places adjacent to Karnataka, you find there are deeper water table. Okay, so this deep water table could be the areas for artificial recharge. Okay, next slide please, sir. So this is again depth to water table. So how deep is the water table from the ground? So you can see that there are, in May 2005 you get only one spot of deep water table, okay, here in the center of the basin, and it is close to the stream, so you can target your recharge in this area, okay, or in this area. But in Maharashtra, for example, to the north there is a deep recharge over there, but there is no stream, so you can know where to recharge your water table. Next please. So excessive flood waters that will come in June, for that year you will know where to you can recharge. So the same spot is there in May 2009. Even today, when we see the water tables, it is that mining area where there is greater water. So you identify your areas within a district, within a basin, where to recharge water table. Okay, this can be done by integrating all data sets. Okay, so go ahead please. So this is the depth to water table, then the water table fluctuation. You want to know how much water you can store. Surplus water you have to further release. So therefore you do it for the water table. Each well can be used to recharge, but only that much that it can take. More than that water it will not take. Once the aquifer is saturated, there will be no more rainfall. Okay, no more recharge. Okay, then it will go as rejected recharge and it will start surface flow. So we want to see how much water you can store. Okay, so this is very important, water table fluctuations. Okay, so you can see here only 2 meters, 3 meters, 4 meters. Okay, that is the maximum you can store in most of the dug wells. Next please, sir. Go ahead. Yeah, so here you can see that that the areas keep changing. Okay, and therefore you can use GIS for dynamic monitoring. Okay, once you recharge one area, that area will become useless for recharging again. It will come handy again next year, but not in the same year. Next slide please, sir. So this is all done on GIS. Okay, water fluctuation levels again, please go ahead, sir. Just show these maps now because we have only 3 minutes. Okay, water table fluctuation. So all these basic maps that I showed you. Next slide please, sir. Okay, all of these are put upon one another. Please hold this slide, sir. And now using summing up all of them and intersecting these maps, giving them the values and then intersecting the maps, you get the groundwater potential map. This is our aim. So where are the waters always available for recharge? Okay, so here you can see very well. If you start through the north, then you can see in the Bhima basin. Okay, in the Shirur Taluka there is the first spot. So in Shirur Taluka you can make a dam across the river. Okay, and then there you can do the artificial recharge. Similarly, you can do it on the Nira. Okay, in Purandar or in Satara at the boundary. Okay, and then many places in central. Okay, in central Karnataka there are many places that show the red spots. Okay, including Kolar. Okay, so the Kolar gold mine, which is the deepest mine on earth, more than 2 kilometers, people have gone looking for gold. It no more produces gold, and so because of this big hole in the ground, all of the water goes into the earth, and therefore all of the excessive rainfall that you see over here in Maharashtra and this thing can be used and channelized. Okay, this requires political will, it requires knowledge. Okay, simply do not recharge anywhere. So this is the groundwater potential map between 1999 and 2005. It is almost the same even now. So the lands that are in this area in Karnataka can be used. Remember, the flood waters in Maharashtra are released to Karnataka. Karnataka is suffering because the waters are released. Simply saying that Maharashtra is releasing water and making a political thing of it, or Karnataka does not want to share water with Tamil Nadu or with Andhra Pradesh. Here is an opportunity for Karnataka to actually recharge its own basin with excessive flood waters. Okay, because its geology and hydrogeology is very, very significant. There are high recharge potentials in Karnataka, very low potential in but very high potential there is no potential in the Krishna basin in Andhra Pradesh or in southern the Karnataka, but in the central and northern parts there is a high recharge potential, and therefore the national policy integrating basin wise recharge is advocated by us. So you can put remote sensing and GIS to know exactly. Okay, and remember, you don't want a research potential away from the river, because you will have to make pipeline, then uska maintenance aega, that is all useless. So wherever the river is in close proximity, those stretches could be used for artificial recharge. Okay, Bidar, Gulbarga, Solapur. Okay, of course Solapur is okay. All of these areas, Umarga, okay, Kolar, these are the areas where you can use. So GIS is telling you that look, don't get scared if there is excess rainfalls. Nature is providing you areas where there is depleted water table. Okay, you become the medium to harvest that, reduce the flood, reduce the surface runoff, and recharge. That water can be used by the next generation because it will be very deep recharge. Okay, 120 meters, 130 meters. Okay, next slide please, sir. Okay, so this is groundwater potential maps. Okay, you see the dynamic natures. Okay, so you can have a time series, and you can overlap the time series maps. Okay, because it is a function of the rainfall, it is the function of water use. Suppose if people use more water that year because the rainfall is low, then the groundwater potential reduces further. Okay, so it's a dynamic system. Okay, next slide please, sir. So just making the map once does not work. GIS does has this potential. Okay, so then we talk about recharge potential. See, now the recharge potential based on different maps are very, very limited. Okay, and therefore all of the efforts, those district collectors only. नहीं तो क्या होता है, पानी आड़वा पानी जेड़वा, all the collectors are doing the same thing. Whether there is a need, whether there is no need, simply it becomes a government scheme. There is some incentives given, and no results come out of it. So GIS, geology, hydrogeology, engineering geology, all taken and put onto a geographic information system platform using remote sensing, using GIS. Pre-existing data can always target where to recharge, okay, and mitigate floods. Next slide please, sir. Yeah, so this is the recharge potentials. Okay, so where the recharge potential is high, based on the rock, the recharge potential is high in river alluvium and sands, then in Gondwana sediments, and in the Kaladgis. You see there is low recharge potential in hard rock terrain. There is no recharge potential. So along the river, whatever alluvium is there, in those wells you should attempt recharge. Okay, so I am sorry for going very fast through this. Next slide please, sir. Yeah, so this is the interventions. Maharashtra has done this, Karnataka is doing this. Okay, how do you reduce runoff, and how do you increase recharge? So these are the area treatments in form of contour bunds. Okay, but they increase only soil water moisture. Okay, then actually you should have these bandaras. Okay, Shetala are very famous, but that is for agriculture. Okay, and then excess of waters, you should filter, of course, not use the clay rich waters, because the clay rich water contains sediments and clays, and they will go and clog the aquifers. So in the sea we have shown that this is the well in Needhal, which is a watershed developed by Chandrakant Dalvi, who was Commissioner Pune, his own village. Okay, these are photographs from there. You can see that an IS officer, how he has converted his own village from where he grew up into this beautiful water conservation. And we have many examples in Maharashtra like that. So you can see in the sea how the pipes are used to siphon off water from the bandaras, filtered and then released into the dug wells with fractures, so that the water level can rise, as you can see in D. Okay, this is summer. In the summer you can see people wearing caps, so it is hot, it is in summer. The water level is near GL, 1 meter. Okay, this is from Nidhar in Satara district. Okay, next slide please, sir. And of course in urban areas we should do this rooftop rainwater harvesting and dug well flooding. Okay, Maharashtra has done a very good example. I know Andhra Pradesh, in Hyderabad, many places it is being done. Bangalore it is being done. For example, you can see in A and B, you can see A, B and C are from my own organization, Groundwater Survey and Development Area, in headquarters in Shivaji Nagar, Pune. The whole building is harvesting the rainwater, and that water is sent to a series of filters and then recharging the borewell. Because of this recharge, the slums in Shivaji Nagar area and what you call the hand making paper factory, there is recharge. Okay, so you can have other concepts. Last slide, sir. You can have other concepts such as grain gardens and of course the old quarries in the cities or in they look very bad. Okay, they are dumping sites for, so they can be converted into rain gardens and rainwater harvesting structures. It has been done in Pune. If you ever visit, so you visit groundwater surveys and development, it is in the agricultural college campus, and close to that is the Lakaki Lake. Okay, this is developed by the people, okay, by Kirloskars and by the people around that area. The quarry has been converted into a beautiful garden where the quarry actually recharges the groundwater. Okay, so we did this study for ICAR, that is National Rainfront. This is available on their website, and therefore I am giving you this report because you can read this report in detail. Okay, it is available on their website. Okay, so this is this is made for the Planning Commission, and accordingly we have said that river basins should be targeted for recharge, and not, it should not be district wise. Okay, so you can see this on the website. You can download this whole report. All of the images are there. I have shared my presentation with Sir Nimbalkar sir. Nimbalkar sir, this is free. You can circulate it among the participants. I'm sorry for the electronic mishap that we had today. We should have had more time, and sufficient time sir has given for us to make this presentation. Thank you very much.
Uh, okay, sir. Can you hear me, sir?
Yes, sir. Yes, sir.
Okay, so on behalf of all the participants and our institute, I thank Durai Swami sir for giving presentation on ground recharge, water recharge, and application of remote sensing and GIS for it. So thank you, sir. Thank you
very much, sir.
Okay.
Thank you, participants. All the best.
Okay. See, for participants, tomorrow we will have a session at 9:30. Please join at 9:30. A link will be sent to you today evening. Okay. Okay, sir. Durai Swami, sir.
आणखी काय माहिती हवी